Testing, testing. Perfect. Welcome, everyone, to the Decentralized Science Conference 2024. Barrett and I have been working very hard on this, and it's an absolute pleasure to see everyone here ready to learn some more things about DeSci, to connect with people. And so I've just got to give a couple housekeeping statements before we get going. The exits for this room, 2 at the back, 2 at the front. And if there is, in the very unlikely chance of a fire, the spot where you go is just outside of Imperial on Exhibition Road. Also, we're going to be opening a second workshop room, and that is going to be on the 6th floor. And that will be at 1:30. We'll give a separate, 1:20. We'll give a separate announcement about that. But I would also just like to thank everyone from Imperial, the Imperial Grad Bio team, for allowing this event to take place. It's been a labor of love. And I'm going to hand over to Barrett now for a couple of words as well.
Cool, thank you. I just wanted to give thanks to the sponsors that are displayed here. Normally when I go to an event and they talk about sponsors, I roll my eyes, I don't care, blah, blah, blah. But we didn't charge ticket prices, the lunch is free, the after party, blah, 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 everything. Wouldn't have been possible without the sponsors. So literally we wouldn't be able to do this event without them. So if you do see anyone from any of these teams, please reach out and say thank you. And it's actually a genuine thank you, not a yes. So, yeah.
And now to hand over to the wonderful Fiona Michelle. She will be your mistress of ceremonies. Sorry, Madame of Ceremonies. Thank you very much.
Thank you, Alfie. Hi, everyone. Morning. I gotta say that it's pretty impressive that people roll through on a Saturday. It shows the commitment and just dedication to this room. So y'all are badass. I'm gonna kick things off very, very quickly because we have no time to lose with some fundamental concepts, which God knows I need. So without further ado, please welcome to the stage Aaron McGinnis and Jocelyn Pearl. What is DeSci? What is blockchain? And what is a DAO?
Morning, everyone. Can everyone hear me? Awesome. Welcome to DeSci London. Woo! I'm so excited to be here. This is one of my very first in-person DeSci events, which is crazy to say, but I am here because I knew Alfie and Barrett and all of the organizers were going to do an amazing job putting together this meeting for us. And already it's kicked off with some impromptu meetings last night. It's been great to meet a number of you in person for the first time. And I'm just excited for the collaborations that are going to form here and the work we're going to do together to make science better. So thank you all for being here, and thank you to our organizers.
Yes, very much want to reiterate how exciting this space is and how wonderful it is that each one of us are able to be here right now. As I'm looking around the room, I know I see a few familiar faces and lots of new ones, and there are some really incredible people here. With that, we'd love to ask, who are you? Maybe just round of applause, since it's a little dark, of if you have a scientific background. Just cheer a little bit. Okay. How about more of like a technical, maybe blockchain experience, maybe more on the developer side? Applause if you're coming from that angle. All right. Some people, not quite as many. How many people are actively working in DeSci right now? Wonderful, wonderful. So lots of really cool perspectives coming into the space, and I'm excited personally to get to know some more of you as well. Ultimately, many of us might be here right now because science is broken. and we might have experienced that firsthand. And the reason we're here is because we know we can do something about it. And we're excited by those possibilities and the possibility to kind of rewrite or update some of that baseline infrastructure to improve some of the processes or systems that exist right now in science. And this is building off of a couple different disappointing trends happening right now. One of which is that science is becoming less innovative over time. And this has a negative effect on each of us if we're working in the space, as well as the world at large. These innovations are things that can have positive impact on each one of our lives, but as we're seeing in this chart above, that's decreasing over time. All of these incredible abilities and just brain power isn't being able to express itself in the ways that it was maybe once before. And that can be due to a wide variety of reasons, some of which being a bit more centralization of funding, of just different coordination, not allowing for this wider spread exploration of science and experimentation. And that's really where decentralization and DeSci can come into play. Kind of open these doors back up into what could scientific innovation look like now, especially with all of these new technologies, this new knowledge, this new ability to collaborate across the world in meaningful and powerful ways. Another trend is we have a lot of incredibly talented people leaving the space, with 50% of scientists leaving that field within 5 years. This exodus of talent from that scientific researcher perspective, and also on the medical provider side of things, can have this really negative impact, once again, on each of our own lives, as well as the spaces we work in too. However, if there are new ways to work in a decentralized type of way, maybe in a part-time capacity and still contribute those different expertise and background and knowledge, we might be able to tap into that, leverage it, and allow that knowledge and background to blossom in new, powerful ways. That's part of why we're here right now at DeSci London.
Yeah, and to touch on that, one of the ways I like to describe the current system is as having these two silos of academia and industrial science. And we can observe through how our money is spent traditionally across these systems as going into these kind of canonical workflows that are pushing people and incentivizing people towards specific outcomes. So within industry, we see people incentivized to generate progress through patents and IP and hold on to their technologies, hold them close to their chest, what I call the black box of biotech. And within academia, people are incentivized to publish their research in traditional academic journals, places like Science and Nature and Cell, and that's kind of what leads you up your career path. And so I think one of the promises of DeSci or decentralized science is that if there was a secret third thing or another way of funding science and of incentivizing science and scientists, that we might see a blossoming of progress in different ways than what we get out of these two canonical systems.
Ultimately, DeSci is here to do something about it. And that's why we're all here pushing this movement forward. And just like the internet was this kind of platform for opportunity to blossom up out of all these different apps, all these websites, different technologies that we use every single day. The same way Web3 is doing that. Blockchains, being able to blossom up these different dApps and protocols, allowing for new ways to engage. DeSci is doing the same type of thing for science, allowing all of these new organizations and technologies to be able to keep moving science forward. It's a platform for opportunity. And right now, it's categorized, at least in my head, there are many different ways to categorize it, into 3 main categories. One being technical infrastructure, so a lot of really incredible work, which we'll be able to hear a bit this weekend about as well, on the publishing side of things, then also on the data side, collection, management, transparency, storage, access, all of that. Second category is funding, and a lot of this is facilitated through these different bio-DAOs, focused on funding research or maybe startup exploration in specific categories. And then a third kind of cluster around community building, education, awareness, convening, lots of incredible events such as this one happening all over the world, with many more scheduled out the rest of this year. So if you have a good time here, definitely check those out as well. And there's really incredible communities blossoming up all over the place. And as we kind of navigate throughout the rest of this weekend, we'll be able to hear a lot more in depth on each of these topics.
And as Aaron mentioned, there isn't one way to categorize the space. I think as humans, we naturally seek out patterns and ways of lumping things together. But I think one of the promises of DeSci is that we're thinking differently about technology and our collaboration networks and how to change science for the better. So I want to come back to kind of the ethos of Web3 a little bit and some of the values that are inherent in this movement, especially for folks who might be new to the space. Chris Dixon wrote a great synopsis of this promise of Web3 with his read, write, own theory. And I think one of my favorite descriptions of this is that it's what the internet promised but didn't deliver on. So when we think of a number of, the biggest companies that have come out of the internet, the biggest names we know, they're highly centralized, they control a lot of the pie. And I think what is exciting for many people working in Web3 is the idea that more of the contributors, more of the creators, more of the scientists could collectively own their own information and their own knowledge and benefit from sharing that with others. Something that I like to call scientists as a creator class. And so, these are just some of the ideas that Web3 has been putting forward. And to put a name on a few of the other principles here, a number of people working in this space really care about building in public, working in public, sharing their ideas and their process so that others can learn from them. Nadia Egbal wrote a great book that I highly recommend called Working in Public that's all about the open source software movement and has been a great inspiration for those of us working on DAOs and working on DeSci as far as how to collaborate through these open source networks online. A lot of people working within this space are highly collaborative. They care about shared ownership. They care about decentralization and democratization of information. And so one of my favorite takeaways from the Cabin DAO founder actually is that if blockchain were to disappear tomorrow, we would still be left with this value system that we care so much about. And I think that's a great point to make for what we're trying to accomplish here. We're using blockchain technology to try to advance the thinking behind how science is shared, how science is owned, and who gets to access that, right? Do patients get to participate in their own research? In a number of ways, the current biotech and pharma industry don't allow for enough of patient contributions. And so I think a number of people that are here today are working on that problem. So another concept we want to introduce is the DAO. And I know the audience, it sounds like, primarily are familiar with DAOs and DeSci, but for those who are new to this concept, a DAO is a decentralized autonomous organization. It was actually a protocol that was initially described in the Ethereum white paper. And the way this functions is essentially as online communities. There's many different flavors and versions of DAOs out there, and some of them achieve decentralization to different degrees. They're all run by people, and people are inherently flawed, and so they're not always successful at what they set out to do. But I think the bottom line of why DAOs are exciting for science is that it lowers the barrier of entry for participation. And that's really exciting to me and to other people. So for any given organization that you see here that's sponsoring this event, I can almost guarantee you can go to their website. Here I'm showing you Cerebrum DAO's website, and you can find some kind of community button. And if you click into that, you'll see that they often have a Discord link. And so anyone can join this community and start interacting with the folks that are participating in this DAO. So for Cerebrum DAO, they're working on neuroscience research and how to achieve a healthy brain. They also have a button for applying to a working group. And this is, again, true for almost every organization you see on this poster. So the barrier to entry is very low. You can join, you can participate if you have a background in investment, if you have a background in science, or any other type of background. You might be a high school person interested in science. You might be an undergraduate researcher. I think that's one of the most exciting aspects of the space is that you actually get to interact with people across the board, across time zones, and that's one of the really beautiful things about this space. So I encourage you, if you're interested in any of the talks you hear over the course of the next 2 days, any of the groups you talk to, join their communities and start interacting with people within these spaces.
And ultimately, the organizations that you'll hear from this weekend, it's been an evolution of how DeSci has kind of continued to grow over the past couple years. We've both been in the space for a couple of years now, and Jocelyn has done this amazing job of creating the DeSci landscape map to really help us understand this evolution. And this was one of the first snapshots, if you'd like to dive in.
Yeah, so we put this together all the way back in 2022, 2 years ago, and the space has moved so quickly. At the time, I was really trying to understand who all was working in the space. I wanted to talk to every single person that was working on a project. And so we started to categorize these things as far as DAOs, organizations like I just talked about that were working on scientific problems, decentralized biotech, so people trying to do drug development using these new decentralized technologies. People trying to disrupt scientific publishing. There are a number of people working on this, and I was really excited by some of the ideas there, and I'm still really excited to see some of that work move forward and to hear from some of the folks like Bianca, who put out a paper on ants review very early on. So, I can't emphasize enough how frustrating it is as a scientist to see how many times you click on a PDF for a paper and it says it's behind a paywall. It's ridiculous that this is currently the state that we live in. I just, it bothers me so much. And likewise, there were a lot of people interested in funding science. That was something that drew me in because scientific funding is waning, and a lot of these things never make it out of the lab. They never make it out into the broader knowledge sphere because they're just not well funded, and that's a huge problem. And since 2022, the space has grown immensely. So this was an update we did to the landscape about 6 months after that. And so many new organizations had come into the space, a lot of new bio DAOs, much of that work funded and supported by Molecule, which created this beautiful ecosystem for bio DAOs. A number of new projects working on the scientific publishing aspect, and kind of across the board. And I like to highlight are open science collaborators. There's a ton of online communities that support open science. They support homegrown science, DIY Bio, Center for Open Science, or just a few, Deep Chem. And then likewise, there were a number of foundations and physical lab spaces that people were building to support the cutting edge of research and support funding things in different ways. And I also see them as our collaborators within this broader DeSci ecosystem. And again, just about a year later, the landscape needed another update. I think it needs an update every day, pretty much. I'm always behind on this, but I think it's important to be able to document who's working in this space, and I really want this to be a resource for people to find collaborators and projects to work on. And similarly, Erin has done a ton of research on this space, putting together a landscape analysis that she's written. And so I'm curious, Erin, if you can tell us about your research and also what some of your biggest takeaways are from all of the deep dives you've done on the space.
Of course. So myself with a few other collaborators, we did a survey on GR15, which was Gitcoin round 15. That was really kind of a seeding for a lot of these different organizations to really have a little bit of money to take those next steps forward. And in that, after talking to 41 different projects in space, we found that there are two really key areas that could use continuous support to keep DeSci evolving forward. One is funding. That's always part of the conversation across the board, and is also true in DeSci. And one of the powerful things is how a little bit of money in these spaces is being allocated into research, into different projects, being able to be amplified in ways that we haven't maybe seen in industry science, for instance. Another category is talent, and that's across the board. So maybe this might be your first DeSci event, or your first kind of step really diving in deeper. Whatever skill sets or background you have, it is needed and wanted in the space. And if you don't know exactly where to get started, or based on your passion areas, what organization might be best aligned, we each would be happy to introduce you to those organizations, as well as many other people here are probably the founders or part of those core teams directly. So keep interacting with them. And with that, like I said, we each have a lot of experience in the space. My original background is in neuroscience, then got into tech startups, got into Web3, and I've been involved with or supporting a large number of DeSci organizations. So very, very happy to help build some of those connections.
And my background is actually in early stage drug development. I worked on some of the early gene editing reagents and programs at Sangamo. My PhD is in molecular and cellular biology, and I still currently work in the lab day to day on novel cell therapies in the oncology space and the CNS space. And that's really where my main mission lies. I really care about developing the next generation of drugs to treat devastating illnesses. But as I was going through my graduate degree, I recognized both the lack of funding of some really important science as NIH dollars wane with inflation, and people really struggle to get grants. Really just the top few % of R01s are funded. So I think there's definitely a gap there that needs to be filled, and there's people who want to fill it. There's people who have funding, who care about the science, and they want to be connected to it. And so that was some of the seeds that laid the groundwork for my entry point into DeSci. I, as we mentioned, have been curating this landscape, and we have the online DeSci wiki, which is an open source Google Doc that anyone can edit. Feel free to add your organization in there if it's not in there already. That really serves as a living document for people to track some of the projects happening in the space. And we also include articles, podcasts. I've done a number of interviews with people trying to understand the ideas that are coming out of this space, but also form new connections, right? So bringing people together from the investment community, from the nonprofit community, from policymakers to people working in traditional publishing that are interested in novel ways of pushing forward the dissemination of scientific knowledge. So I really try to serve as a connector of sorts, and feel free to reach out to me if there's anything I can do to help you with your project, or if there's anyone that you're interested in talking to in the space. I think Aaron and I both are eager to connect you with the right projects so that you can get started on the work.
And over the next couple days, you'll be able to hear about all of this incredible work directly from the source. Just looking through the names here, there are some really, really brilliant people that I'm super excited to hear from. Are there any sessions that you're particularly excited about?
I'm excited for all of it, but I'm super excited for your YDAO panel later today. Also looking forward to the Coordination Network workshop run by Martin and the Coordination Network. So I'm really interested in this information layer of science and how we can better navigate all of the information that's being generated. What about you, Aaron? What are you most excited for?
I'm a bit biased because I'm also part of the Muse Matrix team, which is running a DeSci fellowship program, but we'll be able to dive in and share a bit more details on that during that 12 o'clock block later today. A little bit biased, but I'm excited to share on that. And then tomorrow, I know you're moderating a panel as well.
Yeah, we'll be talking to some of the folks working in the women's health space. I got to meet a number of them last night at the awesome Athena DAO event. Thank you for hosting that and bringing us together at this conference. So I hope people can join us for that panel. I'm really interested in how DAOs can move forward women's health, traditionally very underfunded and under-researched. I mean, most of the research that's been generated, even clinical research, for instance, has been done on men. And so even today, when a diabetes patient goes to the clinic, they're often treated the same as people who went through these clinical trials that weren't even the same gender as them. So let that sink in as far as our lack of understanding about women's health and how much better we could be doing for 50% of the population. Very excited for that.
Completely. I'm also excited for all the SynBio talks and just how we can be learning from other types of natural technologies and other spaces and be able to use that to keep pushing things forward. And that will really be a theme throughout this weekend. Just continuing to explore what could the future look like? What could better science look like? Better coordination? And just kind of this network effect, and leading off of what you were saying before, it's much more of a mindset. I personally experience this more as a social movement than just this technological revolution. The technology is allowing for us to keep taking these steps forward. And one question that often comes up in the DeSci space is, how does that intersect with the open science movement or other scientific work that's been going on for decades? And it's just an iteration of it. It's building off of those shoulders and that foundation that's absolutely essential. And DeSci is in collaboration with open science. DeSci is science. And that's part of why at least each of us are here. And I think that's part of the reason why many of us are sitting in this room right now.
Yeah, so if we could leave you with one big goal for this meeting, one big takeaway. Introduce yourselves to everyone that you can at this meeting, find a new collaborator, and set out to do big things. We don't want this movement to stagnate at a promise. We want it to actually deliver on some of these goals. We want to see new ways of science being done, and that requires science and scientists. So please, lean on your collaborators here, think big about how you can make change, and go out and do the work. So thank you all.
Thank you.
Erin, Jocelyn, thank you so much. Thank you for kicking off this conference with just so much energy and so much knowledge. I'm personally feeling quite inspired. So without further ado, I'd like to introduce our next speaker, Lydia Yatluk. So she's going to be talking about between the mainstream and utopia. What type of organization is a DeSci DAO? Lydia, welcome.
Thanks a lot for the introduction, and I'm also a little bit scared always to speak after the brilliant presentation, but today Jocelyn and Erin actually gave some ground for my own presentation, and that's actually marvelous. I'm a sociologist. I study sociology in the University of Groningen, and my PhD devoted to the sustainability of decentralized science organizations. I have some background in more traditional startups, but now I'm more focused on how it's possible to find conditions of DeSci DAO's sustainability. My current research question for the very first part of my research is what type of organization is actually a DeSci DAO? Why is it important? We can say that it's only some kind of template, so we can choose any kind of, and it's anyway, it's very new organization, and we can't find a totally matching template for that. But if we focus on possible candidates, we can find possible risks. A lot of organizations appeared before, even alternative, even with very strong opposition to the mainstream, and unfortunately they failed. If we don't want that for DSI, we need to find ways to see risks before. What are actually our candidates to match with DeSci DAO? Two options are obvious. It might be kind of scientific organization in a new decentralized way. In a way, actually, open code worked because it's mostly programming community, but creating not closed, but open source. It might be also scientific organization, or it might be a science-based startup, more or less similar to traditional startup with a more focus on science and with higher importance of R&D department, but still sort of startup. It might be also hybrid organization. It's the easiest way to combine science and industry. It's a hybrid. We see it in industry-university collaborations, some kind of in-between R&D centers. Actually, every university, especially in Great Britain, has such type of mixed organization. It could be alternative organization. Generally, in sociology, it's understood as anti-capitalist organization trying to create something community-based with a different sense of responsibility and different sense of participation inside. And also it could be bricolage organization with no key form of organizing, but very deeply rooted into biographies of founders. Maybe DeSci DAOs are just a new field using the same technology, but there is no similar form to describe them. It's only sort of community with similar discourse, but very different goals and very different structure. What did I do to check that? I tried to focus on values. Thanks to the public structure and public discourse of DeSci DAOs, all white papers and websites and a lot of notions are open. That's why we can study it. And I focused on values because values are a basic ground for all future goals, actions, ideas, ways of organizing, values of supporting community and so on. That's why it's really easy to check the status of organization based on values. And also it's very important to check for risks if we lacking some very particular values inside the organization. So I analyzed 25 currently existing DeSci DAOs. I'm aware that it might be much more of them. I used as a basis DeSci Wiki and took all organizations having publicly open and alive documents. I use deductive coding. It might be a little bit boring research stuff, but firstly I tried to match it with alternative and scientific organizations, and secondly used inductive coding to see if there are some values I didn't expect to see before, and just something interesting. So what did I find? The most interesting question actually for sociologists is what's absent, because it's the strangest part. We can always find a lot of different descriptions. Some of them may be real values, some of them may be just formal rhetorics like, yeah, we all care for sustainability, but what do you mean by sustainability? But if something absent, that's really calling for future analysis. And here we see that firstly, the first block that is absent is the structure of knowledge production. In some cases, we see some technical descriptions of that, but we don't see actual values inside the character of knowledge production. We see something about types of collaboration and types of communication between researchers and experimental groups, but that's not a description of the whole process of the knowledge production and scientific creativity. And that's interesting. And also, I saw low interest in working condition and the whole set of values connected with nowadays covered by labor agreements and different laws connected with the status of researcher, like Researchers' Independency Acts. And that's also curious because it raises the question if this organization care for sustainability of lives of researchers or not. We can't answer using only white papers, but that's still interesting. Going to the main results, we see that there are some values really highlighted in most of the research. Originality and a bunch of values connected with commercial status, cost effectiveness, financial sustainability, and that's actually calls to look at hybrid organization, because we see both scientific value of originality and innovativeness, and also some commercially oriented values. But what doesn't match, we don't usually see value of decentralization, autonomy in hybrid organization. It's mostly quite bureaucratic organizations. It's not needed. In alternative organization, in contrast, decentralization and community might be very important. And in this case, DeSci DAO might be quite close to alternative organization, but we still have a little bit of question regarding financial sustainability and whole idea of using research for raising finances, also cost effectiveness. And also hypothesis about bricolage organization worked. Actually, values of the organization deeply connected with the background of founders. It's visible for all of the organizations, and where founders are from different backgrounds, from scientific background and from entrepreneurial, we actually see this hybrid mood of organization. We see this overlapping. Coming back to my headline, I said that actually DeSci DAOs are somewhere in between mainstream and utopia. I think that's because in the same documents we see slightly different sets of values connected with the nowadays situation and the things we need to do to switch from the current situation to the future. Also, we see a set of values connected with the future utopian status of science and utopian status of researchers. Here, DeSci DAOs try to fight typical problems of the current science, like secrecy, particularism, dogmatism, everything actually before described as anti-values by classics in sociology like Merton and Mitrov. And also they try to connect with knowledge commons, self-funded research, trust and transparency, but they're not fully established in the current white papers, because it seems like they couldn't be realized fully in the current ecosystem. My very last slide is on some practical ideas, practical recommendation after the small research. It's really helpful to combine different founders, because even if we know that hybrid organizations might be a little bit unstable because of value conflicts, but it also helps to stay and follow the goal of combining them. And if you have founders only from one side, it's really high risk to go further to this side and lose financial sustainability or lose scientific part and start to be just a startup. Also, it's good to look not only to the user journey, but focus a little bit on the journey of the contributors, partner research labs, and especially full-time contributors, because nowadays it's a little bit lacking in the core documents, and it might be difficult for people joining the community and joining the organization. And also, it might be interesting to look further into values in knowledge production, because now we see mostly some parts connecting with what to do with produced knowledge, how to share it, how to present it, how to prove that it's valuable, but how do we actually need to produce knowledge in this new utopian way of decentralized science. That's all for today. Thanks a lot for your time and listening to me.
Lydia, thank you so much. Our next, I'm just keeping us moving right along, see if we can get us back on time here. So our next discussion, actually, no, we have two presentations, excuse me. Brian Majerski, the CEO, or I guess founder of Cerebrum DAO. Does the Valley of Death exist? Welcome, Brian.
Okay, can everybody hear me? Great. Well, thanks to Alfie and Bharat and DeSci London for the invite to sponsor and speak. I love this community. It's been very good for Cerebrum DAO. We have a lot of talent and interest coming from DeSci London, and I love participating and had a blast last year. So this is, I think this will flow pretty well from the prior two presentations, so I'm kind of excited about this. But this is some new content, so we'll see how it goes and if I can keep us on track. And I can't see the clock, so I'm not going to know. This question popped up. I had a conversation with a couple people that are a lot smarter than I am on this topic of the Valley of Death. And it led this question of, does it even exist? And it's an interesting question as I've been getting into bio-DAOs. So I'm going to start by introducing Cerebrum in the context of this question and see where it goes. So let's go. So what am I doing in brain health? I'm a software entrepreneur, enterprise software. I haven't touched science or biology at all until recently. And my inspiration came from my youngest daughter. So she's 12 now, she has Down syndrome, and people with Down syndrome have 100% certainty of getting early onset Alzheimer's dementia. That means pathology starts in their 30s, and by the time they reach 50 or 60, they're going to have full onset of Alzheimer's. And the population's living long, productive lives. It's about 6 million people globally, but they're all dying from Alzheimer's right now. And so that's, it was shocking, but it was also disturbing as I dug into the disease and looked at the 30-year history and the lack of progress that we've had producing a therapeutic. And at the time she was born, we had no therapeutic for Alzheimer's dementia. That led me on the journey of brain health. So what it led to was an aging population, neurodegeneration in general, brain aging, mental health, and ultimately brain health as a macro topic. And so that drove me down to Cerebrum DAO. And the reality is what we discovered is we're living longer. It's not just people with Down syndrome living longer. We all are. And neurodegeneration is becoming a real thing. Our frontal lobe is developed by our 20s, and then our cognition starts declining in our 40s if we don't do anything about it. So that's like 20 years of peak brain performance, which is kind of disturbing. But you can do something about it when you think about brain health. Yet, with the aging population, the numbers are just absolutely staggering in terms of where we're going. Cost-wise and just the social impact of diseases of the brain of all kinds. And it's not just Alzheimer's. We get Parkinson's, ALS, and so on. And the reality is, for us, neuroscience is a very complex thing. So why is this the case? Why don't we have effective therapeutics in a lot of these diseases? And the reality is, you can insert whatever you want in those parentheses. It's insanely complex, it's effing complex, it's insanely effing complex. It just is. And we know very little about the brain still. We know a lot, but we also know very little. And we have a lot of challenges in developing therapeutics that are unique to the brain because we don't have great models preclinically for this. They don't translate very well from animals. And we also don't have a lot of insight into what's actually going on in the brain when we're actually starting to treat some of these conditions. And so it's a massively challenging space. And so with the Valley of Death, a lot of times and a lot of discussions in science and what I found with DeSci and bio-DAOs, a lot of topics are we have categories like longevity and women's health that are absolutely underfunded. Brain health is not. It's like massively funded. We've seen the NIH budget for Alzheimer's alone has gone from $300 million to over $3 billion in 10 years. And really, we don't have anything to show for it. And you can look at, in Alzheimer's, this pipeline, the efficiency, and Jocelyn and Aaron touched on this earlier, of science becoming less innovative, and it's less efficient. And this begs the question on, we saw this with, and there's something called Eroom's law now, right? So it's Moore's law is what got us supercomputers in our pockets in less than 30 years. In science, we're seeing the reverse of that, right? So it's taking longer and it's costing twice as much in shorter time periods. And the cost to develop a drug now, I guess, is estimated at like $2 billion. And they say if this continues for the next 9 years, it's going to be like $16 or $18 billion. And that's just not an acceptable answer in any field. And in brain health, we just we just have challenges. And a lot of the brain health funding comes from basically 2 organizations. And so it's leading to, I think, a lot of groupthink and lack of progress in a number of areas. So leading up to this question about the valley of death, the bigger question I came up with, which is just, what if we were just overfunding research that just won't translate? It's not a money problem, and I might make a lot of academics really upset with this question, but we can't just throw money at the problem, right? So is $3 billion enough? Clearly not. So is $30 billion going to really change anything in brain health? Probably not. So what do we do about it? And that got me to the question of, well, what is the valley of death? And again, my career being in software, we had crossing the chasm, right? So Geoffrey Moore came up with crossing the chasm. And you could kind of talk to any entrepreneur that had a startup that didn't quite work out, and you say, well, what happened? I said, well, we just couldn't get the money for what we were doing, but it was a really great idea. As opposed to, well, maybe that great idea, you didn't figure out how to translate it into a viable business. So we've got a lot of great ideas, I'm sure, but we're not really thinking critically about everything, like how are we going to get this actually to humans to have an outcome? And again, we heard this morning on, the goal is publishing. Well, if the outcome's publishing for career advancement, that doesn't necessarily mean that we're doing the research that's going to lead to effective therapeutics for people to extend healthy lifespan. And so I don't like the term valley of death so much, just because, at least for me, as I've gone through my journey into life sciences and DeSci, it tends to be discussed in the context of lack of funding. And I think it's a bigger challenge. And so I found a paper on this topic calling it the translation gap. And so this whole idea of translating from bench to bedside. And that to me felt like, okay, this is something that's more addressable. And we might imagine like what could be in this translation gap. And it's a lot of stuff. It's a lot of stuff, but when you take a step back, it's involving things around incentives and coordination and transparency and data and things like that. So this is a whole series of processes that need to be resolved that will help be much more efficient in how we translate. And so this becomes more like a better problem statement for me as I think about what are we doing as a bio-DAO, like in general, and what are we doing as bio-DAOs, and what's our call to action here? And it really is, it's not just about getting a community of people together that care about the same thing and letting them allocate money. That community needs to come together, and we need to solve each and every one of these problems. And it's not just one DAO that's going to do it. There's a whole stack of things that I think we need to be doing together and coordinating on to do this. And so that's the rub. And Mike Tyson has this comment about, like, you can always have a plan until you get punched in the face. And what I've discovered talking with enough scientists is biology punches you in the face a lot. And so it's not like software. And so this isn't exactly crossing the chasm. This is a hell of a lot harder. And each of these boxes is an incredible challenge in front of us. But I think for a bio DAO and for DeSci to be successful, collectively, we got to solve each and every one of these problems. This was another view of it with a different way of categorizing it, but I think you'll get the point. So I love this blog post that Molecule put out calling bio DAOs not investment groups, but these are community translation engines, research translation engines. And I started thinking about the stack of things that we have in DeSci that are merging. And we have bio DAOs themselves. We have IP NFTs, we have IP tokens, and we have a lot of DeSci infrastructure coming into place now too. Things like Lab DAO and Coordination Network and Data Lake and others that I think we can all leverage as a collective community. And so then I said, well, how do we take that stack, and then what parts of the stack solve which of these problems? And I don't know if this is the right answer, but it's at least a hypothesis of where we can focus and how we can start aligning incentives and coordinating with each other. And so with Cerebrum, we're having a good amount of success working with Coordination Network, using tech trees and AI to try to better identify research opportunities and also even to filter the pipeline of opportunities that are coming in before we even put them out to our expert panel. And so we may not do it this weekend. I'm certainly open to doing it if anybody's up for it, but I do want to dive into each and every one of these problems together and start figuring out how do we start coordinating and knowledge sharing amongst us, whether we're in a bio DAO or an infrastructure. And then I'll kind of transition quickly to closing with Cerebrum DAO. So the reason we're doing this is we do imagine a world where brain aging isn't inevitable. And it's possible, and it doesn't always need a therapeutic. We've got a lot of work going on just in terms of education and getting people to think more strategically and developing habits that even improve their brain health without therapeutics. But we're trying to counter cultural norms on this as well, and we definitely think it's possible, but we also know that therapeutics are necessary as part of that journey. And so that was our vision. Our mission is to put together this network organization and really become this community translation engine for brain health. And we definitely think it's possible. This is not a 2 or 3 or 5 year journey. This is a multi-decade journey, and this organization and these DAOs, these network organizations, they are meant to be perpetual. And community owned, so they should go on forever, and that's our aspiration for it. If you are interested in joining the community, our token is coming out soon, so I don't even know if this date's correct, but roughly around these dates, we might move it around by a couple days, but you'll know that if you're on the wait list. We're thinking about this more broadly than a governance token, and it definitely is that, but this is another thing that I just throw out as a challenge to the DeSci community. We're not just solving a funding issue, we're solving a broader translation issue, and we need to start intentionally looking at each of those aspects of it. And I do think these tokens are far more powerful than just governance, and I think we do a bit of a disservice if we just call them governance tokens. There's a lot of utility functions that we can start putting into these that will drive and incentivize our community and members to coordinate broadly across DeSci to solve these translation problems, but also benefit from a number of different utility functions. And so we are going to be exploring a lot of those as we go forward. Governance is certainly one of those. Access to IP tokens coming from our IP NFTs is another one. And we do envision so much more coming down the road. And so that's it. If we have any time, I'm happy to take a question or two, but.
We do have time for 2 questions. Yes, my fine friend. By the way, Brian, thank you for getting us back on track.
Tried.
Hi there. Interesting story, by the way. I really like the backstory, the motivation behind the project. But you mentioned some of the utility that's possible with an Neuron token. Do you have any defined utility use cases for the token just yet?
Yeah, we're thinking of a few. So one utility, and this is a really valuable one, especially if you're interested in investing in the space. And that's if you have our governance token, if you have our Cerebrum DAO token, when we invest in IP, we tokenize it in an NFT, and then as it advances forward, it'll become IP tokens. And so those tokens ostensibly could have some economic value to them. So you have to have our DAO token in order to put capital into each of the IP projects directly. And so if you want access to our IP portfolio personally, then you would need to have our token, and that's one utility function. Another one is we're looking at some partnerships that we'll have some products that are tied to brain health, and they would provide some early access discounts and other benefits as it relates to that portfolio of products that we kind of screen through. And when we're looking at some other ones too, it's early, but we're just challenging ourselves to like broaden the scope beyond just voting. Yeah.
Brilliant. Thank you so much. I'm actually going to move us to the next speaker. Thank you, Brian.
Thanks.
This is a quick PSA. Brilliant. Thank you so much. So a quick PSA. If you are a speaker and you know that you're coming up next, please go see our friends at the sound booth to get mic'd up. And yeah, our friends here are waving. Jules is waving. Thomas is waving. Please make our lives easier and come get your mic. Thank you. Okay, without further ado, I would now like to introduce Laura McKinney. Yes, Laura McKinney, founder of Athena DAO. Sounds like there was quite the party last night, I must say. Everyone's like, hey, we're at the Athena DAO party. I was like, dang, what did I miss out on? So this talk is ReproTech. On how we can get to Mars. I love this. Thank you.
How do I move the presentation? How do I move the presentation? You do it. The green one? Okay. Hello, everybody, and I hope you're not falling asleep with the dark lights over there. I'm going to do the exercise. Everybody get up. No, I'm joking. Thank you so much to all the girls and the men that came to our event last night. It was called Girls That Want to Have Funds. All the girls drank for free. Our ally and friends, the boys, paid for their drinks because every dollar that we don't spend on marketing, we spend it on funding science, fellowships, and our team. So always remember that when you're helping us, you're helping that. So today I'm going to talk about ReproTech and how we're going to get to Mars. You hear about how women's health is all so underfunded, so overlooked. I don't like to think that we are victims of anything because our plans are measured in centuries. I want to make note of how it is women who broke the future of the universe. But while we do that, we have to save the ovaries. And here it's spelled the ovaire because of a French researcher who made this meme when we were sharing this. So before we do our plans in the next centuries, we're going to save the ovaires, which are the ovaries. I don't want to assume that everybody knows who I am and who we are. Athena DAO is the leading decentralized community working on translational women's health research, education, and funding. It's quite a mouthful. Our theory is that more research and development is going to lead to more clinical data. More clinical data is going to lead to better investments. Better investments is going to lead to therapeutics, and that's going to ultimately lead for more options for women. So we have a quite comprehensive plan of how we're going to get there. And just to do an overview, since last DeSci London last year, we have one still company under review that this is going to be our first spin-off. We have one ATH governance token, one equity deal, 2 IP NFTs, 6 pending deals, 40 active contributors between deal flow, comms, and awareness ops, like legal and tokenomics. What do we consider an active contributor? Somebody that spends 5 to 10 hours on the DAO on a weekly basis. Some of them are all on ATH tokens, some are already combined between fiat and ATH. We've had 80 project submissions, overviews over ovarian aging, PCOS, and now we are in our oncology cohort. If anybody knows a researcher working on endometrial or gynecological cancers, we're doing a call for submissions right now. Lastly, we have over 9,000 members across all social media channels. We are the second biggest bio DAO after Vita DAO. I am very proud about our core alpha team. Why? Because of the 12 members, 8 of them are women. Sorry, not 8 of them are women. 8 of them are actually scientists. So we have a very cohesive STEM biologist and all kinds of science in our team, from a data scientist, neuroscientist. I think we have like 7 PhDs in the team. I'm very proud about this because we've managed to harness the power of the DAO to bring women in science into blockchain. A lot of them didn't even have a wallet before they started with us, and now they're very active, and they're actually really helping us in pushing this movement forward. You can see our 2 first IP NFTs. A lot of us came from the reproductive longevity side of things, so that's why we did this as our first cohort. We also just had an amazing summit in Cascais where we brought together some of the researchers in the field. One of them is actually here all the way back from Paris. And it was a very exciting time to have researchers from Stanford in San Francisco, the National University of Singapore, coming together with us to roadmap the future of reproductive longevity. We also have a very exciting lineup of upcoming projects, one of them in the PCOS space, 2 in the, on the sexual health space, and of course, our first company that we're going to be launching in the next couple of months. This week, we also announced our collaboration with Research Hub. So this the part we're very excited as well because it's about the token economy. Research Hub was particularly interested also in how we could get citizen scientists to contribute to scientific research. One of the biggest black boxes in research is hormonal health. And every woman here knows how important that is, how they're doing their own biohacking, how they go to doctors, how when they go to doctors, the doctor says, it's just your hormones. Oh, you're just a woman. The reason they tell you this is because we just don't know we don't know a lot of information. So with Research Hub, we are actually bringing our tokens together to fund some of this citizen scientists or very early stage experiments that any of you could do if you want it. You can find the information on this call for submissions on our Twitter account, or X, formerly known as Twitter account, or you can go to our website or join our Discord. So how do we look at it when it comes to women's health? If I say we fund women's health research, a lot of people are going to be, but what's women's health? It's so much. We took a cohort-based approach to doing the funding. It's very focused. We do sprints of it. We work with the best researchers at each time. And it's a very good way of actually looking at each, I don't want to call it disease, but maybe a condition. So as you know, as I mentioned, we started with ovarian aging. We went into PCOS and endometriosis, and now we are in rare cancers. And we call them rare because some of these cancers are actually, not so much rare, but they're actually not very funded. One thing that we found shocking when we did the market research on oncology, which everybody here probably must know that it's the second biggest after brain health biomedical research funding in the world. However, the crazy part is when you look at the areas that are least funded, again, gynecological cancers came up. And this whole thing about data mattering so much, it doesn't, because when pharma talks about what do you call it? Oh my God, I'm blanking out. I need my brain health fix, Brian. It was a party last night. But when you look at how many, the number of women that have cancer versus how much funding dollar there is in the area is not right. The other thing is that we're only detecting ovarian cancer at usually stage 3, which by that time is too late. So one of the only solutions, and the one that is used, the most used is taking away the entire reproductive system. It's a very invasive operation. It changes everything for a woman. We do need to find better solutions, and that's why we focus on this. But today I'm talking about going to Mars. And our next cohort this summer, which we're getting ready for, and that's why I'm here talking about going to Mars, is on reproductive tech, which is also what we call deep tech, the next generation of reproductive technologies. Things like the artificial womb, IVG, in vitro gametogenesis, anything that touches the next gen, that is going to be very important, not only for women and for changing how we do things, but also to get out to outer space. So we say that the roadmap to Mars needs ReproTech. Why? Because if we want to technically go that far out and we want to colonize, we are going to have the artificial womb. And I know that for some this is scary, but it's not as far out as you think there are. There are a lot of things that we have to still figure out, but it's going to happen one way or the other. The other part where we're focusing on this is because in DeSci and in biotech and on X and on Twitter, everybody wants to talk about all the moonshots. Oh, let's just, we're saying we'd love to fund the things that are really out there. And we're like, okay, well there are lots of moonshots in women's health, so we're going to go to that. At the AG Summit, we talk about some of the things that need to get done, and this is the part where, I mean, we can get very granular of what we need to be funding to get the artificial, for instance, something like the artificial womb. But this is not the part that I want to focus on, because before we do that, we have to save the ovaries. And these ovaries here look like more like oocytes, but you get it. So, how are we going to save the ovaries? We're going to get going our token economy at Athena DAO by biohacking fertility in real time to contribute to R&D. And this is the big thing that we want to talk about today, or at DeSci London. We are going to launch a collection of NFTs that is accessible to ATH holders. On one side, what is the DAO going to get? We're going to start data collection, which is going to lead to our first ovarian aging data platform. We already did the research and R&D on that. We brought on a data scientist to the team, and we're bringing a couple more experts in the field for that. Why ovarian aging? Because we started with reproductive longevity, and there is literally no organization of data sets for ovarian aging that is comprehensive enough. Why are we doing it? Because we also want to make sure that our researchers get access to it in an open source platform. What does the community get? They get, obviously, to be able, one of the things that women ask me when I talk about what I do is, what should I do about my fertility? What are the things that I can be doing now? We're talking about science all the time to these women, and they think, okay, this is cool, but how does it impact me now? And my years working in the luxury industry, I learned two things, as well as in the longevity one. People just want to know what to do and what to buy. It just comes down to that sometimes. So we're going to help women or women in our community who want to hack their fertility, those who are looking to freeze their eggs, or those who want to know where they are in their fertility journey, or those who are going into menopause to figure this out. They're going to have access to experts. We're doing some collaborations with some other startups where we're going to be able to collect data in real time with companies that are already doing this in a very comprehensive way. And they're going to get rewards that go back into their token economy of Athena DAO. We're very excited about this project because last year we set out to put the foundation of the DAO, the scientists, the credibility, working with some of the best researchers in the world. This year we're set out to focus on the women. How do we get women into Web3? I like to say now sometimes that maybe we're not so much DeSci, but making sure that we are one of those organizations that are considered as brokering the time for Web3. So we have a manifesto that's coming out in the next 2 weeks. You're getting a preview here. It's going to outline everything that women are going to get when they get their NFT membership. And the most important part of this is, I know that people hate capitalism sometimes. I think we live in a capitalist society, and one thing that we undermine all the time is that women make 80% of the consumer decisions. Women also make 80% of the decisions at home for healthcare. To me, it's absurd that only 1% of biopharma R&D and innovation budgets go to female-specific conditions. Only 10% of the NIH budget goes to female-specific research. Women are so powerful when they decide where they want to put money. And when they figure out that the reason they're going to the doctor and they don't have solution is because we're not researching it, they're going to decide where the money goes. So, Athena DAO, community of women, we provide the products, get the funding, go back to Athena DAO. Hey, we might not even have to go back to VCs anymore to ask them for money. Just joking. So we have big plans. The girl economy is coming. We're really gonna go for the women this year. We want to onboard the most women possible into Web3 through our mission to something that matters, because when I got into crypto, I was not loving the rock NFTs, I was not loving the casino. But I tell you, I got into this because I thought this is a mechanism where I can actually get something done that matters to me. And our health matters to every woman out there. As a reminder, the future of the universe is brokered by women. So just think of that. We're going to get it done. So if you want to save the ovaries and if you're really and truly into bio-acceleration, make sure you sign up for a whitelist and yesterday a couple of people were like, yes, give me some of the Save the Ovaries. The men are going to have an amazing collection. The women, we're going to be able to biohack our fertility in real time. Thank you so much for the organizers of DeSci London, and 4 members of the team are here. We're open for questions. Please come talk to us, and I look forward to seeing a lot of you this weekend. Thank you.
Absolutely brilliant. Yes, please let's save the ovaries. Do folks have questions now? We have a second, actually. Are there questions? Yes.
Hello. I was wondering what the actual real-time data collection is for the NFT collection and what the NFTs have to do with the women being able to collect data in the reward system and things like that.
So it's basic token gating. If you have the NFT, you're able to enter our program. In terms of the data collection, we're still going to be Web 2 because there's a lot of things to resolve in data. And that's why I mentioned that we're going to have partners that already are doing this. But it's a token gating mechanism. It's just, it's like a membership. If you have the NFT, then you're able to sign up onto the platform and then join the cohort that we're going to do in terms of being able to do this as sprints, so that we can take sample sizes of basically however many women are joining, see how many they actually stay with the program, see how much data we get on a period of 3 to 6 months from each one of them. I think the biggest thing is that we think data is just something that happens, and it's very hard to actually get people to stay constant, to keep participating and to giving the information. And this is one of the biggest problems, that we say, oh yeah, we're just all gonna collect data and it's just gonna happen. It doesn't work that way. So for us, this is the first part where we're going to see what is the dropout, what is the information that they really want to give us, and how efficient it is in truly getting data from everyday user, because the concept of data is very abstract to most people.
Brilliant.
I hope I answered that question.
Yes, I'm going to do some sprinting. Getting my workout in today.
Thanks. Artificial wombs, 2050, 2030, when do you think they'll be available?
So there are about 6 or 7 startups working on it. One of them, one of the biggest ones that actually most people don't know is Colossal, which is bringing the mammoth back to life, and one of their programs is the artificial womb. I also want to mention that people don't know this, but Tyson Meats, the biggest meat manufacturer in the US, is also working in artificial wombs. I mean, it's imminently there. It's just there are roadblocks in terms of the placenta, the umbilical cord. Some version of it is already existing, and when you think of it, the incubator is already an artificial womb. So the sophistication level of them is going to get much more powerful in the next 10 to 20 years. but versions of it already exist. And one of the MDs that just joined the DAO, she already worked on an MVP for it. And we're very excited about it as she's going to lead our ReproTech cohort.
Excellent. We have time for one more question. Yes.
Hi. Yeah, my question is, why do you think it would be mandatory to have artificial wombs in order to go to Mars?
When will it be, sorry?
Why do you think it would be mandatory to have artificial wombs?
Well, I don't know if it's going to, I mean, why will it be mandatory? Because it takes years to get there. And if we want to technically colonize, you're going to have to actually have the gestation period. That whole thing that you see in movies, it makes sense. You either are going to have two embryos ready to actually get done there, or you're going to do it on the process, because it's going to take decades to get there. I mean, on top of that, there's the fact of radiation that we're undermining, so there's a lot of things to fix. But humans, as we are, we're going to have to figure out how to get there with plan B, A, B, C, D, E, and F, G sorted out, because we don't know what we're going to expect there, right? So it has to be part of the plan.
Excellent. That's a whole big topic about space radiation. I'm like, ooh, let's do that. Thank you so much, Laura.
Thank you.
Okie dokie. So I'm now very pleased to introduce our next two speakers who are going to be doing this presentation together. We have Logan Bishop-Curry, Biotech Operations Manager at Molecule, and Victor Korolchuk, who is Professor of Molecular Cell Biology at Newcastle University and a member of Vita DAO. This is Tokenized Research Projects. How does this work in practice? Welcome to the stage.
Cool. Thanks so much for having us here today. I have to say this is my very first DeSci conference, and also now in a speaker time slot, so kind of going 0 to 100 on this thing. But luckily, I'm joined today by Victor, who has been here last year, and is our newly minted professor as well, so congratulations. And we're here to talk to you today about the VitaFast project. So this is a project in collaboration with the University of Newcastle, which is funded by Vita DAO. And I work for Molecule as a biotech operations manager, but in this role, I'm also managing the VitaFast project. So we are here today to kind of answer any questions you may have. We want to have it as a bit of an open dialogue. Victor and I have some prompts as well to kind of guide it through, but any questions you may have had on, the IPT model, what does it look like? Is it actually a scam? Does it work? Hopefully we're here to answer some of your questions today. So before we get into it, I'd like to go first into the background of the project, a little bit of science for you on this Saturday morning. So Victor's focus is on autophagy research, and for those of you who may not have a scientific background, what is autophagy? How does it work? So very briefly, autophagy is a cell's kind of waste management system. It goes and it clears up, the debris, recycles it and packages it to make sure that the cells can reuse those different components. Biology loves to be efficient, doesn't like waste, so wherever it can reuse things is possible. So what happens is molecules that are no longer needed are packaged up and encapsulated in forms called autophagosomes, and then they fuse with another structure called a lysosome, which has different enzymes in it and a low pH, which facilitates the degradation process. Then in this fused format, the biomolecules are recycled and they can be reused to go on and have different functions within the cell. So in general, when you age, you do see a reduction in this autophagy process. And why this is important is that autophagy can be considered as the guardian of health. So as you age, this process of recycling and maintenance becomes less efficient, and aging is also the primary risk factor for the development of many different disorders such as cancers, neurodegenerative diseases, as well as some lysosomal storage disorders. So what Victor and the team at Newcastle have been doing is they wanted to look for novel inducers of autophagy. So they started with a screen of compounds, and they're testing them in a cell line that is deficient in a protein called NPC1. So NPC1 is a gene that encodes this lysosomal protein that helps with transporting lipids, so fats. And what happens in patients who have a mutation in this gene, they develop what's called Niemann-Pick type 1C, so NPC, also what the gene is named after. They have a deficiency in this fat transport, which means they're not really able to recycle these components as efficiently as they were previously. So in biology, again, it's really all about homeostasis, so maintaining a good balance within the cell. In general, it's not always the case that if you increase something good, that this is good, and you decrease something bad, that this is bad. It's really about this homeostatic process. So in these patients who have this mutation, you get an increase in cholesterol storage, which builds up over time. And you have these products that are no longer able to be cleared and recycled, causing a whole host of issues for the cells. And patients with NPC develop neurological and systematic symptoms, and the average lifespan for these patients is around 10 to 25 years. So this is a great model for Victor and the team to use to kind of study the autophagy process, because as a monogenetic disease, it's a little bit easier to understand, okay, if I can increase autophagy here, then maybe it can lead to improved symptoms. And that's exactly what they're doing. So as a therapeutic strategy in this project, we look at the disease. Some hallmarks of it is, okay, we know we have a reduction in autophagy. We know that this causes a decrease in cholesterol clearance. So you get this buildup of cargo that's no longer able to be degraded and recycled. And the hypothesis here is that when we treat this process, we increase autophagy, then we can increase the rate of clearance, and we can have a reduction in some of the disease symptoms. So for NPC, our direct application, we're thinking that the induction of autophagy may lead to a promising therapeutic strategy. But then, in this kind of simple monogenetic context, it's a little bit easier to see whether this has this direct effect. But eventually, long-term, we would like to apply this as well to other neurodegenerative diseases that would follow the same pathway, but such as Alzheimer's and Parkinson's. But there, the mechanism of disease is less well-known. It's a bit more multifactorial. So, you have to build up your kind of story there and your evidence. So obviously, Victor's doing some great research, but in order to do great research, you have to have the funding to do so. And it's been really great hearing the other talks earlier today touch upon this as well. I think it's a really great fit for the program, because here, Victor, the project received funding from VitaDAO to do this project, and then went on to become tokenized. So this is the first tokenized research project. We have IPTs associated with them, the VitaFast tokens. And essentially, short form of this is that, the IP NFT was fractionalized to give away governance rights associated with the tokens to different stakeholders to fund the project, as well as to get the community a little bit more involved. So here it's a great opportunity to kind of align stakeholder interests. And we're here to you today to kind of tell you what that actually means in practice and kind of how we've experienced this process. So again, a little bit of highlight on the project and the token sale for those who may not be so familiar with it. This is the first IPT project. It was very well received. It was 1,700% oversubscribed. I know this is a number that everybody likes to kind of share, but I think it is really interesting to see how many people are actually interested in such a mechanism. Currently, market cap 5.6 million. That number always goes around, but in general, trending up, which is great. And Victor and the project team, all the different people in the lab, as well as the representative from the TTO, they are also all token holders. So cool to see, how you can involve researchers like this as well. So I'm going to switch the format a little bit now. I give you the background on the project. I'm going to ask Victor basically kind of a couple questions. You can hear his insights into what he thinks about all of this, and then I have 3 kind of broad topics and questions, and if there's time in between, we'd love to as well hear from any of you who are also interested in hearing more about it. So, Victor, now that you're here with us, so can you give us a little bit of a background into, how you found out about VitaDAO, how you learned about the project, and kind of why you decided to apply for funding here?
Yeah, all right, thank you. Well, thank you for the invite. It's great to be here. So last year there was a DeSci, and I was very impressed with sort of how much interest is in this field. How many of you are sort of something to do with basic or scientists, essentially, academic research? I just want to know who I'm talking to. Okay, so right. Okay, so this is kind of my entry into this thing, right? So I know nothing about cryptocurrency or any of these mechanisms. Well, as I go through this journey, I start sort of knowing more about this. But the entry point was probably similar to those of you that sort of may be curious about this and never sort of even considered before. How you do this? What do you start? How do you start? So my journey started with that very specific, basic cellular mechanism that Logan was just explaining now, and it's miles away from anything sort of relevant to normal sort of person. So the mechanism was discovered 20, 30 years ago as a sort of as a phenomenon. The Nobel Prize was awarded in 2016, and since then there is nothing in terms of sort of drugs, and that was kind of always a puzzling thing. So for the community that knows that this process is the cornerstone of human health and it's supposed to be one of these key determinants of longevity, we don't have anything that so far been sort of put in humans and used as therapies. So there's always been this drive to go there, but the valley of death does exist. It probably is, it does exist in various shapes and forms, but for people like myself that work with cells, that valley starts very early. So the path is so long to anything drug related that to fill it with some sort of real sort of process would take a long time, and for this obviously you need money. So that I'm sort of slowly coming to your question. So so I started talking. Initially we were trying to do standard sort of routes of getting funding for drug discovery, for screening, and then development. Academia is not very good for this, so a natural sort of idea was let's go to some sort of commercial angle. I approached it from a longevity biotech point of view. This area is booming, everybody is excited about this, and so I signed up for longevity biotech fellowship, and that was quite interesting because I've met so many people. I had like dozens of meetings over the year. And one of them was Sebastian Brunemeyer that I knew from sort of from earlier work, and basically he introduced me to Tyler Galato at VitaDAO and said, why don't you apply for this thing? So to me that was shocking, the contrast with my standard sort of ways of dealing with funders and this, because I actually spoke to a person, and then I spoke to a small group of people, and then I spoke to a larger group of people, and then we had a conversation. When I typically did it, I wrote something on a piece of paper, it went to Abyss, and then 9 months later you get a reply, like one syllable, usually no. So, so that was sort of, although it wasn't easy and simple because I was like a blind cat looking for directions, but eventually having found those people that could actually respond and understand both from scientific point of view as well as from a point of view of how sort of system works. And then they basically entrusted us with sort of next steps, etc. It was a very interesting process, I think, for everybody. I think for both for VitaDAO as well as for us, for our admin, for our finance, for legal team. Everybody was sort of flabbergasted from at the beginning. But surprisingly, that took extremely sort of short period of time in comparison to standard routes just to sign something up. And I think this is why I often now sort of speak to different people because they come to me and say, how is it possible? How did you do it? And stuff. So yeah, but we'll come to that. I think we'll come to that.
Great, thank you so much. Exactly, next question. So in the process of kind of, being confronted with, okay, the opportunity for tokenization and funding and things like that, it's like, obviously you had to have a lot of different conversations with legal, tech transfer, like, what were some of the concerns that came up, and like, how did the institution, let's say, navigate some of the perceived risks, which may touch upon like, okay, all of a sudden everything is maybe open source, my IP is going to be publicly available, maybe the stigma of crypto and not necessarily understanding the space, as well as the kind of reputational risks of like, okay, what would happen actually if the project, quote unquote, fails, or doesn't necessarily lead to a drug in the end. Like, how do you maybe handle the reputational risk of maybe the token price going to zero, or some of the, I don't know, maybe memes that get shared in the space? So what were some of these conversations, and how did it go?
Yeah. Well, so this is a lot of questions, and there is absolutely, I don't even know where to start. So let's try to structure it somewhat, right? So let's address one question, for example, how did it go? So in our case, it was our business development manager, Matt Abbott, a great guy who literally drove the entire process from start to finish from university side. I don't think it would have been possible to replace him and achieve that. I think what the lessons that have been learned would be useful for other universities, for example, research organizations. But one individual was interested in crypto mechanisms. He wasn't necessarily involved with it, but he actually knew how a system works. He understood about the NFTs and how to potentially this could be developed in the future. And he was the person that spoke to legal, to finance, and managed to convince them that this is okay, because I often talk to people that come to me and ask, so, how will it work for me? And you need to have the university to essentially agree to this, so you cannot just do it by yourself, right? So he was able to convince our finance ladies, 60 years old plus, that went sure what the wallet is, and but obviously because the system is relatively sort of streamlined, and together with the molecule, Vita DAO was trying to actually make it as sort of similar to the standard mechanism. So we never got paid in crypto, we got paid in Swiss francs, for example, right? It's just a simple answer. So the IP, okay, so it's always a discussion about that. In our case, we were happy to make whatever IP, the ownership of it by Vita DAO, but that also allowed us to build, sort of develop platforms, because we are at such an early stage of development that, as I say, no funder would have and would be interested in doing this. So it's not just about one way, it's not just about money, but we are getting something out of it, and we've been rational about what we keep and what we share. And in fact, I personally believe that that sort of contribution to a community and actually working with the community is absolutely fantastic thing. Again, not every researcher may think so. In fact, the science is often quite sort of secular, and people don't like to share. And again, quite a number of people would then say, well, no, it's not for me, I want to keep ownership, or university would say, I want to keep ownership. But even in those cases now, I know that there are ways to discuss this and sort of plan for this to develop together. So that's kind of one part of this. The reputation is another interesting thing as well, is because even sort of researchers themselves may consider this, especially those well-established, FRSs and Nobel Prizes. I could see that how unlikely they would go into this. I think it would appeal more to people that are younger, more open-minded, and essentially these are the sort of the target audience that potentially would join this movement. And I think it's a movement that definitely worth joining, because it's actually team work. And I think that the time when scientists were working in silos and individually, it's sort of long gone. So hopefully the new generation will allow for all of those issues that we have with data reproducibility and open sharing, etc., will allow to move everything faster, and we won't have 10 years for drug development later, and which is essentially what the point is here. So, I mean, as we're doing this, we're obviously learning and going try to understand how best we could do this, but I love the direction into actually working with the community. And it's often even a challenge to communicate. We try to share information. We try to get input into our project. But that's why, for example, Logan currently is driving this process, because as a scientist you don't know much, but you don't need to be scared, because there are people that walk with you and hold your hand alongside this pathway. So reputation, as I say, is something that always worth. I remember when Laura De Francesco, she's the editor of Nature Biotechnology, she approached us and asked, can you give us interview, and she wrote an article in it. She said that the chief editor of Nature Biotechnology didn't want this paper to happen. So basically it's sort of dumb to talk about crypto, and that was 2022 only, so it's not even that long ago. She did write it, and then there was a follow-up paper as well, and so it's sort of trying to build this sort of awareness and okayness of this in a community of scientists, and it's still sort of a long process. So yeah, I don't know, anything else on this topic, or shall we move on?
I think that's a very comprehensive answer on this one, and you, I think, touch upon maybe some of the points of this last question is kind of like, what are some key takeaways that you've learned from, the IPT model, the DeSci model, that you would then be able to use to kind of talk to other researchers who are interested in maybe tokenizing their projects?
Well, I speak with people essentially on a weekly basis. So somebody emails me and says, or tweets me and asks me, can you have a half an hour of conversation because we're interested in this, for example, right? And as I say, I've seen examples of people then going ahead and being introduced to Logan, and others would then start these conversations about how to apply. And now that the system is quite established, I think, so it's a fairly straightforward process where you can submit your short proposal, and then this goes through stages of voting and et cetera. So it's not necessarily an issue to know how to do that, but essentially questions are like now, so what's your experience and is it worth it? And I would say probably half and half, so 50% of people would have gone through that route and did apply. Whatever happened after, that's sort of whatever. But about half didn't, and there were multiple reasons for this, and all of those that you've sort of previously mentioned, they were sort of sounded. So there were things, for example, well, we or our university will never share anything to do with the IP, for example. So even giving up a fraction of it, whilst that's already tricky and challenging, but most of people would say that that's a no-no. Obviously, that's a no-no for everybody, right? So I think it also depends on the type of project and type of thing you do, because there may be ways where IP, I suppose, is not necessarily even the stumbling stone. But other aspects, like, for example, the financial part, is something that also plays a role, because sometimes people can choose and they would say, okay, I mean, that comes with quite a lot of ifs and buts, and those ifs and buts could be just the flip side of the same thing. So, for example, I often say, my experience working with Vita DAO and the molecule is that I have quite a lot of interactions, because I often have to have meetings with Logan and other team members. I often have contacts with the community, and we have some presentations and updates, etc. So it's very involved. So it does detract me from doing something else, and a lot of my time is spent on this, but at the same time, it's just the flip side of the coin that I'm actually engaged and somebody else is engaged, and it's quite rare in science to actually have attention of anybody. So in fact, I quite welcome that. I'm quite happy to actually be able to, discuss with people that are talking about my science and how to do this together. But some people may not like that. Some people would essentially want to get money and then never talk to anybody for, 3-5 years or something. So yes, it's a very different system, and yes, it does have drawbacks as well, because we're also working with other companies, and so I like this way of sort of funding because it's a lot more involved and there's a lot more communication that standard funding routes don't have. But I suppose it's even depends on type of your character. If you like to talk to people and if you like to have frequent meetings, then probably you're more likely to enjoy this.
Cool. Well, thank you so much, Victor, for your answers. Obviously, okay, final slide, call to action. If anybody's interested in joining any of the communities, feel free to either join our Discord or, Victor and I are here all weekend, so please come and chat to us if you have any other questions. I don't know how we are for time, but if there are time.
Yeah, fine.
You guys are rocking. We have time for questions? Yes. Okay, 1, 2, 3, 4. Okay, here we go.
Victor, you talked about not needing to have to wait 10 years for drug development. But how does the DAO help with that? Because that's clearly the major problem in the industry. Is it that you're going to have more collaboration? Is it there's more learning from mistakes so you can go faster?
Yes. So, so from my side, the issue is that starting very, very early, right? So when Logan was telling you what we are doing is literally nothing to do with drugs as yet. So it's as early as it gets. We're screening sort of off-the-shelf libraries of molecules, talking to standard funders that are available for academic researchers, as well as even companies like, for example, LifeArc, it's a MRC sort of spin-out, which essentially was funded specifically to develop early stages of drug development into sort of further stages. They all say this is too early. And it took us, so I'm not talking about drug discovery in the sense that you mean. It's not that entire Death Valley. It's a very first few steps of that Death Valley that is quite difficult for us to even penetrate, because you cannot apply for a standard grant when you say, well, I'll screen drugs. Nobody sort of typically funds that. So the only way is to do it via some sort of support of either industry or Vita DAO. So, so for my specific purpose, the fact that we have money available to go through that initial set of stages that we do, so screening, rescreening off-the-shelf compounds, synthesizing new derivatives and testing them, trying to identify targets. This is a phenotypic-based sort of approach that we have, so we still need to work on that. Try to develop the sort of MOAs, as well as sort of find a direction for future application, etc. These are a lot of those steps that we can actually do a little bit ourselves and with support of Vita DAO financially. But of course, as you've also mentioned, that there's this other aspect of it, the input from others as well. So we're also talking outwards. So people that we were not previously connected to or were not linked to any of these, medicinal chemists, for example, or people that with experience from drug development, which we are not, as even though one of the core members of the team has been involved in projects like this at first stages, but then we're trying to move into sort of further down. So those people are starting to come on board and try, and so that process is sort of naturally developing. I will stop here, but I guess I hope you understand my point, is that even that a little initial trigger is extremely helpful for us, because we wouldn't be able to move beyond where we're like now. Yeah.
Excellent. There was someone back here. I thought, there you are, my friend.
Yeah, thank you both. I was wondering what underlying sort of biology did you capture within the IP? Are there any restrictions on how long you own that? How is that? What's the scope, and can people build on that, for example?
So the project at the moment is still like pre-IP, and you have obviously different sorts of like contracts, royalty, licensing rights that are dependent on the different universities that you work with, and as well dependent on the type of like stage that the project is at. So it's always this negotiation process in each and every project. It's never really going to look the same because institutions have different approaches, and then projects are at different stages of maturity. So in this particular instance, University of Newcastle, very early stage project. So VitaDAO owns all of the resulting IP that's coming from this project, and then what VitaDAO chooses to do with that afterwards is up to VitaDAO.
But I think to add to that, so the IP is on chemistry, not on biology in this case. So it's a chemical entities that have biological action, and that are essentially being sort of target of IP.
Okay, I see friends over here coming around.
Okay. She just missed you.
Sorry. I mean, what's concomitant? Yeah, I have more general question, like, how do we get that to be mainstream? I mean, like, you've seen the number of scientists in the audience. It's literally like being at a vegan conference with only butcher in the audience.
Mm-hmm.
So scientists don't know. I'm a scientist. I mean, if I hadn't been interested and created a DeSci company, I would not be here today. It's becoming like an echo chamber with a lot of confirmation bias at the end of the day. And like scientists don't have Instagram, and you propose to talk to them about Discord, which obviously they're not going to go on. So how do we get to become mainstream? And like that's really a question that, because you guys are funding, you should not need help. You should be swamped by requests and etc.
Are you swamped by requests or not?
I mean, Molecule doesn't necessarily do the funding themselves, but I actually started at Molecule last October, and before this I had no knowledge of DeSci, also very not into crypto at all. It was kind of an opportunity that when I looked at it, I was like, this makes sense. I have no clue what any of this is about, but okay, let's try. But there is this every time I kind of think about all of the different things you have to overcome, it's like, okay, you have to understand Discord and DAOs, and there's just there's such a lot of knowledge that you have to really build upon in order to kind of get involved and understand it at a basic level.
Let me interrupt you and clarify. Even I was able to finally make a Discord profile, so anybody can do it, honestly. And in fact, the whole point of this event is that everybody of you who are basic scientists that want to be able to do something in a different route are able to literally apply with a little project, as in little description of the project. Yeah. It doesn't have to be little directly. So now the path is quite established. So I don't know, I mean, there probably are better ways to advertise it on different, I don't know, social platforms, etc. But currently anybody can, without asking for permission, just put a one-pager or something, as far as I understand. And then there are people that essentially take care of you as well. They're shepherds, so it's not that you are working blind, that you are introduced to somebody, so then you can ask questions, etc. So in fact, I think that this system, once people just know about it, I agree, you still have to learn about it somehow, and you tell your friends and your colleagues, and perhaps this would be the, the spread in the word. But I think the system itself is a lot more humane compared to standard systems, because you get a communication with someone. It's not just a piece of paper. Yes.
Wait, hold on. Right. There was someone who was waiting here. Sorry.
Yeah, actually, yes.
Yes.
There were,
okay, we are not going to get to all these questions. I think you were in line first. Wait, no, it's you. Hi.
Hi, I'm a scientist too. I've just actually graduated.
I'm sorry.
Are you going to be, so does VitaDAO plan on funding your research until the end? So for like 10, 15 years, there's so much money.
It was always sort of open. So we were funded for a specific period of time. Then we said, okay, there were changes. We've made those changes. After, obviously, voting of the community, the voting happens with tokens, etc. But there are people that are guiding this process as well. Nitty-gritty doesn't necessarily matter, but it's pliable. It's not fixed, which means that it probably would change. It may happen, for example, that we have these molecules, they basically run away with it or do something, sell them on the market, for example, IP market. That's one way. Another is that we're involved as needed. So it's all on the basis of the need. So if I feel I can contribute still, they would be very happy for me to be involved. If it moves into the direction where it's now pure disease models, for example. We always wanted to do this, a drug for aging, but obviously you have to start with a disease of sorts, and that's kind of the direction. So I think that's, again, another advantage of this is that you can talk to people and you can even influence them as well. It's a dialogue. It's not just, set in stone.
Thank you guys so much. So I'm sorry that we didn't get to everyone's questions. There's a lot, so I strongly encourage folks to find our lovely speakers after this, because we got to move on to the next round. Yeah, sorry. Absolutely brilliant. So without any further ado, please welcome to the stage Josh Bate, founder of DeSci World, for Proof of Knowledge, the on-chain knowledge layer.
Yeah, let's use this. There we go. Nice, thank you, my friend.
Hello. So this is a brief talk about a knowledge-backed economy in an AI-driven future. This is a talk I've given a number of times before, but I'm trying to condense it, so if I rush through things, that's why. So those that don't know me, my name is Joshua Bate. I'm the founder of DeSci World. You can follow us on Twitter here, and you can go to our website up here. So this is a brief exploration of what a knowledge-backed economy might look like. So typically, modern society has gone from the manufacturing-based economy to the service-based economy to what next? Manufacturing was automated away after the Industrial Revolution. A lot of people lost their jobs, moved to the service industry. With AI becoming increasingly powerful and increasingly capable, the service industry is likely also to be automated away. Apologies for those that don't think so. But what's next, right? If we can't make and we can't give, what can we do? So we at DeSci World, we believe that the future lies in a knowledge-backed economy. To understand a knowledge-backed economy, we should first understand what is knowledge. And here there's two brief definitions. The dictionary definition, which is knowledge is the sum of what is known. As we know, AI is incredibly good at synthesizing that which is already known. But what this does mean is it presents a wonderful opportunity to us as humans who are the sole creators of that which is not yet known. Okay, if AI can only synthesize that what we know, humans are the ones that can actually create the new addition to the economy. If we understand that not all knowledge is known because it can be created by humans, then this next understanding of knowledge presents a small problem. Knowledge is also defined by that which is accepted, the canonical understanding of knowledge. An institution, a research institution, some of many different types, will decide on whether or not the knowledge can be considered to be true or factual or canonical. And as we know, canonical knowledge by definition is canon and can be changed. And throughout history, canon has changed a lot. So what we have is an understanding that knowledge is the sum of what is known, but what is known is limited or can be changed. But to understand what an economy how an economy must work, you must understand how to value that input. Manufacturing is quite simple to value. You can value the inputs, the labor required. Service-based economy, similarly. You can figure out the cost per hour of human labor and then find a service charge for that. But how do you value knowledge? Currently, in society, we value knowledge through two core mechanisms. We have the patenting and licensing system, the IP system, and we have the institutional grants and prizes system. When you're creating knowledge, this is typically how you will find your money. Through the patenting system, it's to take your idea to a productive end once your idea has become productive, for example, in a cleaning product or a fertilizer or a pharmaceutical or our society's favorite method of innovation, the weapons of war. Once you get your idea to a point that it can be patented or IP'd, then you can start to generate some revenue from it. Alternatively, using the institutional system, you can get a grant for proactive or a prize for retroactive funding for your idea. The patenting system is pretty robust, but it presents some problems in the isolation of knowledge or protection of knowledge. The institutional grants and prizes system is pretty inefficient and leaves a lot of space for grift, bias, and other such issues. This is a brief sort of analogy of the productive science system. This sprout is the idea, the knowledge that became productive. It was given the seal of approval by the required institutions, and then it was receiving money for its value. But what is in reality, this sprout is actually from the seed of the soil of the dead and dying ideas of other researchers. Many other people contributed their ideas, their mind share, their experiments, their thoughts towards what eventually became this productive idea. However, the money only goes to the seed, to the sprout, and not to the soil. Soil is an issue in society in general right now, but also the intellectual soil is something that we must preserve. If you cannot get funding for your chain of provenance, if you're not a part of the chain of provenance and you don't receive that funding, then this soil becomes unsustainable to create. So the natural conclusion to this idea is that everybody has some value in their brain. Their knowledge has some value. Now, I know many people, maybe not so many in this room, but many people in general have a concern with this statement that everybody's knowledge has value, because primarily of misinformation. Misinformation is a fact of life even before the internet, but with the internet and with AI, it's becoming increasingly terrifying. Honestly, we are living in a crisis of truth. And if we're living in a crisis of truth, currently the system relies on us to have an institution to tell us what is canon, what is accepted. And in a situation where an institution is the one giving us the truth, yet we are still in a crisis of truth, then we need new systems. And we're proposing a new system, which is the proof of knowledge system. I've been told I haven't got much time, so I'm going to whiz through this. Proof of knowledge is a new technical product by DeSci World, okay? And we're going to be showcasing this at a workshop at 1:20 today, so if you're interested, please attend. Very simply, proof of knowledge is these 4 steps. It's a decentralized knowledge graph, a DKG. It is put on-chain. It is machine readable, so that AI can pass the entire DKG. And once the machine has read it and passed it, you can actually assign scores or value and provide incentives. So what you have, in effect, is a distribution method for your knowledge that allows other people to use it through a vectorized database to assign scores and value for reputation and to receive potential incentives. The core primitive that we've created for this is called the engram, or the knowledge engram. The K is silent. An engram allows you to track and to quantify your knowledge. An engram is theorized, is modeled after the engram in your brain, which is theorized to be where your memories are stored. An engram is essentially a knowledge oracle or a wrapper for your knowledge to put it on chain and to have it read by AI. It's a structured unit of knowledge, which is read by AI services using Ethereum attestation service. I'm wearing their t-shirt, but I don't work for them. In effect, this is what happens. You have an AI interface. It can be a chatbot. It can be any other interface. And it's using the data set underneath. It's using your engrams. When your engram is utilized by this AI, you're getting these referenced responses. And so the response is actually linked to your underlying data. So a user can get a nice synthesized answer, but the context that was used to form that answer is referenced in the response. And actually, in effect, what you can have is this ranking of knowledge in relation to other knowledge. So you have a vectorized database that allows knowledge to be passed and to be ranked in relation to itself. What we're doing here is we're placing humanity, the individual who creates the knowledge, back at the center of the AI future. Because when you use OpenAI, the misnomer, when you use OpenAI and you get a response, you don't know which human contributed towards that effort, and you know for a fact that they're not getting incentivized for it. So the accepted sequence, 2 minutes, the accepted sequence right now is to have knowledge given to an institution of some description and then to be canonicized into knowledge. The revised sequence, as we're proposing, is a lot messier, but a lot more beautiful in our opinion, which is humans interacting with humans, humans interacting with engrams or these knowledge wrappers of any description. These people, these entities interacting with institutions and with AI and with each other. It's no longer a unipolar system, it's a multipolar system. So that was a very brief introduction to a knowledge-backed economy in an AI-driven future. Please join us to learn, share, and coordinate at 1:20 in our workshop. Thank you.
Excellent. Thank you, thank you. Yes, please, everyone, attend that workshop because there's clearly a lot more to learn. So, without further ado, I'd like to welcome to the stage our next speaker, Kevin. Kevin, where are you? Oh, there you are. Hi, Kevin. This is Kevin Wad, founder of Etica Protocol, How Blockchain Can Fund Open Source Medical Research. Thank you.
Hi, everybody. First of all, thank you very much to invite HK to speak here, and thank you to the sponsors. And yeah, so HK is a project that tries to fund open source medical research without intellectual property. And we have a very particular vision, and I'm very glad to be able to present it today. Okay, so the IP system is a very old system that was created centuries ago. And right now we are seeing that due to the fact that it's an old system, it's not particularly adapted to the new emergence of the technology. So again, this presentation, I've done it a lot of times, and right now I have to make it very quick, so sorry if it's like very condensed and accelerated. So yeah. So the consequence of the fact that the IP system is outdated is that right now when researchers, they want to publish on journals, they have to pay thousands of dollars just to publish. So let's say you are a researcher, you want to publish your research. Well, it's a well-known fact that you have to pay thousands of dollars just to be able to publish. And the question is, in the new century, are we able to create a new system that will enable to incentivize open source research? And for this, to create a system where basically researchers would not have to pay in order to publish, but they would be able to even get paid to publish. So with the emergence of new technologies, like the quantum technology, artificial intelligence, we are entering a new era, an era where the science is going to accelerate, and it will become harder and harder to track intellectual property. And so we can arrive to the point where it becomes impossible to track intellectual property. So the question is, how can we cope with that? And how can we create a new system that can enable to still reward researchers, but without intellectual property, because it becomes untrackable. Because basically, when you have AI and when you have quantum and all these kind of technologies, and researchers start to share the research online with the new technologies of internet, then it becomes impossible to some extent to track intellectual property. So another reason why I would like to thank the organizers of the event to invite HK is because HK, we have like a very specific vision about this, and it's like an alternative vision. So it's good to have different kind of opinions about it. But with HK, we want to completely remove intellectual property because we think that in order to be adapted to the new challenges of the coming century, we need to create a new system where researchers can publish completely open source, but without intellectual property. So why open source? Why is it important? Well, if we take the example of AI, we can see that it's like an embodiment of the reason why open source is so powerful. Because what happened is that before Google shared its paper about transformers 5 years ago, before that, in the AI community, it was deemed like impossible to reach AGI, and the most optimistic people would say it would like be reached within a century or even longer than this. But since Google has shared its open source paper, we have seen that the AI ecosystem has completely changed, and that now it's very like everything is accelerating at an alarming pace. So this is an example of the power of open source. Because if Google didn't share its paper on the transformers and shared its vision of the transformer system, then the AI ecosystem would be completely different, and we would not have this kind of emergence today. So this the AI ecosystem is truly an ecosystem where the research is open source. Every AI team, even the private companies, they are sharing their research and they are making it open source. They are sharing their papers on archives and this kind of websites. So this is really like the idea, you know, why don't we do the same thing for medical research? Because right now, medical research, it's a system where everything is closed, where intellectual property is the rule, and where open source is not the rule. So for this, we can create a cryptocurrency, we can create a currency that will, to some extent, replace intellectual property and finance open source research. So this is the idea of HK. HK is a new currency that tries to completely replace intellectual property in order to finance the researchers. So basically the system is very simple, that the researchers, they can publish on the blockchain and get, like, there is a voting system that is completely decentralized, and within several weeks, they can get funded. So HK is an idea, it's a white paper that was published in 2018. But like, what I want to say is that it's, it's a cryptocurrency, but that can be used by anyone because it's a community-driven project and nobody controls the system. So it's a neutral protocol like Bitcoin and Monero. Like anyone can join it and can use it for its own interest. So beyond like even the word HK, I want to underline the fact that if DeSci can create a cryptocurrency that can finance open source research, it can truly be a solution to all the problems we have today, because thanks to a neutral protocol that would reward open source research, it would definitely be possible to remove intellectual property and at the same time reward researchers. So let's imagine, like, if sometimes when we say Bitcoin, when we say blockchain, few people understand what it is, but when we say Bitcoin, there are a lot more people that understand. So imagine there is like a Bitcoin cryptocurrency that people can mine, and that is done specifically to finance open source research, and that researchers can earn if they share open source research. And then there is like a decentralized voting system that enable anybody to take part in the voting process to identify the best proposals of the system. And the protocol would separate, like it would create intervals in time. It would create periods, so periods of 7 days, and every 7 days the protocol would issue a fixed amount of currency. So let's imagine like a Bitcoin. but that issues a fixed amount of currency every week, specifically to reward researchers. So if you scale this kind of system, you can have the same benefit as Bitcoin when you scale. It means at the beginning, maybe it could be worth a couple millions, but the system in its nature could evolve into something that one day could be billions or even more dollars. So such system potentially could fund unlimited amount of science. So it would just depend on the size of the market cap. So yeah, so that's the idea of HK, is to create a currency specifically to reward research. And well, I don't want to go beyond my time, but so this is also, it also opened the door for new kind of research, because if anyone can take part in the research process, it means that any student, any private, even small entity can take part in the research process. So it means that there is no grant process, there is nothing like this. It's and the time frame is very short, because like within several weeks anybody can get funded. So let's take the example of a student that wants to publish on the protocol. Well, they would just have to have the best research as possible, the best proposal, and then they would submit the proposal. By the way, the proposal, it can be any kind of a file. It can be a PDF file. It can be a video. Technically, the protocol accepts any kind of format as a proposal. So there is not like any standard or rule about this. So any researcher could share their research, their proposals on the protocol, and within several weeks get funded. And the benefit of such a system is that since it's open source, it means every time someone shares their research, then it is accessible to the whole community and people can start to work together. And I think this is the reason why the AI space has evolved so much in the last few months and years, is because it is open source thanks to the first publication of Google. So that was my kind of accelerated presentation about HK, and thanks for listening.
Because we have one more speaker coming, guys. Thank you, Kevin. Thank you so much. Now, welcome to the stage, our co-host, Bharat Habram. Come on up, dude. Let's do it. So, I think you need no introduction, but I'm going to introduce you anyway, because you are the co-founder of DeSci London and Muse Matrix. Now, this is Get Involved in DeSci, a community call to action.
All right, awesome. Thank you very much. I'm just before lunch, so don't worry. I'll be like 5 minutes and we can all head off. I haven't got slides or anything. I've just got a bit of commentary on my previous experiences with conferences, why I started this and what I see the future direction. I used to be a medical doctor, and I remember the first academic conference I went to in my second year was a chronic fatigue syndrome conference. And I loved it. The talks were interesting. I met some super cool people. There was a lot of energy, a lot of feeling that, okay, we are doing something. We are going to be able to push the needle forward. And then I signed up to a master's, took a year at med school, and came back to the same conference next year. And I was like, this is eerily similar to the one last year. Kind of same speakers, same kind of topics, etc. But I was a researcher then, so I got lured back into this energy. And then, again, came back to the same conference the third year. And I was like, okay, this is the same shit. Like, apologies for my language. And I sat and had a conversation with the organizer for this, and they'd been running this for about a decade. And it was because he had 2 children severely affected with chronic fatigue syndrome, so it was very much mission-driven for personal reasons. And he looked super jaded, and he was saying, look, nothing's happening. We've been doing this for 10 years. And I had to, kind of console him, tell him, look, no, this is just the way, science works. We are making progress, etc. But I was lying to him. Like, I know I was lying, but I just was saying what I thought I could do to comfort him. And me understanding, having worked in the system for a year, I knew how much nonsense there was. To get a stool sample and blood from a patient took us 1 year to get ethical approval. To me, that made absolutely no sense. These are people who wanted to give it to us, we wanted to study it, but we were blocked by some kind of middleman, some kind of entity that to me made no sense. And this is what led me on the path from leaving the traditional system to where I am now, working on the intersection of science and blockchain. And any of my doctor colleagues have no bloody idea what I'm doing. They think I've lost my mind. And I'm not quite sure whether I have or I haven't. And so we don't just do conferences, we do these monthly meetups, and we did those for 6 months before we did our first conference, and that's why I think the conference worked well, because there were loads of people there that were volunteering and helping us. We've been running these monthly meetups, and we still plan on running these monthly meetups, but what I want to do is make sure that this conference is not the same. So you don't come back next year and it's the same talks and nothing's happened. And the idea is we can use this time in between to actually work on things, actually collaborate and actually build. So the combination of people in this room will almost certainly never exist in this exact arrangement ever again in history. So there is something special here, and I don't want to lure people in this false sense of energy that we're moving towards somewhere, and we don't. I think we can do something if we all contribute something, because my thesis is that there's something every single person in this room can do between now and next year to push the needle forward, and that could be as small commitment time as retweeting something or forwarding an email, all the way to leaving your current job and dedicating your life to this. So what we're starting this year is something called Muse Matrix, and it's a community-run fellowship where we're trying to bring together scientists, bring together Web3 developers, and bring together anyone in between, whether it's creatives, whether it's policymakers, etc., and try work on a small number of projects, but where we hone our energy and focus on it together and see what we can do in 1 year. So this is the experiment that we are officially launching today to see what can be done between now and next year. Thank you. So if you want to know more, there's a bunch of posters and QR codes where you can fill out some Google Forms to say what you want to sign up. Like I'm saying, every single person in this room can do something to push the needle forward. So let's see what we can do. That's it for my talk.
That was very short and sweet. Okay, let us definitely get some lunch here, folks. Now I have little announcements here. Food is in both the foyer and the workshop rooms, which are upstairs on floor 6. The floor 6 meeting room, workshop room is open. And everyone, please be back here, in this main stage area, at 1:15. Because we've got some panels and we're going to break out into workshop groups. So be back here at 1:15 and feast and be merry. Yes, wait, in the workshop. Yeah, wait, you, intro.
Sorry, workshop room at 1:20. If you want to learn about proof of knowledge, come there as well. I'm sure there's good things happening in both rooms, but come see us.
should we like
Shit. Do 25 minutes and we'll try and catch up through it. But we'll also flag you down.
Okay. Like, will you do the? Okay.
Someone
I'll just
will.
look.
Friends, welcome, welcome, welcome. May I have your attention, please? Merci beaucoup. Merci. Okay. So before we come back from our lovely lunch, I hope everyone ate their fill, hydrated, rested, overtalked, and is now totally overstimulated, is ready to sit back, relax, and learn more. I do have a very important announcement. Dear friends, this is an open building, and so people do walk in from other places outside of our community, and some things have gone, there has been a theft. So it's off. Yeah, that's my face too. Please, 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 please guard your belongings. We're still in London. Everyone touch base with all your worldly possessions. I see you all tapping your phones and your laptops now. Please maintain vigilance. Thank you. And if anyone sees a camera that is unclaimed, please do let me know. Thank you. Okay, so dear AV team, are we good to go? We're miking, folks. I don't think I have time for a joke, but you could pretend that I do. How are we doing? Is that a thumbs up, thumbs up, thumbs up? All right. I'm going to slowly introduce this panel. So it's our first official panel of the day, Why DAO? So welcome to the stage, when they are properly mic'd, Ionia Traxler of Hair DAO, Veronica Kieran of Asterix DAO, Christina Castro of Kimia DAO, and moderated, of course, by our dear friend, Erin McGinnis. Welcome to the stage.
Party. Oh. It's fine. Amazing. So today we have this incredible panel really diving into the question of why DAO. We'll be able to look at a few different examples of DAOs in the DeSci ecosystem. And to kick it off, would love for each of you to give a brief overview of what your DAO is and maybe something interesting about how your DAO is operating, maybe an opportunity that it's addressing, kind of creative freedom there. Do you want to kick it off?
Yeah, you're staring at me. So hi, I'm Veronica Kieran of Asterix DAO. We're working to shift the way that women's non-reproductive health is conducted at this time, because for so long women were actually banned from clinical studies and research, so we're just completely missing the whole picture. We're very concerned with the idea that bikini medicine is the norm, meaning that women are only different from men. Wear bikini covers, and we know that that's not true. So our job is to backfill the data and to maybe kick some butt along the way. We're finishing our white paper draft right now, so that's our stage.
Yeah. Super exciting stage. Yeah. Christina?
Hi, I'm Christina from Kimia DAO, which I would like to be a DAO for accelerating applied chemistry research. As I've seen that, well, chemistry will be required by many of the DAOs that currently exist, but there's no special focus in it. It's a bit of a forgotten, or maybe not so publicly known science. And at the moment, we're seeing how to set up a chemistry laboratory funded on the principles of DeSci, and we're just at the beginning, but so far it's been a very good journey.
Amazing. Hi, I'm Anya. I'm from Hair DAO. Our mission is really to find the cure for hair loss. Fun fact about us is we actually have a community-generated study that's happening at Imperial right now. And we actually have come out with a treatment that's in testing right now. So going to talk about both the theoretical and actually the practical benefits of DAOs and what they can achieve.
Awesome. That's a great lead-in to the question of why become a DAO in the first place. There are other options that were kind of highlighted throughout the other presentations today on you could go startup route. Why not just stay as some focused research organization or operate within a college or university type system. Maybe you're just a collective and focus more on that investment side. So why did each of your organizations take the approach or continue to take the approach of being a DAO? Great.
So I learned about DAOs first with Vita DAO, and I was like, wow, this is really amazing. And when I saw Valley DAO, I was like, wow, this is even more in the direction of applied science. And I just started thinking, well, there's so many, to the point of why not just stay at the university. There's many research groups in the world that are not doing a great job at collaborating and cooperating with one another. And I think the Web3 and DeSci tools just allow that to happen just easier and like more seamlessly. And one comes in contact with people that you would never come in contact with or work with. And I think that's like really the most interesting aspect of this sort of new approach, that you end up working with people that you never would have or would have never met even at scientific conferences. So I think that's to enable the collaboration across groups of people that maybe are not the most socially able to engage, like do these collaborations if there's no ease for them.
Oh, me, okay. Hello. Yeah, so we looked at a few different structures, and I've done traditional startups before. And that actually leads into one of the reasons that I thought a DAO was the right choice, is because I actually sold one of my companies simply because I was burnt out. Not because it was ready to sell or I wanted to sell, but I couldn't do the work on my own anymore and be a solo leader. And we get led into this fantasy about what leadership is and what founding is. And when you're in a DAO, you can say, you know what, I'm not doing so hot today. I need to tap out, and the rest of the organization comes in. And so the work doesn't stop. And when you're doing such mission-driven work, you don't want the work to stop ever. And that's another reason the DAO is so fantastic, is because you can start to involve people from around the world. It's fully decentralized. So what capitalism does is it pushes us towards power structures, and people want to amass power, and then they want to cloister their IP and keep it behind walls, just like you were saying. So when you're in a DAO, that's not happening anymore, and you can involve previously disenfranchised groups. So we can start involving people, whereas research typically is done in the global north, right? Now we can start involving people in the global south, and if you're trying to conduct real data collection and information collection, you have to have that. And then just as you said, the acceleration, the collaboration, the ability to go beyond what even your own organization is doing is freaking amazing, and it's very exciting.
Yeah, I mean, to do it in the traditional research realm is actually quite difficult in the hair loss space. It falls within that kind of overlooked area where, even though, I think 80% of men and up to 60% of women struggle with hair loss throughout their life, it's not actually classified as a disease. So early stage funding, very difficult to get. Pharmaceutical industry, also not particularly interested in it because, they can't get reimbursed for it. So the DAO structure works because people who have hair loss and have not been catered to, because the solutions that you currently have are riddled with a lot of side effects, have come together to learn a lot about the literature. Many of them aren't actually academics, but know the research, know the science better than at a lot of elite universities because they've been impacted by it. And the really cool thing about it being a DAO is you have all these disparate sources of knowledge come together. It's very meritocratic. It's about the scientific method, more so than maybe in the hierarchical academic sense, where it's not the best idea that wins. Here, people debate it out, and people put forth ideas that they want to fund, and then they can actually get funding. So you don't have that same issue of the professor that's tenured who, we had the example from Cerebrum DAO this morning that, it's been the same research hypothesis in Alzheimer's for over 30 years, hasn't led anywhere. Turns out the seminal data is actually forged. And you can't actually research anything else because, well, that's the paradigm within which you have to research. You don't have these restrictions when you're operating in a DAO.
Definitely. A couple of you have started to touch on just how powerful DAOs can be from that people coordination layer, both within the organization to allow it to be more resilient, as well as maybe questioning the status quo or kind of allowing for exploration into different domains, inviting new people in. Are there any other elements just in the conversation around maybe addressing underfunded research areas or allowing different marginalized or underrepresented people or community to participate in some of these different systems that historically may have been not quite as encouraged? Any other points on those you want to elaborate on?
Just, you know, the long-term goal, our North Star, is that when you have a group that's disenfranchised, right, their voices don't matter, right? Especially in the power hierarchies that we have going on today. And so if you have a DAO and you have people from all over the world who own a token or a fraction of a token within the organization, all of a sudden, for the first time, you have people steering their own medical care. It's absolutely mind-blowing, and that's terribly exciting for us. That's where we want to be in a few years.
Yeah, and you can see this all across the board. I mean, if you look at a lot of how funding is distributed, it's very much in this utilitarian fashion. So where you have most of the money going to the conditions that most of the people are afflicted by, which is great if you're one of them. But if you're a marginalized community, or if you suffer of a disease that's maybe a rare disease, for the first time you have the tooling where you can get together as a community, discuss. You have that shared language, so you feel heard. You're suffering from it. You know what you need best, and you can pool resources to actually make that happen. So I think that's one of the reasons it's so powerful for marginalized and overlooked communities.
Mm-hmm. Yeah, and I think on your point of the kind of local aspect of these communities once they form is that, for instance, if in the applied chemistry realm, it's the people that are on site that know what their problems they're facing that are specific to them, and if we could deploy kind of the right kind of chemistry knowledge that you need to solve those problems, then you could do it in a very tailored fashion all over the world instead of just doing one particular solution for everything. And I very much like I think DAOs also play a sort of educational role, and that's what I thought was most interesting for the chemistry, because, I've heard a lot of people be like, oh, but there's got too many chemicals on it, or, it's been kind of tainted in its reputation. But these kind of initiatives should bring in more people through the lens of, okay, how can we use what we know in this realm to actually solve a problem? And I think that's presenting science in that way is very powerful.
Definitely. There's a lot of opportunity to make some new decisions around solving some of these scientific problems. And one question that I think could be curious to explore is how can DAOs, or how do DAOs help democratize some of that decision-making processes that might be at play within your organizations, or as you're designing out your different DAOs, as well as how does that tie into some of the traditional hierarchical scientific systems, maybe from HairDAO's perspective?
Sure, yeah, it's a great question. Just as I previously mentioned with Alzheimer's disease, I actually have a friend who wanted to pursue Alzheimer's disease, ended up deciding not to, because as I mentioned, you have to research within that given paradigm, because you have that hierarchical power structure. Within DeSci and at HairDAO, I all urge you to check out the Discord. What you really see is people enter, they talk about the research, and they debate it. It democratizes it because everybody can come in. And the best ideas, they should stand by themselves. And the way we actually look into, okay, is this idea a good idea or not a good idea, is that when people post and there's engagement, you actually get hair points. And this is a system where actually the higher your reputation is, the more your engagement with a particular idea will lead to more hair points. And these hair points are translated to our governance token, the hair token. So if the community decides that, hey, we want to look into this project, they can discuss that. It's put up for vote on Snapshot for all of you guys to see if you want to. And then actually with your governance token, you vote on whether this should happen and this shouldn't, or whether it shouldn't. So we've funded multiple studies this way. I mean, as I said, one here at Imperial, one at the University of Brasilia, and one which has led to our first patent and our first treatment. And everything's open. You're all welcome to look at it. You're welcome to look at how people voted. Yeah, it's completely democratic, and it's really about the scientific method and the best idea standing for themselves.
From maybe a little bit earlier on, HairDAO has been around for a little while. Yeah. Are there any elements that you're taking into consideration as you're forming each of your DAOs, kind of tying in this whole idea of democratization?
Yeah, we're looking at our structure very closely, like how are we going to govern to make sure that there isn't a centralized voice. You know, we're at the stage right now where I'm like the one flying the flag all the time, and then we've got an all-female team so far, which is really exciting, but eventually we want thousands and thousands of people around the world, and we feel that breaking that global north paradigm in research is really critical. So part of our initiative is to make sure that we're getting members and ambassadors to help us get members from every country around the world if possible. Because it's, you know, the honest to God truth is I'm a white European woman. So I can't speak to, you know, the medical needs of a woman who went through female genital mutilation. And how dare I should, right? So, but we need those voices if we're going to do women's non-reproductive health. So we have to, that's one of our major cornerstones, is making sure we have all those voices involved.
In our case, I've just been thinking if successful with setting up a sort of DeSci-inspired lab. There will be some decisions that have to be made on sort of like facts alone. So I've been discussing with, again, a person that I would have otherwise never met. On voting systems that have an aspect of like opinion, let's say, and an aspect of like what the facts are telling you, and how we could construct laboratories that operate on obviously using both, so that we can have people partake in these initiatives that are not necessarily professional scientists, but also obviously not avoiding the outcomes of the professional science in the voting. So I've been thinking about that being very important.
Very cool. Absolutely. And kind of as we're thinking about the different opportunities DAOs can provide for, as well as some of the different challenges DAOs might face when interfacing with the traditional scientific system, what are some of those different considerations or conversations you might be having within your organizations? And what, I know for instance at DAO, like there's talent on that tech transfer side and knowledge coming in from that angle, which is an essential piece to the conversation. What are some of these other factors?
Yeah, you can see like I'm just like laughing because like really, so like DeSci has this nascent challenge that med tech is very old guard. We do it this way, and this is the way it's been done, and we can't change that. And so there's this enormous hurdle of like what I call front loading. You have to pre-educate people. For us personally, then also we're focusing on women, and unfortunately women just don't go into tech, and that's a whole historical issue that I'll speak to tomorrow as an anthropologist. But so then we have to pre-front folks who we want to be part of our membership too. And so there's a lot of pre-education going on before we can then start to have the conversations of, okay, like now sign on the dotted line.
Yeah, one of the difficulties or challenges I've noticed, and I think this is true for HairDAO, but a lot of the other DAOs in the space, is issues around UX and UI, so user experience and user interface. What we find is that the kind of crypto native community, they have quite an ease with Discord, but for scientists, researchers, doctors trying to access it the first time, it's nearly impossible. It's very, very difficult. And you also have this the amount of data that gets generated, the great insights that people provide, they just kind of stream by and get lost. So I think around UX and UI, we really have some challenges, but also opportunities. And I think as we build out products, we should make sure they're quite similar to Web 2. So like online applications, you just enter, a website domain. And I think that will also really help us scale as the DeSci community, because there are a lot of researchers that are interested, a lot of doctors, but we really have to provide the toolkit to make that easier. Yeah. So.
Yeah, I think that the current chosen toolkit doesn't seem to be that chemist-friendly. It's actually I've found all sorts of people, but not chemists. Yeah. So I think they just don't spend much time on Discord or Telegram or even X. Yeah. So that's, it's not so easy with it's kind of like niche still, the UI. Yeah.
But I think in terms of opportunity, what we've really seen within the space is that this mentality of cooperation and coordination that you see in a DAO, where people freely share information, as opposed to academia, where people won't discuss between labs, and in many cases even within labs. It's really powerful when people start moving towards, and it took some rethinking as well first joining. It's really a mind shift, and I think when that mind shift trickles into academia, that's really powerful. So I think that's really a big opportunity as well that we should be speaking about.
Completely. You each are working on some really incredible initiatives as so much of the DeSci space. And with that, would love to have you share what's kind of coming up on the roadmap for each of your organizations, and also if there are people here listening in, how might they be able to get involved with each of your orgs, or commentary just on the space generally? I know earlier we shared that most websites, most DAOs have like join our community, join our Discord, join a working group. So that invitation seems to be quite open. But what are those specific opportunities for each of your missions and organizations?
So our DAO is basically just starting, but there's one thing that we really want to demo, which I've been thinking about, which is this protocol I'm calling proof of synthesis, which if managed, if it could become a reality, it would be a blockchain-based way of keeping track of the steps in a chemical reaction so that we can prove the steps in a certain procedure for the synthesis of something have been carried out, when they have been carried out, how they have been carried out, to be able to transfer to whoever wants to carry out these syntheses that knowledge via the blockchain ecosystem. So there are some initiatives for doing this in the regular non-blockchain space, but of course there are sort of closed source, and I think they're overseeing this opportunity. So the idea would be to show that you can have such a system on chain, and that perhaps having it on chain has certain benefits, and that's what we're going to attempt to do. So if anybody here is a chemist or is interested in that, please do get in touch with me or find us, with our name. That's what we're thinking of doing.
Super cool. Yeah, for us, we currently still have a bunch of studies in the pipeline. As I mentioned, a lot of them really focused around reducing the side effect profile that comes with the drugs, which are pretty severe, as I mentioned, range from erectile dysfunction to depression. We had a lot of people in our community actually quit their jobs because they're so bad. So we have those studies that are continuing. We're trialing our first product that we developed, so people are rubbing that on their head. Building a telehealth right now so that these products are available. And yeah, we're actually also building out our platform, as I mentioned, to make it easier for people to share their experience with hair loss, but also have a resource that they can consult, because you really have this audience that is super knowledgeable, that wants to share and really wants to help you out. So if you want to get involved, feel free to come chat to me or check out our website, which is hairdao.xyz.
Yeah, so as I mentioned at the very beginning, we're editing our white paper right now. We're planning to roll it out at Block Split. So if you're going to be at Block Split in a couple months, keep your ears peeled, if that's a phrase we can use here. And we're definitely looking, with the white paper coming, for a token economist. We're just going to portmanteau the heck out of these words. We definitely need a community manager or a social media manager just to help us accelerate the content we're pushing out, and some research devs would be freaking great too. So we're on the acceleration path. We're ready to take you all in.
Yes. So many really incredible opportunities here with these DAOs, as well as so many others in this space. I know a bunch that sponsored here, also hiring, and I, for one, am super excited for how DAOs can really help accelerate in different rare diseases that have been under-supported, underfunded over time, and just those different coordination layers and the connections that are forming between a lot of these DAOs as well. So wanted to thank all of you for sharing all of your expertise on DAOs, why DAO in the DeSci ecosystem, and you all will be around for more questions, so definitely come connect with them.
And also
They're
thank
incredible.
you for great questions, Erin.
Yeah. Wonderful. Well, that concludes our Why DAO panel, and we'll move on to some more amazing talks.
You do my job for me. I'm just like, yeah. Thank you, guys. That was awesome. Thank you, thank you. Okay, so our next talk, our next talk is Liga Kornowska, and this is the DeSci Profitability Playbook, the case of Data Lake. And of course, Liga is from Data Lake, so welcome. So what? Yeah. I think so.
Can you hear me? 1, 2, 3. Yeah, it's working. Great. Great. So hi all. My name is Ligia. I am co-founder and president of the board of Data Lake, and I am really excited to meet you all today and to show you our case, our business case of Data Lake. As you could hear of in actually every presentation before me, when it comes to research and development, it's all about the data and open access to medical data for research, for development, for every DeSci project. And we as a Data Lake are opening access to data, to medical data. First of all, few things about our team. Our background is healthcare sector, legal sector, and tech sector. I worked for 8 years as a managing director of the biggest hospital organization in Poland, which associates together more than 550 hospitals. I also was responsible for the first code of conduct for healthcare under Article 40 of GDPR. This is actually the regulation that tells hospitals how to protect medical data. I am also responsible for other technological stuff like AI regulations or co-regulations in hospitals. And my co-founder, Wojtek Sierocki, is a serial entrepreneur. He actually created the first and the biggest foundation that delivered medical stuff actually to Africa. He also created the first telemedical company that provided telemedical solutions in Kenya. I am also today here, I am also with Piotr, which is our legal architect and was responsible for the first regulation in Poland that actually allowed to use telemedical solution. I can see he's filming me right now. And Andrea, our great and brilliant mind head of marketing. So we are actually from this business sector, and we got involved in the blockchain sector because we believe that blockchain could solve our problems, and it actually did. So our company right now, after 4 years of working and 2 years in a blockchain technology, has more than 10 agreements signed with clients, including two of top 10 pharma companies that we cooperate with on medical data analysis. We gathered more than 60,000 consents, patients' consents, for sharing their medical data and using their medical data in R&D projects. We also got involved in clinical trial sector, and we have more than 20. Actually, it's more than that right now. Clinical trials on our platform, and we like to deliver what we promise. So, what is our data lake application? In the most general way, we can tell that data lake application, it's an application that enables creation of a large-scale vital referral network for collecting consents and collecting informations about users. It's about collecting consents online and offline for patients when it comes to our business case, collecting some other informations for patients because when you run R&D project, you don't want data from any patient. You want data from patient that suffer from this particular disease and has this particular diagnosis, for example, when it comes to radiological images. So we help to find the right patients, asking them the right questions, and collecting consents from them for using their medical data. This way, we can scale our projects, but we also follow the rules of privacy, and we give patients the decision about their data to their hands. So how does it work? Oh, I think the slide is broken, but I will tell you about it. So it's just really simple. So maybe it will be enough if I just tell you. So first of all, you can put a project in our platform. Project means survey and the content of consent. Survey is about checking if patients, for example, suffer from that illness that you are thinking about when it comes to R&D project. Consent may be. Actually, content of consent may vary a lot. For example, it can be consent for using their medical data for R&D, but it can be also consent for using their biosamples for R&D. We cooperate with we are in the process of cooperation with biobanks in Poland. And it can be, of course, consent for marketing options or for preselection to clinical trials. Then you can use your own, or in the near future, our referral network of hospitals, medical personnel, people that have contact with patients, and they can collect consents from patients. They can do it either online or offline. Our application allows both of that. Then, when they give you a consent, they can of course log into the platform and, for example, withdraw that consent or give another consent if they will. They can claim their benefits, but then you have their consent, so a key to unlock their medical data and download it, for example, from hospitals. You know who collected that consent, so you can benefit people that you cooperate with, for example, hospitals or medical personnel. And then you have that consent saved on a blockchain technology. So you are sure that this patient gave that particular consent during this particular day at this hour. This is super important because this is a real utility of the blockchain technology that is crucial from our client's perspective. Because if you gather like thousands of consents, you have numbers of patients that, for example, tell you that, no, I didn't give that consent, or I withdraw that consent this day and you still used my medical data. No, with blockchain technology, we are sure when you gave and when you withdraw consent. This is super important, and this is one of the reasons why we use blockchain technology in general. So our applications looks more or less like this. I will show you the whole application during our workshop in half an hour. So you are invited to this workshop. It's on 6th floor, I believe. So we can find project, you can onboard patients or users, because we are not only about healthcare sector, but we like personally are involved in the sector, healthcare sector most. And you can even choose the way the consent is signed. For example, sometimes you need only a confirmation on email, but sometimes you need a physical signature of patients that collect biometrical information, and we can gather this kind of consent also. And you choose what kind of signature it should be. So what is our use cases, real use cases of real projects that we actually run or are involved right now? First of all, based on patients' consents, we can download their medical data and do a lot of analysis on medical records. For example, one of our clients was interested how patients with breast cancer are treated in Poland, in specific regions. So our client had questions like, what was time from the diagnosis to treatment? What kind of treatment did patients get? Did they get standard chemotherapy, or did they get the newest technology, newest drug, for example, that is financed in the drug program? We have this special way of financing very expensive drugs. It's named in Poland the drug program. And for example, why this patient stopped receiving a treatment. So this kind of questions we were able to answer because we had medical data and we analyzed medical records. And this was like hard data that our client could use, for example, when it comes to cooperation with public entities and negotiations of, for example, drug price. Other case that we are working right now is patients registry for patients with very specific rare disease. So we collect the data about this disease from patients and from hospitals they were treated, and we created registry that is updated every 6 months. So we can see how patients are treated, how they respond to treatment, but we can also see how was it possible to diagnose them? Because when you have a rare disease, you probably, before a diagnosis, you have like 2, 3, 4, 5 years of being diagnosed and nobody knows what is going on with you. So when you have a patient's registry with this particular disease, you can check what was the specific symptoms of the illness and what was the patient's path. For example, if patients went to this particular doctor, then this particular doctor, then to the hospital, it may seem that they can suffer from specific rare disease. Second case, because I think I don't have to tell you how valuable is medical data market. But we have entered the second market, very valuable market. It's a clinical trials market that is like $100 billion right now, and 30 or 40% of this budget goes into patients recruitment and to finding the right patients. So we actually get involved in this sector because finding the right patients and gathering information from them, for example, contact details and information about illness they suffer from, it is the same business as business with medical data, right? So we right now have more than 20 or more than 30 clinical trials on our platform. We have plenty of hospitals, hospital networks, hospital information system providers that we cooperate with. They help us to find the right patients that meet inclusion criteria and can be pre-selected to clinical trials. We have right now a couple of patients, including one of the biggest one involved in clinical trials for Central Eastern Europe. So, question that I get a lot, actually 2 questions, is why don't you do it on paper, right? Of course, you can do it on paper, but please imagine having 60,000 papers and, for example, one patient that wants to withdraw this consent, or that you have like to coordinate information sharing between different data controllers. It's actually pretty impossible. Second question is that I get a lot is why blockchain technology? So I think I answered it a little bit. But the thing is, when you gather a lot of consents, you have to be sure that this consent was given on this particular day from this particular patient, and this was about this particular content of consent, right? You can do it on paper, but when it comes to, when it comes to thousands of consents, it's very difficult. And when you use like standard hospital information system, administrator of that system can always interfere with that system. And if you save information on a blockchain technology, there is no manipulation of the data. So our app is GDPR compliant, but what is even more important, there are new European regulations that are coming into place, or one actually already came. This is Data Governance Act that is actually about sharing data, not only healthcare sector, based on patients' consent. And there is a European health data space that also says that you can use medical data of patients, but you have to ask patients for their consent or for their active withdrawal of consents, depending on what kind of data you want to deal with. So our application is in line with these regulations. This is very, very important. Second thing is how to make your referral network to collect consents for you. So the answer is rewards, and we have rewards on our platform. We used rewards, for example, for rewarding patients in our oncological project. That was rewards like this was our token, native token lake, that you could actually exchange, for example, for discounts for Nutri-drinks or some other healthcare stuff. But you can also reward consent collectors, so people that actually collected this consent from patients, so they are motivated to collect more and more consents. And second thing is architecture of our platform. We actually made a lot of effort to make our platform very simple and very easy to interact with, and actually very fast to collect consent. So we are right now on that stage of the business that we created the platform. We are our own clients because we use that platform and run a number of projects. And we want you and other projects, DeSci projects, to use that platform and to actually be inspired of our case and benefit from other projects in cooperation with pharma and tech companies. Our platform is actually, we have the whole granting program when it comes to using our platform. And even without grant program, you have to have like I don't remember right now, but I believe 10,000 of lakes to use the whole platform. You don't even have to spend these lakes, so it's really cheap for small researchers and researcher and development department that are not like commercial companies. So we invite you to cooperate with us. We would like to share our case, and we would like to inspire you to use the same technology that we use in your areas of expertise. Not only in medical sector. Medical sector is really important when it comes to research and development, but you can use this platform also in, for example, climate sector or. We are in discussion in the banking and insurance sector when it comes to our platform. So that's all from me. We have a workshop at 2:30, and I truly invite you for that workshop because we'll have some more time to speak, and I would love to learn more about your projects. It's actually, I am really excited after hearing all of presentations from the morning. And if you would like to grab a coffee and talk about DeSci project, you can use this QR code and plan a meeting, or just come to me and start talking. So thank you. Are there maybe some questions?
We have time for one question. So who is going to be my lucky question person? Yes, my fine friend, you are the winner.
What is the gap in the current NHS database system, which your blockchain could possibly address?
So what is the
gap in the current NHS database management system, which stores and data from all the patients, in a centralized way?
Okay, so maybe I will start with that. Our system is not about collecting and storing medical data like electronic health records. We think that saving electronic health records on the blockchain technology may be illegal in European economic area, but we save information about consent. So we are not saving data on a blockchain technology. So our application is used for other systems to know that this patient gave their consent, and we can download data from this particular patients because we have a consent. So this is, I don't know if I answered the question because no?
This is awesome, guys. I was distracted by a dog down here, just so you know. Thank you so much.
Thank you.
Okay, so I'm going to like to welcome our next. Amazing. So yes, folks, you saw the QR code, you've heard the announcement, join the workshop at 2:30. There's clearly a lot more to discuss. So, Martin Carlson, come up here. So Martin is from Coordination Network. I almost call it Coronation Network. Coordination, I think it's a bit more useful. Achieving perfectly informed decisions to solve the world's hard problems. I like it. Welcome.
Thank you. Thanks, everybody. Great to be here. So yeah, what I'm going to be talking to you about today is I think I wanted to take an angle of how do we make this world that we're trying to create a reality, and how do we succeed in overcoming these incredible incumbent forces that might make that difficult. And the way that I'm approaching that is by focusing on how this environment makes it possible to aspire to basically enable perfectly informed decisions when you're trying to solve these hard problems. And I know that that's a huge statement to make, but I think that's where the principles of this community, what makes possible. And my tagline is basically the barrierless future on our doorstep, and the role of DeSci in making it a good reality. And the reason I mention that is because essentially we're at an inflection point right now, and I'm sure all of you have seen a lot of the buzz going on in terms of LLMs and AI and so on. And I think it's important to state that in terms of what direction we now take with these technologies and the acceleration effect that they might have, we're at a very important point to decide how to do so. And I think DeSci and the programmatic incentives that they enable really give us a way to align these new technologies with societal needs in a way that overcomes a lot of the legacy bureaucracy that has led to bad outcomes. So that's why I had a really long title, but my other title would basically be Preventing a Dystopian Hellscape. And the reason for that is that we're at a stage right now where if our legacy methods are what we channel this new technology into, we're going to be reinforcing incumbent issues in a way that becomes very difficult to alleviate later on. And so I think many of you here, being scientists and being involved in very complex areas, you know that we're facing global complex challenges, and you know that, but you also know that the technologies and pathways to meet some of those challenges are actually here. But it can be very difficult to tell that narrative in today's environment, especially with some of the attention spans that are in a lot of mainstream channels. So what we want to do is basically facilitate a way where we choose the right path now and bring together these communities to make the good realities happen. So in DeSci, in crypto in general, you'll see a lot of memes. You might have seen this one quite a few times, but I like how memes kind of can summarize things in an image. And right now we are at a crossroads where essentially on the one hand you have a pluralistic utopia where you have DAOs coming together representing the desires and needs of different communities and having composable network environments where those needs can speak to each other and come up with harmonious paths going forward. And then you have a centralized dystopian rule by the few scenario where basically these AI models entrench the power of a limited amount of people where they basically set the narrative, which would be very scary. And I think in terms, we can articulate the ideal, but we also need to make it the best path, essentially, for people to take. In a sense, I think of this of how you make it basically uncompetable by really speaking to the needs of the end consumer and the end users and the societies that it supports, and also those that deliver the solutions that they need. So this is really one way to put it again in a meme, is that rather than having extractive systems that consume your expertise for the benefit of centralized owners rife with incentives for misalignment, we should have an environment where you're contributing to stakeholder-governed decentralized networks with incentives directed at alignment where you are one of those stakeholders. And I think the important point to emphasize here, and I think the panel touched on it earlier, is that in DeSci, we actually have a huge competitive advantage, which is the transparency. And this was mentioned earlier because I come from a background where I worked with a lot of legacy organizations, and I know how tough it is to try to make anything happen when you're talking to a multinational with lots of different stakeholders and politics involved. So it can't be understated how powerful it is to be in an environment where openness is the default. However, on the flip side to that, and also as mentioned, the UX around navigating this type of decentralized environment can be challenging because sometimes it's like herding cats and there's information everywhere and you have to learn new interfaces. So what we want to do is basically solve that problem, create really intuitive experiences that help align all the different people involved. And it's fundamentally empowered by the openness of people to collaborate and share information. So this is the environment in which you then have the opportunity to basically make perfectly informed decisions because you can be connected to a hive mind of essentially the expertise you need and the data that you need at any point in time adapted to exactly the question that you're asking. So when it comes to this question of how do you make perfectly informed decisions, there's this concept called the OODA loop. I won't go into it in too much detail right now because I have limited time. But in essence, it talks about this ability to basically get an overview of this process of basically observing your reality, getting input from what is happening, orienting around your internal principles, and seeing how that data can then be processed into making hypotheses of what action to take, then taking that action, and throughout that process, feeding your learnings back into your observation, and basically doing this loop as effectively as possible. And I like to put this up because this is essentially what we're trying to help facilitate for every DAO and every individual in the DAO so that they have full coordination mechanism within what's going on, how can they act, what's their highest leverage move to help move them forward to achieving the goal of the DAO. And the second piece to mention is that John Boyd, who's the creator of the OODA loop, he was an Air Force pilot, and he also made the point that there's no way out. We must continue to the whirl of reorientation, mismatches, analysis, synthesis over and over again ad infinitum. This OODA loop, it can be very overwhelming. But luckily, this is where AI can be used in a beneficial way of actually allowing you to keep track of all this personalized to every individual. And so what we've been doing has been really getting our hands dirty, working with a lot of these fantastic organizations in this environment to see, okay, as I said, trying to get to a point of perfect decisions is a big claim, so we wanted to make sure where are we today with the technology available to help facilitate this. And I should also emphasize that this would be impossible in an environment that didn't have openness as default. I came into this community, I think it's just about 2 years ago now, and I said, here we have the opportunity to achieve this, and I've just started going into these DAOs. Like people say, go into the Discord, start talking to people. That's what I've been doing, and they come open to hearing ideas, trying new things, and this is really a collective effort to try to achieve this. So some of the methods that we've been developing are things like rapid evidence collection. So if you're making a claim of taking an action, how can you rapidly know the state of evidence available in the literature? Road mapping and tech trees. This was an approach, really a lot of effort went into it from the Foresight Institute, where it's around mapping the dependencies to achieving complex outcomes. And then with Cerebrum DAO, who you heard from earlier, I should mention that across these methods, they're not kind of unique to one, but with them, we've also been looking at how do you then, if you identify a bottleneck, source researchers who can help you unblock that bottleneck. And finally, with Molecule and Logan, who you heard from earlier today, how can we capture best practices around proposal writing and proposal review in a way that makes it so that when you come to one of these DAOs and you come in with an idea, you can have a seamless experience of seeing how it matches up to the DAO's values, what they're currently working on, and on the flip side, for their internal teams, how can you make it a seamless experience for them to review those proposals as effectively as possible so that you can have very substantive conversations. And so far, the response has been great. And I think one thing to mention, for example, from HairDAO, in HairDAO case, I think like HairDAO is definitely one, if you want to see a live hive mind in action, go to the researcher channel in the HairDAO's Discord. It is unbelievable. And I mean, this is why, I mean, I'm now a happy purchaser of HairDAO shampoo, which is I've started, my receding hair has started to happen. And HairDAO has a solution that I've like had tiny little role of being able to be a part of, but a lot of other people did a lot more. But it's really incredible. This is actually happening, essentially. So it's just to say that basically with this environment, we've had a chance to really see where are we today and what are the steps to take to make it even better. Another couple to mention is that patent review is also something that can be streamlined in this way. And even more exciting, there's been people working on open source platforms to be able to run computational biology experiments that you could then also call via these type of mechanisms. So the next thing to say is that I won't do a demo here because this is a PDF, but I will do a workshop. So if you want to see anything live, please come by. But one of the key points to this is also that basically all of these layers, all those methods that I just spoke about, are being built in a way that they're composable so that they become an ideal partner for if you're going to have basically swarms of AI agents helping you undertake these tasks. Because what you enable is that you can go from a 30,000 high view, for example, a tech tree, showing you the pathway, zoom down to one dependency, and basically understand, what do we want to do here, and then actually guide in terms of research and experimentation agents to be able to do what they are currently capable of and feed it back into this loop. So you get this dynamic living representation of the state of the art at all times relative to different inputs, all working towards a shared common goal that all participants in the DAO and different stakeholders can speak to understand what is happening at one time. So this is what we're working towards. Now it's important to state the current state of the art, there's still a lot of things to figure out of how you make this seamless, but the key pieces are there in terms of the openness of these communities to collaborate in this way, and also the programmatic incentives that help align both the budget mechanism, but also the individuals involved in terms of curating this information and so on. So it's really this is unbelievable almost for me that this is now possible, but it is, and so that's very exciting. And from a UX perspective, people were mentioning kind of the challenges of getting into the space. What these capabilities will allow is that you can literally come in and you can make these very simple statements to a DAO's entire collective knowledge where it's leveraging behind the scenes a very rich context understanding of these different pieces. So here, for example, this would be more of an internal case where someone might say, come with a proposal and one of the internal team wants to ask, how does this stack up against current literature and does it map to our tech tree? But you could also flip it around and say, I have an idea, how does this map to the values of the DAO and what they're currently looking at and so on, and gives you that first step without needing to get deep into what is actually going on. And so, this acceleration effect and this coordination, the reason why I mentioned at the beginning the importance of kind of this moment in time is that this then is in a world where that acceleration and the gains from it accrue to you, the contributors and stakeholders of this system, rather than to a smaller group of people who fund closed systems. And it's also important to say that this data can then be stored in composable environments where you choose the level of access that's available so that they collaborate seamlessly across each other as well. And this is, again, where the openness is key and the programmatic incentives that enable it are vital. And so, all in all, this gives you this way to catch this acceleration wave that is underway. It can feel overwhelming. As someone who's living it day in and day out, it's intense and kind of wild. But this gives you a way to kind of fully translate that productivity game into aligned outcomes where human involvement is about deciding what futures we want to see. And just to briefly speak about how we think about making this a sustainable system, essentially we're structuring it so that the tooling that is being built can help solve problems faster, And where rewards are associated with those solutions, most of that goes to the people that solved it, but there's also a way where that then can support the contributors that helped facilitate the increase in speed to achieving it. And this, again, is only possible in a world where you have programmatic tokens available, because if you imagine the legal work that you'd have to do in a legacy environment to try to even do this with one organization, it gets pretty complicated pretty quickly. So as I said, if you want to see where we're at currently, I have a workshop at 4. The emoji on PDF converted into a slightly freakier looking emoji, but I won't be smiling that intensely, but I'll happily answer any questions and show you what we're doing. And I just want to, as I come to my conclusion, emphasize something, which is that this would not be possible without the DeSci community. I was at DeSci London last year presenting an earlier phase of this, and now we're here sponsoring it. It's like, and so and also Bharat made this point. In terms of sponsoring it, for me, it's like this is all about how we give back and accelerate this process more and more. And I cannot state how incredible an environment is and how optimistic it can make you to be surrounded by people who are trying to work together to create these new and better worlds, basically. And that's coming from someone who has, gone through the mud of legacy organizational structures. And if any of you have yet to experience what it's like in this world, I highly recommend to try it, even if you have to go through Discord, because it really is something uplifting in a time where a lot of things can feel overwhelming and negative. And so just to emphasize, what we're building is an open source platform. You can also use it for yourself once it comes live, I think end of April. You can choose how much you share, and we have this idea of working towards like local first and then scale up to being able to collaborate as you see fit. So if you want to help us make it a reality faster, you can join the network, go to Coordination Network, and we have different paths for signing up based on different interests. There's a type form, you just fill it out and you can talk to us. But come up to me at any point as well if you want to. So I will pause it there.
Thank you, Martin. Okay. You've successfully got us back on track, which means if there's a question, we have time for one question. Who will be my lucky question winner? Yes, sir, with the purple shirt.
Hello, baby. Oh, I know.
Okay.
Magnus, do you think your system will manage to reach perfectly informed decisions on very contentious issues like how bad is climate change and how safe are various vaccines and should we be slowing down the development of AI? And can it actually reach a consensus on what is the truth on these matters?
Yeah, so I was anticipating something like this question, and it's a very good one. And I think what my answer would be is that the world that we want to aspire to is a pluralistic one, in the sense that different opinions should be able to come together. And what it aims to do is raise the bar for that conversation so that there's substance behind the dialogue, to put it that way. To your point, there's definitely going to be conversations where people may not come to agreement, but the goal is to make the tools available so that if you have that discussion, it encourages the pursuit of evidence and substance over simple rhetoric and populistic, let's say, shouting matches. So that's my way of answering that one.
Excellent. Thank you so much, Martin. Okay. I just put it on that desk. Okay, so it is my absolute pleasure now to welcome our next speaker, Cajun Franks. So Cajun is from Vector Space Bio, and this is Biology in the Space Industry, how DeSci, Space Biosciences, and AI connect. I love the space theme. Welcome.
Well, the fact is, we're not going to be establishing lunar bases. We're not going to be sending people to the moon. And we're not going to be going to Mars or going after trillion-dollar asteroids, quadrillion-dollar asteroids, or quintillion-dollar asteroids, and they are out there, verified, if we don't understand how to protect and repair the human body during spaceflight. And that is space biosciences. And you might ask, what is space biosciences? Well, I can tell you one thing. It's the biggest elephant in the room in the space industry. And it also represents the biggest opportunity, the biggest total addressable market that will ever exist. This means protecting humans during spaceflight. This means protecting them based on countermeasures that can be developed against diseases that result from stressors during human spaceflight. A countermeasure might be a repurposed drug compound. Maybe you've heard of Novo Nordisk's Wegovy, an obesity drug being repurposed for heart disease. A countermeasure can also represent a drug cocktail or a nutrigenomic cocktail filled with micronutrients or biochemicals that target your omics, your multi-omics, not just your genome, but your transcriptome, your inflammasome, your epigenome, and the list goes on, your microbiome. So when you look at creating a countermeasure, obviously that takes understanding what the stressors are. And the stressors in space biosciences, that define space biosciences, represent microgravity and radiation. Microgravity is a big one, so is radiation. Microgravity resulted in Scott Kelly, the guy that spent a year in space, having 30% of his heart muscle mass reduced. Also, bone density loss. That's microgravity for you. There's a lot of other drawbacks to microgravity related to animal biology and plant biology. When you look at radiation, radiation comes in the form of galactic cosmic rays. Some of them come from SPEs, or solar particle events. Well, these GCRs, galactic cosmic rays, are made up of about 85% protons and a couple percentage points of what are called HZE particles. These HZE particles are high charge, high energy ions. And iron being the worst, when it travels through your body, shielding does not help, by the way. So when these particles come from a supernova, a sun dying and exploding, they travel through your body and they can create up to 1,000 double-stranded DNA breaks, DSBs, double-stranded breaks. That's what happens when a particle comes, and along with its track, these are electrons that are emitted, and it barrels through your body, and it will run into DNA and break it in two. That's a DSB, double-stranded break. Now, your body has DNA repair mechanisms. Many of you have probably heard about them. DNA repair genes, proteins, pathways, enzymes. And they all work together to engage in something called NHEJ, non-homologous end joining. And that means that they repair your DNA. But sometimes they misrepair it. And that means that you might have a malformed protein. So if your DNA is being read backwards or in a garbage-like state, you're probably going to get garbage out, which means malformed proteins, which can then result in cancer that metastasizes in an astronaut's body. But what we do is not just worry about protecting astronauts or billionaires in space. We translate these countermeasures into precision medicine for everybody on the ground, because that's what matters, ultimately, is the entire human race. So we run a company called Vector Space Biosciences. We have a crypto, SBIO, that will eventually become fully regulated. And this is going to mean that individuals will have voting rights, not necessarily based on a DAO, but based on the fact that they own actual equity in the company. SBIO is a representative of it's our token that represents our parent company, Vector Space Biosciences. We have a subsidiary that focuses on data sets as well, all kinds of data sets. And this token, VXV, provides data set security and provenance, because data sets are the new attack surface as they power all of AI. So when you look at our background, we got our start in the early 2000s at Lawrence Berkeley National Lab in space biosciences, focusing on chromosomal translocations. That's the same thing that happens when radiation hits your chromosome and causes all kinds of damage, and you get misrepair. What we decided to do was use some early language modeling approaches to extract hidden relationships between genes, proteins, drugs, pathways, biochemicals, other kinds of phytochemicals, micronutrients, and other environmental factors. The hidden relationships are where discoveries are made, by the way. Knowledge graphs, they have their use, of course, but as a scientist, you want to be able to discover something, and you want to be able to accelerate the process of discovery as well. What we do is we work with our scientific advisory board, and our chief scientific advisor is Mina Bissell. She's up for the Nobel Prize in Medicine and ran the life sciences division at Lawrence Berkeley Lab for over 20 years. So we collaborate closely together along with her cohort. In addition to Cal Poly, City of Hope, ICL, UCL, and a bunch of other institutions, including IFO Rome and UC San Diego. So what we do is we try to learn from launching CubeSats. CubeSats are 10 by 10 by 10 centimeter, almost shoebox size containers or devices that you stick a payload in. You can stick a scientific experiment in. You can measure radioactivity with the TimePix-2, developed by CERN and distributed by Advocam. So what we like to do is push things, push the limits a little bit. And that would mean, for example, not necessarily following the path of some of these large pharmaceutical companies. For example, Merck. Many of you have heard of Merck, one of the largest pharma companies in the world. It has a $20 billion blockbuster drug called Wegovy. And it was found that, Keytruda. Wegovy is Novo Nordisk. But Keytruda is Merck's drug that they launched 10 times to the ISS to determine how proteins crystallize in space. Microgravity. Actually, it doesn't have all drawbacks, but microgravity enables a pharmaceutical company or drug developer to better understand how a protein crystallizes in a more uniform way because of microgravity and bring that template back and then make their drugs a little more effective. So that's happening today. It's happening with Eli Lilly. Eli Lilly is on their second launch right now. And Varda Space Industries, that's another one. You might want to look that up someday. They have a whole lab in space where you can conduct biological research, but mainly in particular related to protein crystallization. So our product line includes launching these CubeSats and enabling biotechs, pharmas, scientific institutions to design an experiment. They can design it on their own, or we can help them design it based on our scientific advisory board and the wealth of knowledge domain expertise that they have in this area. We also plan on launching multiple launches, at least one per week eventually. That's absolutely tractable. And we've got, as I mentioned, we're looking at the largest possible TAM that has ever existed, total addressable market. And that's because, it's not just about sending humans, but it's about sending robots, it's about sending chipsets so that you can understand how you can harden them, radiation harden them or space harden them. And there's eventually going to be a lot of chips in space, including NVIDIA's chips. So we work together with companies like NVIDIA to move toward understanding what it takes to space harden some of their chips. So space biosciences is ready to exponentially increase. One of the reasons for that is that many cancers can triple in size in just 10 days, whereas it takes 10 years on the ground to triple in size. And that really means that you can accelerate your process of discovery because things are happening at a much faster rate. So you can conduct more experiments. But you can accelerate it even more with DeSci. And that means that you're then approaching an area that we like to focus on within DeSci, not necessarily the DAO approach, but we understand that one of the biggest problems in science is that everything moves too slow. Discoveries are made way too slow. And this means that we need to figure out ways of accelerating that. And the best way to accelerate scientific discovery is to be able to share your research, engage in open science, so that you're giving everybody else a head start on things. And that's almost a double-edged sword, though. We can mention that, but we do also have to mention the fact that there is theft in science. There's theft in industry of intellectual property, and if you want to be able to publish your research and maybe share it without it being traced back to you, that could be a problem. But again, DeSci solves for that. When you initially store your research online, on-chain, and maybe based on a hash. So DeSci solves for that, and we are looking to engage and help with that along the way, along the DeSci path. But another reason that DeSci and open science, we take this open science approach and understand how DeSci can help with it. But another reason for open science in the DeSci format, or following the principles of DeSci, is that AI, language modeling being the tip of the spear in AI, by the way. You've heard of Gen AI, generative AI. You've heard of ChatGPT. You've heard of AlphaFold 2, that won the biggest breakthrough in 2020 for predicting the way protein would fold. And you've heard of Gemini, maybe, a recent deal done between Apple and Google so that Google shares this language model, Gemini. Every one of those product lines, every one of those technologies or innovations is based on language modeling. And when we talk about language modeling, we just don't mean looking at human language. That's not what language modeling is. A protein sequence is language. You can do some research and understand how language modeling is being applied to sequences of protein, cutting up into k-mers and understanding similarity. Well, all of that stuff is stored in what are called vectors. A byproduct of any language model is the vector with feature attributes. At the core of any AI system is a comparison between the input vector and the output vector. They're all vectors. That's why our name is Vector Space Biosciences. When you look at a vector, the way you construct a vector and the way you compare it for similarity is what really matters. You have to do it in a very high quality way. So data sets result from these vectors. That we take these vectors, we extract them from language models, small and large ensembles, mixture of experts as opposed to an ensemble approach. And we then build correlation matrix data sets, graph networks, relationship networks that show hidden connections between genes, drugs, diseases, and so forth. So in conclusion, I do want to mention that these data sets, being the new attack surface, data sets power all of AI. We leverage the VXV token to enable data set security and provenance. That means provenance, as you know, is anybody that's ever touched that data set, any machine or piece of software that's ever modified that data set or data sources associated to it, and the whole shebang, and storing that on-chain as a record, an immutable record. So in conclusion, let's go back to precision medicine for everybody on the ground. The big question we always get is, well, why are you guys doing this to protect astronauts and billionaires in space? That's not at all what we do. What we do is we translate these countermeasures. Space is hard, but space biology, space biosciences, space medicine, that's even harder. So when you look at what needs to be done, it can be summed up in the fact that this decentralized research connects to new forms of precision medicine in the context of fighting cancer, human aging, and health span. When we were at the lab, we worked on, as I mentioned, chromosomal translocations, but also human aging and cancer, in particular breast cancer, because that was Mina Bissel's main drive, although she did create one of the first reports for protecting astronauts in space back in 1997. I think it was like 300 pages or something, but it involved multiple labs. But we worked on human aging in the context of nematodes as well. These are small worms. We understood that when you knocked out a couple of genes, these worms would live to what's equivalent to 300 years in human lifespan. So we do have some background in that area, and that connects directly to the space industry. There's a lot of distance that people need to travel in space, and you might want to live a little longer so you can enjoy it, maybe, or actually make it to another habitable planet. But that's 70,000 years, so we won't go there just yet. There's a paper titled The Biomedical Challenge Associated with the Artemis Space Program, and in it, Professor Mariano Bizzarri stated, what we know, or what we do not know about human physiological limitations hinders our ability to plan a human exploration campaign beyond LEO, low Earth orbit. The team said in their paper, the most limiting factor that makes human space exploration a risky endeavor is strictly dependent on safety issues. Therefore, the principal barriers to human exploration, far from LEO, are those given by the limits of medicine. So in other words, there will be no space race. There will be no lunar bases, no going to Mars if we don't understand how to protect and repair the human body in space with these countermeasures doubling as forms or new forms of precision medicine for everyone on the ground. And as mentioned, that includes Novo Nordisk, Wegovy, that example I mentioned earlier. And it also includes the fact that, we are in it for the revenue. And this is going to mean that we're charging about $250,000 to $5 million per customer. Our customers are biotechs, pharmas, and new materials companies, in addition to companies that want to space harden. One of our first launches is going to be based on tardigrades, or water bears. They're about 1 nanometer in length. Some of them are about 500 microns, or about 6 human hairs. So if you take 6 human hairs, line them up, that's the size of a tardigrade. They happen to repair their DNA 2,000 times faster than humans. They also have other attributes. They live about 30 years Their normal lifespan is about 3 to 4 months, but they live 30 years when they go into hibernation. So understanding DNA repair pathways with these tardigrades using some biomimicry is where we are headed in these launches. And all of it connects to human aging, mitochondrial stress, the brain ECM, the extracellular matrix, all the fibrils that interconnect your cells, and how they communicate with extracellular vesicles and so forth. So in the end here, we'd like to say that if you are an SBIO holder, we'll send your name and DNA, or both, into space if you'd like, deep space. We'll follow the path of Voyager 1 and Voyager 2. Or if you'd like to become a sponsor of one of our CubeSat launches at no cost, just let us know if you're an SBIO holder at support@vectorspacebio.science. References and citations are available upon request. Just see us afterwards. And thanks for listening.
Brilliant. We have time for questions if you would like to take questions.
Sure.
Do we have questions? This is the post-lunch sleepy crew. Yeah, there we go.
Hi, just a quick one. Just wondering what you're doing with NVIDIA more specifically.
Yes, so NVIDIA, we first got involved with NVIDIA based on their biological language modeling effort, BioNeMo. Since then, they've expanded it, and they've, instead of taking a horizontal approach, they've taken more of a vertical approach, understanding relationships between proteins and so forth. And that's valuable, but not quite as valuable as it needs to be right now. Our next track with NVIDIA is to space harden their chips. And there's going to be a lot of chipsets in space. So if you're a chip provider, whether you're ARM, TMSC, Taiwan Semiconductor, you're going to want to know that your chips function properly in space without having anomalies associated to the memory storage and so forth.
Excellent. Do we have other questions? Yes. Coming over your way. Hold on.
Hi, thanks for presentation. It was very interesting. Actually, I have two questions. The first one is, I wasn't aware that NVIDIA is involved in space, so do you have more information about this? What do they tend to do? Is it a new program? And my second question is your research open source, or how do you what is your model like to finance your research?
Sure. So NVIDIA, anything that they're doing anything they want to do in space is nascent right now. Most companies aren't prepared for this elephant in the room, which is space biosciences, to completely take over the space industry in terms of government contracts and whatever else. There's going to be a flurry of activity, so we are working with NVIDIA to help them better understand how they can space harden their chips. And this is early days. So in terms of open source, we work to open as much as we can, given the particular customer. So we handle it on a case-by-case basis. As you know, biotechs and pharmas are pretty, protective of their proprietary aspects. Some of the things that we do, we keep as a trade secret or a secret sauce, like the Coca-Cola recipe or something like that. We don't intend to exercise a patent portfolio. We intend to engage in open science because we understand the importance of accelerating discoveries, and that's the best way to do it.
Excellent. Thank you so much. We have time for one more question. Yes, you are my winner. Okay, coming all the way around. Here we go.
So it sounds like most of your experimentation is in LEO currently. I'm curious if you have any plans in the short term to expand outside of the Earth magnetosphere inside of deep space and do experiments there.
Absolutely. The reason for that is you get different kinds of galactic cosmic rays out there, the deeper you go. So first, LEO will follow the path of the ISS, which is going to be decommissioned in 2030. So there's going to be a flurry of activity of launch providers, but also CubeSat manufacturers and whatever else, and biological CubeSat launching and development and design. So first LEO, then cislunar between here and the moon, between LEO and the moon, and then deep space. And of course, the ultimate objective is interstellar, beyond the influence of the sun in our current
orbit. So.
Excellent. Thank you so much. I really, really enjoyed that. Yeah, please, please. All right, so we're sticking with our space theme. And our next speaker, Manu, I think that's you, my friend, Manu Ilariu, this from Copernic Space. This is Open Science Marketplaces for the Space Industry. Welcome, welcome. There should be one there.
Me? Hello? Yeah, working? Back forth, okay, nice. Hello, everyone here. My name is Manuel Olario. I'm the founder of Deep Venture DAO, where I built IP marketplaces for the space industry before. I led different grant programs and the whole operational infrastructure for onboarding D-scientists into MoonDAO. And now I'm working with a very good friend of mine, Grant Blaisdell, on Copernic Space, where he already built up the whole commercial side of the marketplace when it comes to satellite imagery and payloads, while I'm exclusively focusing on the research side of the marketplace, where we have papers, IP, experiments in space, and so on. So, what are we doing with Copernic Space? With Copernic Space, we are building marketplaces for the space industry. We had really successful use cases in the past with space companies who want to find additional paths towards profitability. And we are providing the economic infrastructure so that that space companies can find new customer groups, new proof of concepts, novel business models, how they can find also additional streams to cross-fund their research. So besides the stuff that I did before with Deep Venture and the IP marketplaces, I then found out that in space, we actually have for sure the problem of science financing, but the even bigger elephant in the room, right, is market making, market creation. So we have a super fragmented market in space. Everybody's doing like their own thing all across the globe, sending things up in space without thinking about the consequences. And then also the normal citizens and small and medium-sized businesses are typically excluded for all of these opportunities. And even like high-level executives from space companies don't even have the chance to send anything up with their respective companies. So I want to tell you a little bit about some of the success cases that we had in the past. We acquired a database on a Firefly land on a SpaceX rocket that will be sent to the lunar surface by end of this year. So we sold out in the first month. We made a shitload of money out of it and enabled individuals, right, to send PFPs up in space. So if you have, for example, your family photo, your company incorporation, anything that you want to have up there, we enable people to actually do it. And then we have a thing that we call spacification. So we are converting traditional asset classes into real-world space assets. And we do this, for example, by sending a digital copy up in space, giving away at the stations that this is now a verified space asset. And then what comes after this is the trading, buying and selling of this digital copy and the representation of the space asset itself. So yeah, buy, sell, tokenize your access to space. This is how it looks like on our platform in a nutshell. And we partnered up with meaningful partners such as Axiom Space, who are building out space stations with the first meme on the moon. We had a collaboration with Sophiaverse out of this whole SingularityNet decentralized AI ecosystem when it comes to the first AI asset on the lunar surface. And a bunch of other use cases, and I want to highlight some of the DeSci use cases here. DeSci Journal with one of my good friends, Maria, and also DeSci Youth when it comes to community engagement for decentralized science all around the globe. So some of our partners, you can see up here, and more importantly, the use cases. So you can imagine we have different product verticals where we are tackling different parts of the space industry. It's all starting with the culture of space, what's connecting us in the hearts and the minds in the end. So this is what we call Spaceables, where it comes to enabling artists to send the artworks up in space, go to an auction house, sell it for the 10x, 100x, or whatever. Well, this is creating speculation markets so that space companies can better navigate the pricing strategy in front of the rest of the world. We also have, again, physical payloads, digital payloads, satellite imagery. Right now on our second marketplace, on our second vertical, we call Space Mart. And then the part that I'm most interested in, it's for sure accelerated tech transfers. So we are also building out different prototypes right now with some of our partners when it comes to tokenized academic papers, tokenized IP, science financing, etc. So yeah, here you can see the product itself, how it looks like on the platform. So you have the satellite imagery report for your specific region. People can request that they want to buy it, and then they get access. Following out of this is for sure also like the tokenization and fractionalization of these reports. We're working on this right now to enable much larger audiences in accessing these data points. We have a papers and patents platform, a prototype where we are right now onboarding different early adopters to have like an iteration, an iterative loop in there. And our roadmap for this year looks exactly like that. So we are in Q2 right now. We already did a lot of successful, again, spaceification processes where we are converting traditional asset classes into reward space assets with spaceables. We had the payload with the moon sail, and right now we are working on, again, tokenizing IP, academic papers. We're also supporting a lot of crypto crowdfunding activities together with Gitcoin and the Greenpill community to further grow the decentralized science ecosystem and the decentralized space exploration ecosystem. And later this year, we are also working on the whole financing part with DeFi investments, but I will let you know when we are ready for this. So what is Copernicus Space Research? A marketplace where, again, people can showcase their space research, their R&D, their IP, and then find additional sources for financing their efforts. Why now? I mean, obviously, last year we had the Year of Open Science. The biggest research institutions of our time announced this, such as NASA and CERN, and they were desperately looking for all the solutions that all these great DeSci founders are building out right now for open science and for the space industry to unfold. So for this, we created a framework that we call OSHIP, Open Science and Hardware IP, where it's not about further commercializing IP, because this is like a bottleneck that we already solved from my point of view, but when it comes to the scalable tech transfer. So I won't explain like everything here in detail, how our smart contracts works and etc. The thing is, sharing is caring. The more you share, the more you get access to early stage research that is emerging out of this. So here you can see two of these quadratic funding rounds that I delegated together with Gitcoin and a lot of our community members. Last year we had the DeSci round where we had in total 75K that we distributed to 65 projects in total. December last year, I also kickstarted a QF round with Gitcoin and the top 5 space-focused DAOs to focus again on space, and it was like a market testing, so we were not, our objective was not to equip like everyone with like 10K, 100K, whatever, but to see how many people actually have the need and the interest to support and apply for these super early stage space projects and support them with crypto. So now I want to talk a little bit about Spacepool before I open it up for Liam, who is hopefully here in the audience somewhere. Spacepool DeFi investments, so grants, direct crypto investments, donation, etc. This is linked to securities law a little bit. If we further open up the speculation markets and enable crypto holders to speculate on our assets, so we will most likely need a securities license for this, so we are working on this right now. Here you can see my good friend Grant, who co-founded the company a couple of years ago with his mom, Eva, aka Lady Rocket. Here you can see the rest of the team with like space industry veterans, our CTO. I'm the Chief Innovation Officer. Maybe I just skipped my introduction, but I hope that's fine. And then some other VCs. So we are raising right now. Happy to have a chat. Happy to support the whole ecosystem. Every project that is using blockchain tech for the space industry, building out DApps for space companies, or just also want to support others. So let me know if you have an interest in further expanding our reach with blockchain space tech, because this is, nothing's new here. We had a great wave of projects popping up 6-7 years ago who utilized blockchain infrastructure for space, but unfortunately 90% of these projects died. So let's learn out of it, let's change our attitudes, let's change how we communicate and collaborate with each other, and then open up the final frontier so that anyone anywhere can participate. Thank you very much. Please let me know how much time we have left. So I would love to invite, again, Liam to show our prototype, some other people that I saw here in the audience to announce what they got, and then we can close it up, and I'm handing it over to the next one. What do you think?
Awesome. You got 9 minutes.
9 minutes left. Perfect. Liam, are you here? Here we go.
Yeah.
Join me on stage. Applause for Liam, please. Hello. Hello, hello.
Just plug it in?
Yeah, just plug it in. Should be fine. Liam, here's your mic. Please introduce yourself and the magnificent work that you did.
Hey, my name's Liam. I'm from Melbourne, the best city in the world, and I don't want to hear any discerning opinions. So I work with Copernic. I've been doing some collaborative work with DeSci Labs over the last year and a half. I also work with the Bank of Melbourne, or I did until last week when I got made redundant. I was working in fraud detection and scam prevention. My passion is on open science and especially on space exploration. I grew up in Australia where there's pretty much no investment in space exploration or really in science outside of mining. And I was like, well, there's really no way I can do what I want to do. I want to learn about alien life and moon missions. I can't do that in Australia, and I can't do that if I don't have a degree, if I'm not part of the industry. And that's what I realized was citizen science is really important. There's so many people that have a passion and interest in science, but they're not welcome in the traditional industry because they're not considered smart enough. So I started building a platform called Star Sailors, which started out with exoplanet verification via citizen science, and then I've taken that into other areas in DeSci, in mining, in health, in animal tagging. And I met Manu, well actually I met him for the first time last night in person, but I've been working with Manu in a bunch of different capacities over the last couple of months. Right now I'm working on building IPFS-backed tools to integrate with the rest of the DeSci ecosystem, specifically around space exploration. So the first thing, you've got the front end that I worked on. So Star Sails has gone through a bunch of different iterations. Right now it is primarily targeted around nodes. So if you are a space scientist or if you are a health scientist, you have a research project, and every research project has a lot of data in it. And what can you do with data? You can explore, classify, get findings from your data. And hopefully, in a couple of years, almost every research project that is being put on chain will have people all over the world contributing their own data. In my home country of Australia, we had a project called Fireballs in the Sky, where people would take photos of meteorites just with their cell phone, and that would add to the network. So just to keep things simple, Star Sailors is a website and a mobile app where you can explore different planets, explore pretty much anything. So I'll just go to my planet. So it's all based around ownership. We do have an NFT infrastructure. So let's wait for that to load. Do I still have Wi-Fi? Hopefully I do. Doesn't look like it's working, unfortunately. Oh, here we go. Okay, so the first planet is showing up now. So this is Kepler 186f, and the main concept is this could be relocated for any scientific node, not just space. But we've got a research project that is looking at the validity of different exoplanets, and you can click on the different areas. So you have you would place different structures around your node once you own the NFT, which can allow you to look at, in the case of a planet, you can look at the light curve data, which I'll pull up now. Yeah. So, Sorry, it shouldn't be happening like that. Oh, here we go. So people can talk about what they think of their planet candidate. Which is apparently not, again, not going well. My apologies. Yeah, so you can talk about what you think of a planet candidate. Currently, I just have a bunch of test data. This is of our test node, but you can just say, okay, here's a node, here's a specific part of a research project. You can make a comment on it. You can view all the different data by clicking across the different icons. As you can look at light curve data, you can look at rover data. So we have a partnership with the International Centre for Radio Astronomy Research and also linking in with the Perseverance rover. So you can view live data from the Perseverance rover and say what's going on and feed that back into other projects. So that's what I'm doing. We're rolling this into the Copernic infrastructure, and I'm also just working on how do we monetize our projects and provide value to investors and backers while still ensuring that the values of open science are respected and that anybody can contribute.
All right. Thank you, Liam, for showing our pre-alpha prototype as well. Thank you. And now I want to, so I saw some friends, some space friends in here, so maybe, you can just raise your hands if you're, interested in space, please now, so that I know who I need to talk with. I saw some of our crypto space agency friends also over there, so if you want, just join us on stage for a quick picture, for a quick selfie here, so that we can show face in front of the DeSci ecosystem that we were here before you, okay? So yeah, feel free to join us on stage. If not, it's also okay. And before that, Kiba, are you here? Yes, join us on stage for a quick announcement before we close it up. And here we go. So, thank you.
Thank you. Give it up for Copernic. That was a great demo. So I'm here to give an announcement about the Zuzulu village in Georgia. We're going to be doing a space track there to bring and invite the space ecosystem into the Zuzulu community. So we have longevity, biotech, crypto, AI, and now we're also going to bring in the space industry so we can learn more about space infrastructure. What does medicine look like in space? We heard about space radiation and how that affects space travel. There's all types of infrastructure, research and data that we can be collecting. And so there'll be a 2-week conference in Georgia specifically on space within the 2-month event. So if you guys are interested in learning more, then please join us there.
Thank you. Open invitations, right? Thank you. Chance to join us on stage for a quick selfie before we close it up. Want to join us? Yeah? Space friends? Calling all space friends here, please? Sarah, here we go. I knew it, I knew it. So now, final question. Good to meet you guys. Hello, hi, good to meet you. Hey, you too, perfect. Big question, who wants to do the photo? Can you do the photo, please? Yeah, perfect. So, here we go.
Actually, y'all are in shadow. Let's put you into the light. Come into the light, y'all.
Yeah, good.
Thank you.
Yeah, good. Good. Join us.
Do not be afraid of each other. Please all squish together.
Yeah.
Huddle.
Good.
Okay.
All right.
Gorgeous.
Perfect.
Everybody, space travel.
Space travel.
I love it.
And one more.
Yeah, I love it.
Perfect. Thank you. Thank you, guys. Thank you.
Okay. Where's the mic?
No. You did great, man. Here, Mike.
I think let me use this one. This is my favorite mic.
I think I'm mic'd.
You're mic'd. We don't. No, just leave that one up there though. Dankeschön. This is like past the mics. Okay, love it. All right, so last space talk of the day, I think. I'll look at the other side of this piece of paper and tell you if there's more later. So, kindly welcome to the stage, Sam Hutchinson, founder of Sarah, How to Build a Space Agency for Everyone. Welcome.
Thank you. Thanks. Where is the... Thanks. Is this green forward, red back? Yep. That's great. Thank you so much for having me. It's been great to hear from the other decentralized space projects. As you may have picked up, space is uniquely difficult to decentralize in a number of different ways. One is the enormous capital cost associated with space exploration. The second is the long lead times for commercialization. And the third is the enormous amount of regulations and sensitivity around space, because one of its primary uses is, of course, for military applications. So I and my co-founders founded Sarah in 2022 when we were known as the CSA. And what we focused on is, in the first instance, human space exploration, because to build a large community that is excited about space, the number one thing that people who say they are interested in space want to do is go themselves. So we thought we'd tackle that first, and then gradually develop decentralized systems around scientific research and technical space activities. So I'm just going to give you a few slides on what we did with our first human spaceflight mission, and then talk about a larger human spaceflight mission and associated scientific experiment payloads that we're going to be doing this year. I'm here because I'm excited to learn. I'm not a blockchain person. My background is in hypersonic and space propulsion. It's incredible to see the innovation that all of you have been generating to try and tackle this incredibly important and exciting problem around how we can create open and collaborative science. I'd love to talk to all of you about the ideas that you would have for how you can participate in our upcoming space flight. So here's a funny fact. 86% of astronauts have come from just 3 countries. Those are the United States of America, Russia, and China. And that human spaceflight experience also translates into in-space assets. So 76% of in-space assets, that's satellites, space stations, and the like, are owned by those same 3 countries. And as I mentioned before, heavily restricted and regulated. So it's a huge challenge moving forward. 150 countries have never had an astronaut. That's a lot. It's much more than half the population of the planet lives in a country with no active human spaceflight program or active space program at all. And we started last year with a young man called Victor from Brazil. Sarah bought a ticket on Blue Origin's New Shepard rocket and made that ticket available to members of our community. We sold NFTs to be members of the community. And we did a random on-chain draw. So Victor was the first human sent to space using the blockchain, which we found very exciting. He became a national hero. Even we were taken aback by just how big an impact Victor's journey had on young people in particular in Brazil. They had 1 astronaut previously, but it was 17 years before. And he became a super celebrity. He was back-to-back coverage, online, television, radio. And after that flight, Blue Origin came to us and said, well, that was extremely interesting. What do you do? What do you want to do next? So we have a second mission upcoming. I can't talk about the specific date. Upcoming, where we've taken the whole capsule. So we had 1 seat last time, and we've got 6 seats. And 5 of those seats will be dedicated to nations that have never had an astronaut before. And the 6th seat will be open to anyone, anywhere. And using some of our experience on the last mission, we're going to be using Web3 tooling to allow anybody, anywhere, to propose themselves as an astronaut candidate, to vote on the final mission crew, and also, and this is where all of you come in, propose and select the science experiments that those astronauts are going to perform on the flight. So each seat will have 1 large autonomous experiment, human physiology sensor experiments, and then 6 smaller astronaut-tended experiments. And for those, we're opening that up to anybody to propose, and the community will vote on those that are selected for their regional seats. So each of the 5 seats, it'll be regional specific voting. And then for the 6 seat, it's up to anyone anywhere. So if you're a space startup and you want to send an experiment to space, stay tuned, sign up, and submit. And one of the things that we've learned over the last 18 months, myself coming from a sort of pure engineering background, is that particularly in space, in the space sector, a huge amount of the value of historical space activity is in the know-how around the way that you put a mission together. And that's not something that you can find on the internet. And we are developing a mission AI because we're reaching out to countries, communities, high school students, university students who have got little or no experience in putting together science experiments, understanding microgravity environments, that is trained on the parameters, the themes, and the background materials for each of the we're going to have 3 different themes for the in-space experiments. We've also trained it on the NASA Program Management Handbook, which is something that I spent many years having to sort of memorize and learn, and it's very, very useful when it comes to a systematic approach to putting space activity together generally and experiments specifically. And also function as a sort of basic knowledge disseminator for people who may not have any academic background in engineering, technology, science, and experimentation. And it's one of those things where 18 months ago, if you told me that I'd be building a friendly HAL 9000, I would have not believed you, but there we go. What could possibly go wrong, right? So in terms of this year, our mission objectives are, to build a large global community of space enthusiasts, engineers, and scientists. I think part of what is essential if you're building a decentralized space community is scale. I mentioned at the beginning that the challenges in space are that it's really expensive. And so in order to sort of engage in meaningful activity, you've got to do so at a very large scale. Luckily, 50% of people who are polled want to go to space. And so the human spaceflight program at SARA is part of that draw for a larger audience who may be interested in space, certainly want to go to space, but don't have technical skills relevant to putting experiments together. And growing both of those communities in tandem is what we see as essential to success. A large community of people who are interested in space, want to maybe have a say and invest in or donate to space research, but who aren't going to get too involved in the day-to-day running of projects or DAO mechanics. And on the other hand, build a community of people with the skill set to put meaningful space experimental research projects together for the community to support. And the third objective is to use the data around the community's use of the AI and the platform to build a more meaningful and sophisticated platform to allow people to put their own projects together to fund, and all the things that Manu and other people in the DSpace community have been focused on for a long time. So beyond that, I'm very interested personally because I worked on a lot of projects where a lack of program management led to program failure in developing a decentralized program management suite. It's also critical that you manage the intellectual property side of space research. As others have mentioned, it's a highly regulated space and it has unique challenges when it comes to collaborating globally on sensitive or applications and technologies that may have military applications. So there are some sophisticated and complicated challenges there to address. We're also going to be continuing to develop the LLM to be more than just an assistant and become more of a sort of an AI program manager for anyone who wants to utilize its expertise. And then obviously it goes without saying, IP digitization is critical. People need to understand that their work is protected even if it's transparent and have a way of monetizing that moving forward. So that's all I've come to say. What we love is if all of you who've had much more experience than we have in the challenges of running decentralized organizations, in executing on decentralized science, please, if you've got solutions, if you've got expertise, come and talk to us. We're going to be building up this platform over the next year, and we'd love to hear from you on how we can do it. Also, of course, if you're a space scientist, stay tuned, and you can submit your research experiment proposals for the upcoming flight. I can't say when it is, but it isn't too far off. And that's all the news that is fit to print. Thank you so much.
That's fantastic. Do we have questions? Yes, my okay. 1, 2, 3.
I can't see anything, so.
No, that's okay. I got you. I got you.
It's been said that the most important space project might be to put up solar panels into space where they could collect vast amounts of energy and then beam it down cleanly to the Earth. Is that something that any of your teams or personnel have been looking at, to how to speed up this benefit?
Do you know, it's so funny you say that. So I was part of a team that built a company here in the UK called Reaction Engines, which is the world's, I would argue, most innovative space and hypersonic propulsion company. That was the first use case that I looked at when we were looking for, when we were a scrappy startup. It's now a very well-established UK engineering company. And there were some very big bills to foot for the development of the propulsion system. And the UK at that time was not investing in propulsion. Actually, Reaction Engines was the first recipient of government funding to space propulsion for over 50 years. Obviously, investors were saying, well, why do we need a cheaper, more usable space access system? And 100%, solar energy is, I think, again, I'm not a scientist in that area, at least 10 times more powerful even in low Earth orbit. And it's an incredibly obvious use case for the kind of launch systems. For example, SpaceX's new rocket got some serious payload on it. And it's something that you could haul up solar panels on, I think, no problem. So I think those things are going to start to come online. I think, one of the other areas that I think is really interesting, well, I think there are lots of areas. Two areas in space computing is really obvious. For one, there's free power. And there's also very low temperatures at zero cost. So I wouldn't be surprised if, for example, a very rich owner of Blue Origin, who also owns the largest cloud computing on the planet, wasn't thinking about those things. And I think that you're going to start to see those come online. At the moment, cost is prohibitive. For all the work that SpaceX has done, it's still, $85 million to take a satellite up. As that continues to come down, you're going to start to see larger scale projects, like I would hope solar power in space computing and the like. Sorry, it was a long answer.
Excellent. So we have time for these 2 questions.
Sure.
So you're my first question.
Hey, I'm just wondering, how do I get involved in the raffle in case I want to go to space?
It's not a raffle. So the first time we did it, it was a random selection. This time, it's going to be voting. So one of the things that we found, and maybe all of you have found the same thing, is that getting a very large, non-technical, non-blockchain focused audience to interact with very complex DAO mechanics is challenging. It's a UX UI challenge. It's an educational challenge. So the easiest way to do it was just to do a random selection. We're building a voting ecosystem as part of the project, and people who sign up as an astronaut candidate will have to run their own campaigns on their own social media or by word of mouth and get their friends to vote for them. So it's going to be, it's not just democratizing access to space, it's an actual democratic process to decide who gets. But to answer your question, you can go on sarah.space, pre-register, and we'll let you know when the full registration is open.
Excellent. Our last question is all the way over here. So we'll last question for the break.
I'm curious
Where
how
are
the...
you? We're here. Hi. That's okay.
How the vision for Sarah evolves, as you alluded to earlier, as the cost per kilogram to space goes down, space becomes more available to the general population. So I'm curious how your vision changes to suit that need.
Well, I think you can become more ambitious. It's very, as I'm sure there are people who are involved in decentralized space projects now. It's a big problem. putting things up is really expensive. So where does the money come from? As the cost of launch comes down, it's going to be easier and easier for less centralized organizations to be active in space. And I think that's why it's really important that you see the foundations being laid and the lessons being learned in how to and how not to run decentralized space organizations, because at the moment it's, we're reliant on private investment and sponsorship, and moving forward, it's going to be easier and easier for people all over the world to self-organize around space projects as the cost comes down. So to answer your question directly, just simply more ambitious. Right, right now, this is ambitious enough for the moment. This is, 5 people who will be their country's first astronaut. Human space flight, captures people's imagination. That allows you to, that will allow us to build a sort of large community that's excited about space, maybe hasn't understood or knew much about space previously. And as the cost comes down, you can just get more and more ambitious. Has that answered your question? I don't know. Are there specific things that you think that could be done? I think that...
I was just curious because it seems like it was mainly focused on the lack of availability currently. So I was wondering, as that becomes less of a need, if you're moving to different needs. But yeah, it makes sense that you go for more outlandish, or not outlandish, but more ambitious opportunities as things change.
For sure, and I think as well, as the markets sort of get more comfortable with investing in space ventures, that's going to change the dial a lot as well. So, obviously, 2 speakers ago, he mentioned there are incredible opportunities around asteroid mining. I mean, it is true. There are hunks of platinum, gold, iridium, and rare earth metals just rolling around the near solar system, and you can go and get them. And the law is that if you get them, they're yours. What you do with them once you've got them, I think, is a different question. But I think you're going to see, the initial private investment, has been in the launch vehicles. That's why you see Elon Musk with SpaceX, Jeff Bezos with Amazon, because that's the pain point right now. The pain point right now is the complexity, the risk, and the cost of operating in space. And as that comes down, you're going to see, a completely different ecosystem of investors interested in building out in space infrastructure and businesses. So hopefully we can all be a part of that. Thank you so much.
No, thank you. I have to be the bad guy. So I have to kick everyone out. No, I want everyone to have a break and take a breather. Thank you so much.
Not at all, please.
So, a brief PSA before we go to our break. Dear friends, there is an after party. Yes, there's an after party at Bar 190, sponsored by Cerebrum DAO. Thank you, Cerebrum. All right, get out of here. Come back in half an hour. Be back at the top of the hour. Love you all. Yay. All right. Oh, I forgot to yell at people about their...
I think people will start to trickle in here a little bit. I'll get started because I know that we're on a very tight timetable. I'm very excited to be here. My name is JJ Seiler. I am Chief of Staff at Input Output Global, which is the entity behind the core protocol development of Cardano, which is a top 10 blockchain project. It's very large. It's about $20 billion in value right now on a given day, and at its all-time high was worth about $65 billion. So it's a pretty big project. It's got smart contracts, it's got native assets, it's got NFTs. It's really wonderful project. So I am here today to talk a little bit about decentralizing scientific research through protocol-funded grants. So a quick intro on me. I'll talk a little bit about the Cardano Treasury, which we think is one of our USPs for Cardano. Then I'll talk about how we access that treasury and the results from how we access that, which is called Project Catalyst. And then a little bit about the future of how we think this is going to work. So who is this person, why is he speaking, and what is input output? I realize that nobody knows who I am, that's totally fine. I will go through that real quickly. So IoT is mostly working on cryptography in the past. So we have put out about 200 peer-reviewed research papers in all sorts of things. So proof of stake with Ouroboros, which is a very energy-efficient consensus mechanism, and it currently powers Cardano. It was online a very long time ago. There's lots of stake pool operators now that fund the protocol and that make the protocol function. So this is under the leadership of Aggelos Kiais, who's at University of Edinburgh. We've worked with folks at Carnegie Mellon, at Hoskinson Center for Formal Mathematics, which is named after my boss, Charles, and that's at Carnegie Mellon. And Stanford University under David C. We've worked with Tokyo Institute of Technology, University of Athens, University of Wyoming. We recently worked with the Ethereum Foundation on a event called QSIG, which was about one-shot signatures for quantum signatures. So it's a really interesting event. Our researchers are also working on the future of blockchain protocols. So that's proof of useful work. So everybody says Bitcoin is useless. All the processing power goes for nothing except for generating random numbers. This is a solution for that. If you're interested in that paper, it's called Ophilimos. It was presented at Crypto in Santa Barbara in 2022. It's a very, very interesting paper if you're interested in the technology. There's also a multi-resource consensus, which we're working on. It's called Minotaur. So if you don't want to pick between proof of work, proof of stake, proof of elapsed time, proof of storage, you can put together a virtualized layer and use all those different consensus mechanisms to secure your blockchain, which is very cool. And I think in the future what you'll see is that people will build their blockchain initially on Cardano, and then they'll turn the switch over, and then they'll have their own consensus mechanism and they'll be their own blockchain. So that is a really cool thing coming down the pipe. We are a venture studio now, so input output is not just cryptography. A lot of our products have become fully fledged business units with their own leadership. Everybody's got their own incentive set. And they are in everything from microfinance to gaming to self-sovereign identity, which we're very passionate about, zero-knowledge cryptography with Midnight, which is a great project. We've got Mario Magaldi here representing Midnight today. Thank you guys for showing up. And Sabina Begum, with our creative director with Input Output, so thank you guys for showing up. In their infancy, all these projects are using IOG shared services, and then they get spun out from the venture studio and they become their own projects. So when I'm talking about these protocol-funded grants, what would be really excellent is that if people are receiving those grants from Project Catalyst, which I'm about to talk to in the future, maybe someday one of those persons that's received a grant becomes an entrepreneur in residence at Input Output, and it becomes this virtuous cycle. So the protocol delivers a grant to you. Maybe you build a great company, a great product, something. Maybe you come back in-house at Input Output someday and build a company with us. That would be really excellent. So another thing that we work on, and it came up earlier today, is Colossal Laboratories and biosciences. We have a synthetic biology portfolio. We've invested in Colossal as of the Series A round. And we actually partnered with Ben Lamb and George Church to make another venture, which you'll hear about later this year, which is really exciting. It's still in kind of stealth mode at the present. So this is me. I'm the chief of staff there. I work as a chief of staff for Charles. I'm very interested in a topic that's kind of esoteric. I think representing consciousness is super interesting. So that's kind of my academic focus. I think a way of it's very hard to represent consciousness. I also worked on antenna design for neutrino detection at the University of Kansas. It was a very long time ago. I also worked at Cambridge for a little bit at King's College and did some independent research there in 2009. So a long time ago. And that's me on a boat. We were on a boat for 2 weeks. We were looking for interstellar meteor fragments off the coast of Papua New Guinea. So that was through Harvard. So. Okay, so the part that everybody's very interested in, the Cardano Treasury. I'm going to talk about this a little bit. How does the blockchain's design actually promote DeSci? Cardano is a blockchain with a treasury. Very important number here. It's worth about $942 million, or 730 million pounds. So in ADA terms, it's over $1 billion ADA. And a portion of every single blockchain transaction on Cardano gets swept into, the blockchain fees get swept into a treasury account. This is a really interesting thing. I would encourage any of you, if you're listening to, hey, how does a blockchain project function? Ask a founder, hey, is there a treasury? It's uncommon. So the stake pool operators are given fees for processing transactions. It's a proof of stake blockchain. But some of that is set aside for protocol development and for decentralized grants. So as you can see here, a lot of the supply was minted at the beginning. That's the Genesis mint there. Oh, there's a little error there. But yeah, right now there's 31 billion ADA out there, and 1.47 billion ADA is kept in the treasury right now. And it's quite valuable. So how do we access that treasury? And what does that mean? Well, right now we have a decentralized grant agency called Project Catalyst, and I would encourage anybody here to look at projectcatalyst.io. And there will be much more detailed information that I can deliver here than I can deliver here in 15 minutes. But broadly, this is how it worked. Categories are set for a fund. People submit proposals for those categories. And then voting happens in a decentralized way from ADA holders. So if you have ADA in your wallet, you register that wallet, and then you get voting power based on how much ADA you have. So at this point, there's about 31 billion ADA in circulation. There's a lot of smaller holders. There's still some large holders. But what's interesting is that the votes are tallied in a decentralized way, and those results are put on chain. It's very transparent. It's very inclusively accountable. So what has happened with this so far? What are the results of Catalyst to date? 2.5 million votes have been cast. So we talk about DAOs. We talk about, hey, help us bootstrap a community, and we'll also give you some funds to drive your research forward. What's cool is that this has already happened. It's happening in real time with Cardano. It's been happening for 11 funds successfully in a row. 300,000 votes were cast in the last fund, which closed this year, and almost $29 million were dispersed in that one fund. So to date, about 1,600 projects have been funded. 800 projects have been completed, so many of those are ongoing, and those projects come back for additional tranches of funding over time. So you're not restricted. It's not a one-and-done thing. So this is everything from individuals to teams, businesses, nonprofits. All sorts of different entities have applied for Catalyst funding and have received it. And I think it's very exciting. All you need is community consent. You actually don't have to give up equity in your company. You don't have to give up IP rights. You're simply given an unrestricted grant. You're supposed to, present milestones along the way as part of your proposal. But we trust, I think, as a community, a decentralized protocol disperses those funds, and then you make good on that proposal. If you don't make good on the proposal, then what happens is you likely won't get funded again. And that's it. I mean, the community keeps track of these things. So you have to make good on it. But what's nice is that they're not going to micromanage it. They are going to get money in the hands of people that are building right away, which I think is really exciting. So a little bit deeper dive on Fund 11. $29 million, as I said, 46 million ADA dispersed. This is a really cool thing. If you're thinking about where to build, you have to think about liquidity as well. If you get issued a bunch of tokens, what do you do with those tokens then? If you need to pay your staff, you need to be able to sell that and get fiat and be able to pay people. You got to pay product managers and communications people, all sorts of people. So what's interesting is that, as soon as you receive that ADA, there are many, many different exchanges that you can sell that. And if you want to hold the ADA and watch it appreciate, you can do that too. So 300 different proposals funded. I just want to note here, 920 proposals submitted in the last round. So that's pretty exciting. That's about a 30% success rate. And the strength of the community is really in its peer review process. We do blockchain development with formal methods. We're very careful. We don't move fast and break things. That's kind of the Web 2 perspective. You really can't move fast and break things with Web 3. When there's billions of dollars at stake or lives could be lost, we like to say, if you're designing an airplane or the bullet train, you have to be very careful. So we are very careful about that. And the community of people that have come out of that ethos are very dedicated, very careful. They'll look at your research, they'll dive into it. If they're a subject matter expert in the area that you're applying for, you can expect to have a conversation with that person. It's not one person controlling or gatekeeping how these proposals are going through. All you have to do is talk to the community, engage them, and they're ready, waiting for you. So, a lot of these use cases at present, you'll note here, a lot of them have to do with Cardano, but my call to action here is to get involved. Like I said, input-output is expanding past cryptography. I think Project Catalyst and Cardano in general will expand past mere Cardano development in the near future. I think that if there's a group of people that can get involved and say synthetic bio is very important to us, let's put together a catalyst category for that, we'll see that happen. If we see a group of people out of a community say, hey, this rare disease is very important to me, and I know that there's people out there that think like me, and I want to see research funds go to that, I think you'll see the community swell to support that. And I think that we can become more diverse in the kinds of proposals that we see get approved in Catalyst over time. So, a couple different, a few more category areas here. So Catalyst systems improvements, developers. I think what's important to note is that these are not just things that have to do with core protocol development. These are products, these are meetups, these are media spaces, these are things as small as a Twitter space, anything that adds value to the overall ecosystem, the community's gotten behind and says, yes, let's give them a shot. So, into the future, looking ahead to Fund 12, which is about to begin, and also looking ahead to the future of what on-chain governance looks like for Cardano. Fund 12 is going to kick off around the world. There's a lot of different spaces, so I know people are gathered here from all over the world. I just want to mention that there's lots of different working groups that are going to spring up, and we're trying to be as inclusive as possible in this process. So 50 million ADA will also be available for Fund 12. I think that at this point it's a functioning decentralized economy. There's lots of different working groups where you can socialize your ideas and your proposals and make it happen. And I would encourage everybody here, if you're not quite ready to submit a proposal, consider becoming a community reviewer. And I think it's going to be really excellent to see how this evolves in the future. So yeah, I would like to leave you with a thought. I would like for Cardano to be a chain for builders, for creators. I know a lot of people say that, but we do have the academic pedigree, so to speak. We work with academics all the time. People that are aware about our project are careful, considerate. The values, I think, really align with DeSci, and I think that what this really shows is DeSci is already happening here. It's already happening through Project Catalyst, and I think you can evolve. And you don't have to spend time trying to bootstrap a community. You can spend time building. You can spend time perfecting a great proposal, working with subject matter experts that understand how to make this happen, and working with people that have already successfully received lots of ADA and grants through Project Catalyst. What's interesting too, I want to mention, is that Cardano is developing an on-chain governance. So this project is going to become a bit more involved. I think we're going to see more things put on chain, more transparent, and I would encourage everybody to keep track of that as it progresses. We should hear a lot of great updates about Cardano governance through the rest of the year. Thank you for listening here, and this is my contact information. If anybody would like to follow up, I am more than happy to chat with you personally. And I would encourage everybody to check out projectcatalyst.io, and and our website is iohk.io, and yeah, please feel free to reach out to me personally anytime. More than happy to help. Cheers.
Thank you. Great way to bring us back from the break. Thank you, JJ. And a nice shout out to SynBio, EngBio in this country. So nice to hear. Yes, yeah. Okay, a little PSA about the door, folks. It slams, if you haven't noticed, when exiting or entering this room. Please, please close the door gently so we don't all have to, perfect. That was a perfect example of using that door. Okay, Leo, you're up. Leo Boltz from Molecule. Bridging DeSci and DeFi. Introducing the bioeconomy. I love it. Welcome to the stage.
flickering.
Speaker view is paused. Make sure your presentation and put this window off. Yeah.
I'll try the second part.
Yeah.
Just see if that changes anything. Feel better? Yeah?
Looks about right. All right, perfect, let's get started. What's up, guys? My name's Leo. I'm pretty excited to be here. Some of you guys I know, some of you I'm not. To give a little bit of background, I am with the team of BioXYZ. And yeah, I'm pretty excited to be here today, representing BioXYZ, what we're doing, what we've been cooking on over the past 6 months, because yeah, I can proudly say I'm pretty excited that today I can announce something fairly new, something brand new to be precise. And I'm actually announcing this publicly or in this kind of small echo chamber for the first time, what we've been working on. And essentially, I think it takes a good shot at solving some of the roadblocks that we are experiencing within DeSci. And yeah, stay tuned. You'll hear more about it throughout the presentation. So I want to start off by kind of settling on a common ground. And I think the common denominator of why a lot of us are in this room and coming to this conference is because we see some of the caveats that the incumbent scientific system brings and has. And so we see misaligned incentives, we see a lack of democratic access and permission for anyone to get in and to participate, and we see bureaucracy overheading the scientific process. And so I think a lot of us can agree that DeSci, why we are here, has the real chance at bringing about a new scientific paradigm that the modern world truly needs. Build on democratic access, collective intelligence in these communities, getting to ideas and products and, progress faster. And so the team at BioXYZ, and to give you a little bit background, has basically been part of initiating VitaDAO, one of the prime examples of a BioDAO in the DeSci space. And back in 2022, the team has basically summoned all of the learnings and the experiences from having co-initiated VitaDAO and built a blueprint for BioDAO building, brought to curious biotech builders and founders in the space through an acceleration program in a launchpad that essentially dreams of making BioDAO building scalable. And so for those of you who don't know BioXYZ yet, the program essentially provides a seed funding for DeSci projects of 100K grant. And then most importantly, it brings about battle-tested frameworks and tooling designed for the BioDAO space to get your project up and running within no time. We have people who have built these DeSci DAOs, as I mentioned, seasoned biotech builders and serial entrepreneurs who make up a network of mentors that can really bring your BioDAO from 0 to 1. And what this looks like in praxis, in practical terms, is you are guided through a 4-month program that basically drives through 3 foundational milestones. Milestone 1 is getting you set up, finding the right legal entity model that works for your BioDAO, and kind of getting you set up in the Web3 space with your platform for your community, your BioDAO treasury, etc. It then moves on to help you build a community building strategy and to formulate your research funding thesis to then really drive these applications through the research kind of application process and culminate in funding science on chain. The whole program ends by helping you launch your DAO and your token to the public, and then ends with a big boom with a demo day that gets investors excited and shows the world the progress you've made. Some of the services we provide is getting you set up with branding and design, so really putting an identity and a face to your DAO that folks that scientists or people from the Web3 space can identify with and really want to jump on to join your mission. As I mentioned, legal engineering, providing you with the right governance systems and operation system, and more. Thus far, we've been we're super proud to having supported 5 insanely cool teams of BioDAO and DeSci builders. Again, building on the blueprint of VitaDAO. And so, yeah, we're super proud of the journeys the teams have taken thus far, a lot, like over the last 1 to 1.5 years. And yeah, kudos to those of you in the room who've been building with us and in the space. We're proud, definitely. What makes this special for me and why I'm standing here or in this ecosystem is really that I find it fascinating that these DAOs are funding science in overlooked areas and really bring these cures to patients or technologies to the societies of this world that are truly needed. And I think overall we can say DeSci is really showing traction, and we've already, in this short period of time, we've already come a long way. And I brought a couple of data points only looking at our of our ecosystem of the first 5 BioDAOs we've accelerated in our cohort 1. And we see that, yeah, there's actual proof that this model might be the shot and might be working well. We see that we're able to fund these treasuries in amounts of 10 millions, treasuries that then go on to fund science in these overlooked areas. So science, funding into science have already been deployed in the amounts of roughly 10 million. And not only that, but we see that the traditional science world, both academically as well as the industry, are picking up and jumping onto the bandwagon of DeSci and BioDAOs. DeSci and BioDAOs is being featured in Nature Biotech. Influential investors and influential Web3 personas like Brian Armstrong or CZ from Binance are advocating for BioDAOs and DeSci and saying, hey guys, look at that direction, go and build there. And so this, there's obviously different factors to it, but we've already seen an increase in market cap and can say that our ecosystem alone has already a cumulative market cap of over 100 million. And one last data point I want to share, and I think that is outstanding and great to see, is that the traditional biopharma or biotech companies are also onboarding into DeSci and seeing this is an innovative force we better not neglect. So we are building with industry giants already, from Novartis, from Pfizer, MIT, UCLA. Now, after having built in the space for 1.5 years, more or less, and successfully graduating the first cohort of BioDAOs, we took a little break, or at least a step back, to align again on the fundamentals and check in, okay, what are the next big roadblocks that we as a BioDAO accelerator can unblock to make human progress unstoppable and to make these DAOs get there. And so we started off asking ourselves, why are we here? Why are we even doing this? And yeah, we really believe that this DeSci as a new scientific paradigm can get to this unstoppable human progress. We believe that the DAO model, if we apply it to every disease area and every other area of life science out there, can really drive abundance of technology and eliminate human suffering to the furthest extent we can imagine. And building on that, we went to the drawing room basically and brainstormed and looked at what are the learnings and experience we are taking from our first cohort, as well as looking like from a bird's eye view onto the space. What are the biggest roadblocks DeSci and BioDAOs are facing at the moment? And obviously there is a variety, right? There's so many areas. It's a nascent space that is just starting up, basically. There's problems in governance, in the efficiency of treasuries raised and actually science funded, right? With operational overheads, etc. But what we want to boil down onto, and where we see our next big impact and potential, is driving into the tokenomic and crypto-economic realm. Because what we see is the actual roadblock for scaling DeSci is that DeSci is suffering from having low liquidity, and investors and users are looking at projects and seeking deeper liquidity to decide if they want to get in or out, if they want to get into the project, because essentially it's an indicator of how interesting and like how demanded the project is, and also how easy it is to deploy your capital and also to get out, right? And so the second problem we're seeing, and it's coupled to this, it all comes into the same problem space, is we already see that users in the BioDAOs are seeking for more new utility of the governance token, of their governance tokens. They want to make those governance tokens more productive. And they are kind of recapping, hey, what do I know from the DeFi summer or DeFi time, or in general the DeFi principles? And so we already see users in the discourse of the BioDAOs asking, hey, can I make more use of the governance token? Is there a way to stake it, to make more use of it? And lastly, and also a very important factor, is we see there's still a huge opportunity for more capital to inflow into the space, essentially to fund great science. And so there is a big audience of Web3 investors and the broader crypto ecosystem that are already kind of sensing, ooh, DeSci, that's a hot topic, and a real good use case, and it's impactful, wow, that checks off a lot of boxes. But they sure don't understand biotech. I mean, it's a very hard subject, right? And they surely don't even, or they, one layer down, they probably don't then understand like single asset development or a certain research space like women's health or SynBio. That's very hard, right? But they are looking for exposure. They know that biotech and Web3 together is like a magic wand. So now we're coming to a possible solution here, which the team and I have been working on over the past 6 months. And today is actually the very first time that we are publicly teasing and announcing this new system and that we've been building. And so BioXYZ, the accelerator, is step-by-step decentralizing and becoming its own DAO in and of itself, guided and governed by Bio, the governance token, the cornerstone of this ecosystem. But Bio will be more than just governing the DAO. It will introduce a liquid acceleration layer for DeSci. So a new layer on top of the already existing ecosystem that builds on the dynamics and mechanisms that we know from DeFi, where users, for example, as one use case, can make use of their governance token from the BioDAOs they have. So, for example, their Athena DAO token, their Valley DAO token, they stake that in our protocol, and they get liquidity mining rewards, the Bio token. And Bio is sort of an ecosystem, right? It's backed by its underlying assets. So all of the BioDAOs that run through our acceleration program, they, in return for participating in the program, they hand over or they put some of their tokens into the BioXYZ treasury. And so the BioXYZ treasury really builds on the value of its underlying BioDAO tokens that are part of the ecosystem. The way we are currently thinking about rolling the system out step by step, and bear with me, it's like whip, very whip. We are building in the background and we're having a lot of conversations. But what it looks like currently, the way we anticipate launching the bioeconomy, is by starting off with a DeSci airdrop, which essentially rewards those who've been part of the space and part of the system for a very long time, have been active in the communities, have been participating in on-chain activity. Yeah, you'll soon find out if you're part of that group. The next step will be the biogenesis swap, which essentially is an on-chain fair launch where people, the users, can take their BioDAO tokens, Athena again, or Grow, whichever are part of the biosciences ecosystem, and swap those in to get bio. Bio is non-transferable at this point. There's no other way to get into the bioeconomy, so this will really be the first step and your first, the first mechanism for you to get your hands into the system. And then lastly, and I guess what I would like for you to take away from introducing the system, the most important component that solves some of these problems I talked about before is instantiating we nickname the project internally currently the biopharmacy, where users can stake their BioDAO tokens and earn those liquidity incentive rewards that I mentioned a bit earlier. Yeah, and with this system rolling out step by step, we believe that some of the most crucial problems for the DeSci space, which is a lack of liquidity depth and a lack of being able to onboard more capital and get the broader ecosystem involved, will be solved. And if we couple this with driving on the bioaccelerationist movement altogether, if we really jump on the bandwagon and make this movement as loud and flourishing as possible, then I think we have a great mix and a great way of achieving scalability in DeSci. I hope this got you excited or curious at least. If you want to find out more, or if you even want to participate in the bioeconomy, help us build this out, contribute to the DAO, and join this whole movement, or learn more about the accelerator anyways, then join our Discord. There's a QR code here. If you're a builder and you're curious to find out how to get started with building a BioDAO, come talk to us, or also scan this QR code. And very last thing I'm going to end on with is if you want to physically feel what it's like to be part of biosciences team and the community, you can grab one of these very nice shirts after the presentation. I've got a few with me. You can find me outside. Oops. I also got very sick socks. So but then you'll be locked into the system, right? We're gonna work together then. No, I'm just kidding. Hit me up afterwards. I'm also open for any questions. I hope you enjoyed this, something new, something that will level up DeSci, hopefully. And thank you so much.
Thank you so much. Again, more shout outs to SynBio. Thank you. If you guys don't know by now, I'm a SynBio person. That's how I ended up here. So our next panel, I'm very excited to introduce. This is Lou de Querjuelves. Sorry, I butchered that. I'm so sorry. And Bogdan Serstia. Come on up here. So Lou is from Foresight, and Bogdan is an AI researcher. And, oh, wait, Roman. There you are, Roman Bauer from Combine Lab. This is guiding the beneficial development of high-impact technology. All right, how about it, folks? Okay.
Hi, everyone. Can you hear me? Is the mic working? Here. And maybe could I borrow your mic? Thank you. Okay, this is for you. Maybe come closer. I'm gonna sit here. Hi everyone, can you all hear me? Is my mic connected? Okay, amazing. It's a real pleasure to be here with you today and with Roman and Bogdan. So my name is Lou de Carrilvé. I'm Director of Program at Foresight Institute. Bogdan is AI safety researcher and also a Foresight Fellow, and Roman is work focuses on biocomputing. And also neurotech in part. And so for those, who knows about Foresight Institute here? Okay, so for those who don't, we are pretty old, like 38 years old, non-profit based in California that has been, for all this time, accelerating the beneficial development of really high impact technologies. We focus on AI safety, cryptography, neurotech, biotech, space technologies, and biotech for longevity. So the conversation that I would like us to have today, it is one that is about the intersection of decentralized science and existential risk and existential hopes, and applied in particular to the two fields of our fellows today. So maybe as a way of introducing yourself to the audience, you could tell us what project you're currently working on that you feel, let's say, most excited about, especially in relationship to existential risks, existential hope, and decentralized science. Bogdan, maybe you want to start? Cool.
Yeah, thanks. So I'm currently working on this general idea of automating AI safety research. So I'm very excited about this, both from the perspective of avoiding existential risk from AI, but also from from a more optimistic perspective. I think this could make a really big difference. Like if this works and if this can be used safely, we could produce a lot of AI safety research in a relatively short amount of time. And I'm also, this year I'm a Foresight Fellow in neurotech, and I've thought in the past about the intersection of neuroscience and AI safety, and I'm still thinking about it, though it's become more of a secondary area of research for me.
Right, hello everyone. So my name is Roman Bauer. I'm a senior lecturer at the University of Surrey, just nearby. And I would like to highlight two projects. So one project is called Biodynamo. I'm the spokesperson of Biodynamo, which is an international collaboration for computational biology research. And we have created the arguably most performing agent-based simulator in the world. So the agent-based simulators are computer software that allow to model biological systems in a certain way. I become later on going to more depth. But essentially, that's one project that I'm very excited about, also because I'm very grateful for it. We received some funding from Foresight for this to essentially create a computer model of a neural network that is biologically realistic. And so we would really try to emulate how nature builds neural networks, which is starting from a single cell, right? You can try to create a brain from scratch, which I wouldn't advise because people have tried before. But another approach is to simulate really how from a single cell this complexity develops, and that's what we are looking into. And by the way, I will also say it later, if you know or if you are a smart potential PhD student, please get in touch with me now that we have this opportunity. And the other project is I'm putting on now a different hat, which is I'm a co-director of a recently created company called Oxford Cryotech, or Cryotechnology, which we co-founded together with Professor Pedro Magalhães and Emil Kensiora, Dr. Emil Kensiora. And we are doing cryopreservation research. And also there we actually recently were awarded some funding from CryoDAO, which I'm also very grateful for. So these are the two kind of projects that I'm extremely excited about and that are directly supported by decentralized science projects.
Amazing, thank you. So in those projects, how do you think about existential risk and like safety. Okay, so in all the disciplines that you're working on, whether it's AI safety or biotech and also neurotech, there is really big questions about existential risk and the potential also for existential hope in like addressing and solving those risks and building solutions. So how does that like, you know, how does that tie into the specific projects that you mentioned, and yeah, where do you see the big like ethical considerations? What should we really look at when we are talking about decentralized science? Because there are big questions, right, in like decentralizing, whether it's biotech or AI safety.
Yeah, so I think a lot could be said here. I think the way I'm thinking about it, especially in the context of automated AI safety research, let's say, I think basically we could try to use AI to help us align AI, to help us make AI itself safer. So it's kind of like a mix of like, on the one hand, you're trying to avoid risks, including existential risks, but you're trying to also potentially use the technology to help you make the technology itself safer. So it's also kind of like an existential hope side to this. I think there are a lot of open questions about how to do this, and I'm currently trying to help make some progress on this. Similarly, with respect to neurotech, I think, it's just there are so many open questions also here. Also more, I mean, obviously, if we're talking about aligning sport intelligence, this is like the concern scope, like the spectrum of concerns is very large. I think it's kind of similarly for neurotech and like for technologies which are very close to humans. You have a mix of concerns.
Do you want to just, as a follow-up question, dive a little deeper into this? For instance, recently there was this article in Times about this report that came to the US government about open sourcing AI, large language models, and they were like, basically we recommend you don't, and to straight up like make it illegal. Do you have thoughts on this?
I have kind of like mixed thoughts. I think like open sourcing very powerful AIs could be very bad. Like open sourcing carelessly very powerful AI could be really bad. Like you could think of various ways people could misuse those, like creating bioweapons, cyber attacks. Like, there's a whole, or like just like using them carelessly, like the typical AI takeover scenarios. So I think definitely like open sourcing in a very careless way, or like open sourcing at all, very powerful AIs could be really bad. I think for current systems, it's a bit more, my opinion would be a bit more mixed. For example, I think current systems don't seem very dangerous. So, and to the degree they would allow for more, let's say AI safety research to happen by like allowing academics or people or like various researchers with less resources than the top labs to produce more AI safety research, I think that might be overall good. So I think for now, like just now, I'd probably be happy with open sourcing large language models to go on, especially done carefully. But for the future, I'd be very cautious. And I'm probably on the side of like, at some point this probably really needs to stop. This would need to stop.
So to you, we are close to the limit where we need to stop.
Sorry?
We are close to the limit where we need to stop in terms of...
That's another issue, like we might not know when we are close to the limit. So like that's another reason to be cautious. I think I'm relatively optimistic for now, but like that limit could be very soon. And like it would be good to have something like legislation or at least have thought about that hard before it's needed.
Cool, thank you. Roman.
Yeah, so maybe the first part of your question about how this relates to AI safety related issues. So regarding BioDynamo and the software that I mentioned before, and the collaboration, which is an international collaboration. So it has already done some steps towards decentralization, even though it's not yet on the blockchain. But the collaboration is governed in a pluralistic manner, and I'm very much interested in pursuing ways to really bring this to the blockchain and create a DAO-like entity from this. So I'm very interested in speaking with people who maybe can advise and help with this endeavor to bring this into the blockchain. But regarding safety, one of the big, I think, risks that we currently have, particularly with large language models, is that they are still kind of black boxes, right? We don't really understand them. It's extremely complex. It's a black box. And I think one way to address this is to create new kinds of AI systems that are not purely statistical, like the large language models and deep learning are, but they are a bit more human-like, because then that facilitates also interactions with us, because there is a mechanistic model underlying those systems, which is inspired by the brain. I mean, also, obviously, large language models are inspired by the brain, but they're still very, very far from how the brain is organized. The brain doesn't have like several hundreds of layers that are stacked on each other. And I could go on, but current large language models are very, very different from how the brain is organized. And so there's a gap there, not only for making AI more human-like, but also to better understand our own brain, right? There's a component of how can we understand the brain? It's extremely complex. It has 86 billion neurons, and we need computers to understand the brain. And so one way to address this risk of AI is, I think, to do research that enables us to better understand the mammalian and human brain, and then see how we can bridge this gap towards complete black box models, which LLMs are. And the other project with Oxford Cryotechnology, I mean, it's a company, it's not a project anymore, is about cryopreservation. And I think cryopreservation is one of those topics that has been completely neglected, I mean, very much neglected by the overall scientific community, unfortunately, and that's why there hasn't been much progress in the last few decades. I mean, we still cannot cryopreserve organs, even though there has been recently some very promising results, but not on the scale of human organs, unfortunately. And so I think there is a lot to be said about funding cryopreservation to address risks such as, obviously, in health. I mean, if you could store organs in a scalable manner, this would save many lives. There was actually a few years ago a paper published that estimated that about 1/3 of all deaths could be avoided if we could have organs available without any shortage. So that's a huge number. And so in Oxford cryopreservation cryotechnology, we want to address this gap, this huge gap, by developing new kinds of cryoprotective agents. And then, of course, there are other applications like space travel, right? It was mentioned before that, I think to Mars it takes maybe 6 months or so to travel, but then if you want to go further, already 6 months is a huge time, right? You don't, if you're in a confined space. So we need new ways of space travel, and biostasis type of approach, I think, would be mandatory if we want to really go very far. That's another application. And then, of course, regenerative medicine. I mean, you need stem cells to be cryopreserved. You need all kinds of medical types of technology need to be, if they could be preserved for a longer time, this would save a lot of time and effort and money at the end of the day. So yeah, these are these two AI safety related thoughts that I wanted to share.
Cool, thank you so much. And so again, to both of you, in which way does decentralizing science can help with the sort of like positive aspect of these risk and like big considerations in AI or else. I think there are also a lot in biotechnology. And how, like, have you seen examples of decentralized science solutions or architectures really helping with your projects or other projects that may be really beneficial for the long-term future and flourishing of humanity?
Yeah, so I think I'm somewhat less familiar with the decentralized science space than with the AI safety space. But for example, I've seen donations in cryptocurrency towards AI safety projects. So I think that was helpful. Also, like Foresight is involved in the DeSci space, so I think that's also helpful. I'm more unsure with respect. So, like, one way could be something like you could, for example, something like the decentralized science of AI safety. Like, I could imagine something like that, but again, I'm somewhat less familiar, and I would also be a bit wary of potential risks. I think I really I've seen this framing from Vitalik Buterin of DAC, something like differential accelerationism or like a decentralized accelerationism. And I think especially like the idea of differential accelerationism, as in think hard of like what would you actually want to accelerate and like what the potential impacts on both sides could be. I think that's a really good framework. I really like that.
Yeah, me too, actually. So differential technology development is, just to remind everyone, is the idea that you select which technology to accelerate and in which order, hoping that like arriving at a certain level of development of one technology will help to like make another technology more safe and beneficial. So you could think about the example you were giving, Roman, about if we develop AIs that are more based on our like human brains, then they may be like easier to understand and like have aligned that the large language models, which are black boxes and very different architectures from our biological brains. Do you have example in mind of like differential tech development that you'd be, if you could be like, oh, if only we could be there with this technology, then this would help for this one?
I'm unsure again, but for example, in that blog post, Vitalik Buterin does mention BCI actually, brain-computer interfaces, as one way. Yeah. I think it's plausible that could help. I'm also obviously very biased because I work, or like I have worked and I still think about it sometimes. But I think, basically I think it's totally plausible that there are ways to like do differential accelerationism. Also, for example, I know AI for AI safety, so automated AI safety research. But I think, I wouldn't be, I think it's definitely an area ripe for research and for like ideas, but I'd also be a bit cautious to say like, oh, definitely this one is gonna work.
Cool. And you, Roman?
Yeah, so regarding decentralized science, as I mentioned, within Biodynamo, we have made some first steps towards decentralization, which I think is ultimately where we will end up with. I think it is important to maybe start this, at least in academia. I'm not myself, I don't have a lot of experience in industry, but in academia, I think it is important, at least at the very beginning, to start this organically, to create some connections with other universities and see, can you collaborate with one another? Because often some people, as you may know, they have some big egos and it's difficult to collaborate. So you need to, I think the chemistry needs to first be right, at least in the core, right? At the very beginning, you need to create some organic growth, which we did. So we now are about 7 or 8 institutions in Biodynamo, including, for example, my own university, the University of Surrey, but then also CERN in Switzerland or University of Cyprus, for instance. So we have been growing quite a lot recently. that and such a growth obviously always also has a risk, right? We don't want to just grow in an uncontrolled manner. Because then that of course can be then again challenging with regards to collaboration. But potentially with blockchain technology, this can help and really pave the way towards a more meritocratic collaboration scheme. And yeah, I think Biodynamo could be a very nice test case to see that how would it be realized? Because until now, I haven't seen really any academic projects that then went into this direction and then gave rise to fruitful outputs, whether this is in terms of papers. I agree, of course, that we shouldn't just publish papers. There should be a real-world impact, and that's why also I co-founded Oxford Cryotechnology, because I think we need to get out of this silo of academia. We need to interact much more with industrial players, and so I actually have in mind another plan for neurological conditions to create a company to help with diagnosis, because we developed a technology that can do that very easily with retinal fundus images. So these are images of the retina, which are very cheap to acquire, and we have shown that we can actually diagnose Alzheimer's disease and Parkinson's disease reliably with this technology. But now there's this huge gap, this death valley that was mentioned before, and so I think as academics we should also help push this gap and bring it to the real world, because we published it, but it's still not there. So that was with regards to decentralized science, and yeah, as I said, Oxford Cryotechnology is still in its very early stages. We just recently have made these steps, and hopefully in the future we can scale up this, and we are very interested in collaboration also, of course, if you're interested in cryopreservation, especially of neural cells and neural tissues. That's where we focus on, including using computational methods. So I'm a computational neuroscientist, and also Professor Pedro Magalhães, she's a computational biologist. So we want to kind of be very interdisciplinary and at the same time also inclusive to have a large variety of experts on board.
Awesome.
Yes.
And on the differential technology development, I mean, you did mention earlier an example, but just if you...
Yeah, so I have to say here I maybe have a slightly different opinion. I mean, in my opinion, currently those large language models, I'm very much for open source. That's also why why Biodynamo is published actually for free. It's open source. We are happy to collaborate with people to work with us and add their code. But at the end of the day, I think for large language models, for example, we need some regulatory bodies that give their approval process. I mean, it's the same thing as with nuclear bombs, nuclear technology and other dangerous technologies. I think technology is always a two-sided sword, right? And we don't want to just push one technology down because we're afraid. I think if you have the proper regulatory bodies that similar to the FDA or whatever, then we can deal with this. But I think we should not be led by fear at the end of the day. So I mean, I'm not sure if that answers this particular question, but I think we need better regulatory laws and bodies that can address AI technology. And so maybe in the future, if an institution wants to release some AI as open source, then this has to go through a process, of course, a thorough regulatory process. And if this is accepted and it's deemed not to be necessary to kind of stop this, then I think it's okay if it's published as open source. But that should be judged on a case-by-case basis. That's what I'm saying. I don't think one should a priori just say, oh, this technology is too dangerous, let's slow this down. I think everything could be used in very positive ways as long as it's understood what the dangers are and how to address those dangers.
Cool, thank you. And maybe just to touch on the hope. What makes you most, both of you? You said you were optimist, and you don't seem too worried either. So I'm personally very concerned. So give me hope, please. What makes you most hopeful, like about the future, the existential future of humanity?
Yeah, maybe to clarify a bit, I think I'm pretty optimistic among AI safety people, but I don't know if I'm that optimistic among the random person on the street, let's say. I think what makes me optimistic is that I think it's these are not impossible problems, at least, and that if we do solve them decently well, like, life could be way better than it is for many people and for many people in the future. And yeah, I think like even the word utopia would not be a mischaracterization of like what life could be if we make things go well.
Yeah, I agree with that. Well, yeah, I look forward to having a solution to these problems. What about you, Roman?
Yeah, I agree. I mean, sometimes I hear or I watch some videos on YouTube from Yuval Harari, and sometimes I feel like he's very much negative on certain things in the future. And I think obviously there's always the risk that things can go very negative, but I think there's a huge potential, a huge opportunity that we never had before. I mean, we never had access to intelligence on this scale with this efficiency everywhere in the world. And because now we can really, I mean, you can be born in some place that has no, where like 50 years ago you would have had no opportunities, right? You would have zero opportunities to get out of this place. And now this person, if they have internet access and even an old laptop, they have at least a place to start, and I think now we can really enable a much larger proportion of the overall world population to get out of certain conditions that 50 years ago was just unimaginable. And so I think we have gone a long way, and things are much better now, in my view, than they were 50 years ago. Obviously, there is also other risks, but also 50 years ago, there were huge risks, right? There could have been nuclear war, and maybe there could be now. So things haven't changed that much in terms of risk. So I'm very much enthusiastic about the future.
Cool. Maybe one question for the audience, and then we have 5 minutes left. I thought we could take a few questions, actually, if you're okay with that. But you were mentioning nuclear risk. Just before coming into the room, Bogdan and I were discussing and asking this question of like, what would decentralizing the Manhattan Project look like? Like, what would it look like to work on it? And like trying to think of, okay, would there be any benefits? And if so, which?
Just to clarify, I was thinking of like something like, could you do a decentralized Manhattan Project for AI safety? So not for nukes. But yeah, I'm unsure even for AI safety if it's a good idea or not. Like, there are many ways that could go wrong. Like, you could imagine people using that to advance AI in an unsafe way. You could imagine models getting stolen, and like very powerful models getting stolen. Like, yeah, I'm unsure, but I think it might be an interesting topic for some people to think about, at least.
Yeah. Any questions? Yeah, maybe I can, here, I'll borrow one of your.
I was curious if you have any latest updates on the neurocryonics, where we are at with that. That would be great.
Yeah. So there, as I said, unfortunately, because it has been completely underfunded, there's even no way at the moment that the student who wants to study cryopreservation can directly study cryopreservation. There's no such, in most universities, as far as I know, at least in the UK, and I'm sure in many others, there is no module called cryopreservation, right? It's like people assume, biologists assume that's just a method, and that's it, and kind of way. So unfortunately, at this stage, I think we need much more funding to make this step towards neurocryopreservation, because neurons are actually a bit more challenging to cryopreserve neural tissue than many other types of tissues, also because of higher lipid proportion. And the synapses are, of course, very delicate structures, and our personality is to a large extent stored in the synapses, right? And up to now, there's no proof that we can really cryopreserve intact the microcircuitry of a mammalian brain. So I'm afraid we need much more funding to really get this. So I think we need a Manhattan Project for that, because if we get this, I'm much more positive that this will work than slowing down or stopping aging process, I have to say. I mean, I've worked on I work also in aging, and I know many people who work in aging as well, and so I think cryopreservation has a huge opportunity. It's just we need more awareness and more support.
One very last question, quick one, David.
Thanks. Bogdan, you talked about restricting the release of some AI models on open source, which I'm sympathetic with, because some other people may say, hey, I'm going to remove these woke checks. I'm going to remove these unnecessary health and safety checks. So they might do it carelessly, or they might do it maliciously. But some of the most powerful people in the world have said, hell no, I'm going to release my software as open source. I'm thinking of Elon Musk. I'm thinking of Mark Zuckerberg, who is backed up in that point of view by Jan LeCun, who is his head of AI research. And both of them are saying, don't you dare slow down open source. How do you think there's a way to get an agreement on that?
Yeah, I think I actually agree with Roman that having some regulatory processes might be like the first step, or like I think that's good on its own, separate from the open source, from like completely banning open source question. Yeah, so I think that definitely be a first step, like trying to at least start to have some processes of like, okay, and like this is already starting with the executive order in the US and the EU AI Act and a lot of other, and in other places. So I think for relatively near-term models, that's pretty good. My worry would be that at some point, like it might be very hard to be confident that there are not powerful capabilities inside the model. So I think for now, like regulatory bodies could have some way forward with like, for example, if you know that models are not capable of doing, like for now we are safe because the models are just not capable enough. Like their dangerous capabilities are just limited because they are not smart enough. At some point that's probably gonna stop. And then I don't think we have the science right now to like our confidence is only coming from the lack of capabilities now. And when that will stop, I don't think we have anything in place. So if it was to happen now, I think banning would be the only solution for now, like if we wanted to be very confident. And like the way forward is probably AI safety research, I would guess.
Thank
As
you.
the first step.
Thank you so much. Thank you, everyone. We are done with this panel. Thanks for you can find us in the corridors or at foresight.org for more info. Great.
If you guys want to leave your mics here, that's great. Just leave your mics. Yeah, it's fine. Okie dokie. What? Oh no, I just asked you to leave you guys' mics there. Oh, you're totally fine. Okay, so I am looking for Julia. There we are. There's our panel. Okay, everyone. So I know you've heard my voice a lot and seen me running around today, and now we're going to do more of that because I'm actually going to chair this panel. So, beautiful. Thank you. Oh, is this from Alfie? Did Alfie bring this? Someone brought this. It's beautiful. I love it. Okay. All right, my fine friends. So we have mics. We have one mic there. Where's our second mic? You know, you can take this one. Testing, testing, 1, 2, 3. Hey, that works. Okay. Welcome, friends. So this is our policy panel. I was supposed to be a speaker on this panel. Hi, surprise, I'm now your moderator. So it's one of those days we just roll with it. So what I'm going to do is I'm going to ask you both to introduce yourselves in a second. I'm Fiona. You guys have heard me a lot today, but my background is in engineering biology, synthetic biology. So that's how I come to this world. I work for a company called SynBio Beta. We're the world's largest networking organization for the synthetic biology industry. And one of my many, many hats is policy. So that's how I ended up here today. Much more interestingly, Julia, please introduce yourself.
Hi, lovely to meet you. So I'm Julia. I'm the co-director at UK Day One. So UK Day One is a sprint that we're running before the election this year. What we're doing is we're crowdsourcing policy ideas from scientists, entrepreneurs, technologists, people like yourselves, and we're putting them through effectively kind of like an accelerator where we work with policymakers and experts to make policy ideas implementation ready, and then we would propose them to the new government. So this isn't a new idea. It happened in the US and it was hugely successful there. In 2020, they were able to put 200 policy ideas together, present it to the government, and as a result, $2.11 billion were moved. A lot of what you see in the CHIPS Act, for example, was originally part of the US Day One initiative. So the point is, it worked in the US. We have an opportunity here in the UK with the new election, a policy window to get new policies through. And we're here to help people like you get your policies on the government's books. So I'm sure we'll talk more about this during the panel, but if anyone has any ideas, come talk to me.
Outstanding, thank you. Alvin, please introduce yourself.
Sure. Hi. Yeah, thanks everyone for listening. My name's Alvin. I'm a co-founder of the Better Science Project in the UK. And basically what we're trying to do is identify solutions to many problems in the science ecosystem and sort of implement them in practice through a mixture of incubating entrepreneurial projects and getting policy changes put through. So maybe a bit of background about myself. I was a former scientist at some stage. I did my PhD and a bit of a postdoc in Cambridge. And sort of through that process, I realized that lots of talent is not really being well spent because scientists are going into work and they're not able to focus on actually doing the work because there's so much sort of politics, there's so much bureaucracy, there's so much, we're optimizing for papers. You know, I think there's a stat that most PIs spend at least 40% of their time looking for funding and on other administrative tasks. And we were thinking that so many of these things were structural features of the system that could be changed. And I think at Better Science, what we want to say is, you know, a lot of people recognize there's a problem in science. Almost across all academia, across industry, people recognize there's a problem. But in terms of the change approach, we have to actually get things implemented in practice. So there's no recourse that, you know, nobody's going to go in and fix it. Not many people have the power to. Government has their own series of incentives, and you need to influence them in the right way. Basically, we're trying to adopt a really pragmatic experimental approach where we try out real solutions and see if they work. So yeah, I think that's more or less it from us.
Brilliant, thank you. So I want to kick us off with a bit of a lay the groundwork here because we've been talking a lot about DeSci and DAOs and chains and on-chain and off-chain and all these. Actually, I don't actually know if off-chain is a phrase. Obviously, I am not from DeSci, so sorry about that. But I do want to understand, how does DeSci and policy intersect? Because right now they seem pretty far apart and they kind of maybe meet a little bit in the middle with AI. But how do you see these two coming together if we want to build a different kind of future? Maybe we start with the current election. What can we look forward to in the coming election, and how could that affect the DeSci community?
Yeah, so I guess it makes sense to first think about what the priorities are for the likely incoming government. So good to say we're nonpartisan, but if we look at the current political reality, we're probably looking at Labour being the new incoming government. What's their priority? Growth. Everyone's heard what Suella Braverman came out. No, not Suella Braverman.
Hopefully not.
So growth is number one priority, but the second thing is balancing the books. Anything that goes through needs to either make money for the government or ensure that no extra money is being spent. I think a way that could connect with DeSci and I'm not an expert in DeSci, is when we're thinking about how we're funding science, so how are we doing science, and how can the government think about innovative models to fund science, how can we streamline the current system, how can we ensure that we have more accountability when it comes to how people are then using their grants. These are all big questions that DCIT and various departments like DCIT, like the UKRI, and Number 10 are thinking about. So I think that that's something that the decentralized science community can think about as well. Yeah.
I think that's a really good point, and I think you've touched on something really important, which is how grants are used. I mean, we are living with limited resources when it comes to UKRI funding, for example. A lot of people want grants. Very, relatively few funds are distributed. So, Alvin, I want to take this to you because you talk about, the inefficiencies that you see in academia, scientists spending a lot of time not doing science. How do you see your work supporting them to actually be able to do the science and utilize those grants more effectively?
Yeah, sure. So maybe I'll actually answer part of the first question you said first, because I think there's an interesting point that the intersection between DeSci and policy is it's very important, but it's very indirect. So what I'd say is the most important thing is there's sort of this science institutional ecosystem as a whole. There's funding bodies, there's publishing, there's academia, there's industry, and DeSci per se isn't necessarily in the sort of awareness space of most policymakers at the moment, but policy does matter to DeSci as a whole because of the way in which academics are incentivized at the moment. Because right now you have concrete outputs that are often measured by sort of administrators, like publications, like things like that. And while that's the case, and while funding is largely tied to these things, it will pose a barrier to the adoption of lots of DeSci, right? An academic isn't going to want to publish in a DeSci platform if they know that they actually need to use a traditional institution to try and get their next round of grants. So I think there is a really important intersection, but it's sort of indirectly mediated. And to be more specific on your second question, Fiona, how can academics use grants more efficiently? Well, I think the way we see it is, again, sort of zoomed out a little more. The grants themselves, I think, are quite often not really efficiently allocated. So at the moment, especially, for instance, there's a lot of smaller grants. Say you have a grant for 100,000. It seems like quite a lot, and you realize that 30 researchers have spent 2 weeks each applying for that £100,000 grant, and it's actually possible for highly prescriptive grant funding mechanisms to almost be deleterious. So one thing that we're arguing for on that side is that the way we're doing funding sort of based on projects is quite wrong in itself. And if there are ways to simplify how we allocate funding to make it a lot faster for researchers, that's really the most important thing. Sort of building slightly on that, I would say the fact that lots of grant money is quite prescriptive is quite deleterious. So researchers don't necessarily have to be equipped to use money better. They just would use the money better if we sort of freed them from any of these restrictions. So there was a survey in the US coming out of the FAST Grants program that close to 80% of researchers would actually use their money to work on something completely different if it wasn't for conditions based on grant funding. So I think that's the second thing, just sort of letting people have more freedom to do what they want. And finally, the third thing is probably a tools thing. So at the moment, outputs of research come in the form of peer-reviewed publications, and that's quite often, unfortunately, used as a proxy, both by individual researchers, universities, the government, for how much science we're doing. But there's actually this incredible decorrelation with the number of publications we get out and real indices of scientific progress. So in the last 30 years, we have a truly exponential rise in number of papers that hasn't been accompanied by, for instance, a rise in the number of molecular entities found in pharma. Like all these other measures, which are sort of more connected to the real world, are totally unlinked. And in fact, it might be that getting information out via publications is actually quite a poor way to do it. So I mean, there's sort of some efficiencies to be found here as well, I think, in the sense that if we can share data better, get more information out so people can read it and understand it better, I think that would get people, will basically improve the efficiency of funding.
No, this is really, really good, and this is, I mean, it's a really good overview of, we've talked about it before today, of, especially in the publishing system. It's very, very broken. It's inefficient on both sides. Not only can researchers not access the research because it's behind paywalls, but then researchers are de-incentivized to do good science versus just kind of generating papers. So how can we as a community communicate these needs more effectively to policymakers? Like, how can we interface with policymakers and academic institutions to start to drive some of these changes? I want to come to you first.
Join UK Day One.
Nice.
No, I think a lot of the times we've actually historically seen sort of policy entrepreneurs, and they might not call themselves that, but they are policy entrepreneurs, do fantastic work and get their ideas in government. So two very tangible examples, not in the science sort of sector in the UK, would be firstly YIMBYism, so thinking about planning laws. Like, this used to be a very niche issue. People didn't really think about wanting to build as a big tenet of what either Labour or Conservatives were talking about. And that small community was able to really make their case online through blog posts, on Twitter, and now YIMBYism is a huge part of the Labour campaign. Another example would be full expensing. There was a blog post that came out from the Adam Smith's Institute, and then 6 months later, you had that be passed by Jeremy Hunt. So it is possible to have that kind of effect from the outside. Now, what I think that people sometimes are missing, and the reason why it's not as easy for a normal layperson to impact policy is often they don't know the policy area itself, and they're not confident about it, right? You'll talk to an experienced policymaker, and you'll cite the wrong line on a report, and they'll shut you down. So they might not know how to make things implementation ready. They'll have a big idea, but they won't know where the budget's coming from or which department's supposed to do what to make their idea a reality. And that's really important. So the second thing is also the politics of the thing. I like to think about it like having a singular focus, but being able to weave multiple narratives. So one of the things that we really care about is at UK Day One is migration. So how can we get high-skilled immigrants, scientists, technologists in the UK? The way that I frame that to a conservative audience is completely different to the way I frame that exact same policy goal to like someone in Labour, or even within Labour, there'll be completely different focus areas. So that's the other thing. People don't necessarily know the politics of what they're speaking about and how to frame the exact same policy issue in different ways for different audiences. And then the final thing is connections. If you're a scientist, you might not know a Labour SPAD in a current Labour SPAD, and you might not also know who's going to be a Labour SPAD in 6 months. And that's really hard. But I think those are things that we're trying to do at UK Day One. We're trying to be able to coach people so that we can bring in the implementation ready side of things and tell them how their ideas can be implemented. We can teach them how to do the politics side of things. How can you make your idea amenable to various different audiences? And then finally, we have a lot of the connections, and we're building a lot of the connections that our policy entrepreneurs need to then push their ideas forward.
Nice. Alvin, do you want to add to that?
Yeah, sure. Yeah, I agree with lots of what Julia had to say. I think a lot of it is about the fact that going into number 10 or something is totally unfamiliar for somebody outside. It's quite like a confusing, sort of slightly opaque system from the outside. And I think a key is almost to find early adopters. I would say almost using sort of user terminology, but the small number of people within these institutions who are willing to actually support you, willing to spend some time to learn a bit more, because I think offhand a lot of this stuff is deeply unfamiliar to most political insiders, and the key thing for that is to find the right people and sort of speak in their language a bit in terms of why does this kind of initiative, why does improving the science ecosystem matter so much to many of the things that they care about, which are largely about economic growth, largely about using funding efficiently, and getting that messaging right is important. I think the second note that I'd like to add, and this is also related to what you said about YIMBYism, Julia, is that a lot of stuff around DeSci and science reform in general is sort of, at this point, non-partisan. At least there's an argument that it can be non-partisan, that both parties would benefit from it, and I think that's quite important to keep it that way. So it's quite important to make sure there's a frame to sell to both the Labour Party, the Conservative Party, etc. Because I think lots of the changes we'd want to implement, we don't want it to be polarized, especially because they're going to take more than one electoral cycle to implement. So yeah, I think it's important to make sure the sales pitch sort of goes to both sides.
I would say also, just from my perspective on this, is that if you look at the science and technology framework that the UK put out through DCIT, there are 5 key, sorry, is it 6? Is it 5 or 6? There are 6 key technology areas. Go look them up, because each one of those is now a policy priority for the UK government. Labour agrees with the Conservatives, at least in that sense of, yes, we agree that it's, what is it? AI, telecoms, advanced semiconductors, engineering, biology, something and something else. It's almost all in the sort of web space, except for engineering, biology, which is in the more physical realm. Obviously, I focus on the SynBio side and bio side, so I didn't learn the others very well. Sorry. But do go find those, because when you talk to policymakers, you can point to these are already recognized technologies that are in the roadmap, and they're also recognized by the UK's closest ally, United States. We have trade agreements now that say, yes, we agree that these are technology priorities. So there's a lot of stuff out there, I think, to give us a better framework of how to interact with policymakers. And just as another fun fact, I come from the States, where it's really difficult to talk to anyone with any kind of power. Here it's simpler, because we don't have to wade through as much red tape. I mean, it's a lot easier to call your local MP versus your congressperson in the States. So take advantage of it, I'm serious. They're lovely people. I mean, everyone's so nice. And they, so far, seem like they actually really want to listen. And they know that the UK really needs to be a science superpower in order to compete, especially given the events of the last few years. So, yeah. So can we look across the world and look at other examples of where sort of decentralized communities have made inroads with policymakers, or are we too young of a space to see if that's come forward yet? That is a confusing question. Let me do that again. Are there hubs where we've seen, maybe it's Montenegro, but are there regional hubs the UK could emulate of say, hey, this is really working well in this particular community, how can we grow on that? Or are we already the leading forefront of the DeSci community space?
My feeling is that it's probably too early.
Yeah, fair
like
enough.
you said. It depends how broadly you're conceiving of, I guess, DeSci as a concept. I think the first thing is timescale-wise, really assessing things in science takes a very long time to see how well things work out, and using short-term indices can often be counterproductive. That's why, at Better Science, our stance historically has been sort of diversification of the way we do things. So if we try lots of things and make sure we're not overly confident in one method or another in the short term, that's going to lead to a healthier sort of evolution of the system in the long term. In terms of, I honestly maybe I'm not fully on top of DeSci per se across various countries, but in terms of the diversity and like the things people are trying, the UK is probably slightly behind parts of the United States. That's partly just because the US has lots of private philanthropy that's sort of more willing to experiment than maybe are more sort of government-based and long-term institutions here.
Yeah, the one thing I'll say as a sort of success case here in the UK is the DCIT just opened up their meta science unit, and Alvin will have more, like, he's the meta science guy, and he'll have a lot to say about it. But I think that means that the government and the community as a whole is at least starting to think about these things, and that's a really positive thing. And I think that there is a lot of appetite from the conversations I've had to think about science funding more like differently and to be innovative. But I'm sure, Alvin, you have some other thoughts on that more generally.
So I mean, the government in the UK has definitely like adopted a recent interest, and like there are individuals who are fairly well placed in the UK government who are really keen to push this stuff onwards. I mean, so I think it's a huge opportunity area. This isn't, again, DeSci per se, but ARIA, obviously most of you have seen, has been founded in the UK, and I think has huge potential to really change things. I think lots of the challenges here, we're maybe like more dependent on the state for some of this stuff than the United States for the reasons I mentioned earlier. There's just like a little less sort of private philanthropy going on. But on the other hand, like you said, Fiona, the state's actually pretty open to engage and like maybe easier to get to than the US.
Yeah, for sure.
I think just on that philanthropy point, that's one of the areas that we're looking at as well. How can we facilitate philanthropic investing into research and development in the UK? Because the laws in the US make that kind of investing a lot easier and make it more easier in terms of like tax rebates for it to be philanthropic. So if anyone has any thoughts on that, I'm also working on that, so let me know.
Fantastic. So in the last nanoseconds that we have left, are there questions from the audience? Yes. Ooh, okay, let me run to you. All right, you guys are gonna have to share that one, sorry. Okay. Where are we going? Ah, there you are. I love your coat, by the way.
Hi, Bob. Very interesting topic. I have a question for you. As academic scientists are a bit like in Hollywood. We judge how good we are based on our publication record and your latest publication. Is it in a high scientific impact factor journal? So this pushes a lot of people to publish fake results. And some of them get retracted from publication, but a lot of them remain. And even those that get retracted, it takes years to do that. How do you think, from where you stand in your companies, we can fight that?
Yeah, should I start with this one? Yeah. Okay, yeah, so, excellent point. I think my response to this is that there's a lot of, first of all, that it's like a whole system problem and there might be multiple levers, but I think the strongest one is probably in publishing, in the publishing arena. And there's a few things sort of at play here. In terms of, the first thing is probably incentives, right? So right now, as you mentioned, because you have to publish all these things in high impact journals, there's a lot of concerns about the reproducibility, accuracy of this information. So how do we improve the incentives? I think by taking alternative platforms and actually sort of making people use them and making them sort of usable and adoptable to the point where they can compete with some of these high-impact journals in prestige. And this is a huge challenge, and I think it's a challenge for many of you. I assume some of you are probably in the space where you're working in DeSci publishing. But if there are alternative platforms that end up being useful enough as tools, and maybe provide alternative metrics that people can use for promotion that end up being reliable. So, you know, here's my portfolio on a DeSci platform, and this is actually more important than journal publications. That's sort of one lever, I think. The second lever I would suggest is that the publishing platforms themselves can be scoped to increase reproducibility. And this plays out in two ways. The first way is if it's just easier to share data, then people are not going to leave so much information out of a scientific paper. So as a former scientist, I think that's a key problem, is that when you publish a paper, so much information essentially gets left out of it. You only pick out, the most high impact findings. And if it was easier for people to publish, then a lot more people would publish the opposite result really fast, and you'd realize quite fast that, some results tend to be one-off. And there's probably a second piece there about automation of tools to make data more accessible and to do some automated checks of reliability, and that might also be a second lever to improve data reliability. But yeah, I think it's quite a complex problem, but there are ways for publishing to tackle it.
Can you incentivize this from the funding source?
Yeah, that's a good question. So some people are trying to do this, for example, some funders are now tying their funding to open science, which I think is maybe incomplete as an approach, because journals can be sort of poorly reproducible in terms, even if they're open journals. So I think, so people, the people who are putting out platforms that are, maybe better for reproducibility should be making an active effort to engage with funders. It's not going to be easy, but maybe, say, instead of tying your funding to traditional journal publications, see if you would accept alternative forms of publication, maybe even make some of them required. And I think probably there's a system here where there's collaboration between, for you guys, some of the 4 DeSci funding initiatives and some of the publishing ones, where you can sort of link the two so that there's a link between the funding and the output, and you can almost, there's maybe an alternative ecosystem going on. But that's something that I think many of you in this room will have a better understanding of than me.
Awesome. So that is the end of the time that we have. Thank you both so much. Okay, I'm now going to go back to my hosting duties, which are over here. Okay. Thank you, guys. Woo! Okay, our final presentation of the day. I have a note here. It's a bit of a spicy topic. I'm very excited for this. So Terence Keeley, professor of clinical biochemistry and I guess, is it provost, vice chancellor? Vice chancellor. Just vice chancellor, which is quite significant, my fine friend, of the University of Buckingham, which is a private university here. Why the government should not fund science.
Thank you.
Love it.
Yes, I was very upset by the previous speakers going on about ARIA. Terrible thing. Governments absolutely should not fund science, and I will tell you why. And I will leave half the talk for Q&A, because I think Q&A is so much more interesting than just me pontificating. So I'm going to do this in 10 minutes, and then it's over to you. So which country gave us the Industrial Revolution? Britain. And when Britain was finally overtaken after about 100 years, it was overtaken by the United States. Which countries did not catch up with France or Britain or America during the whole of the 19th and 20th century even? France and Germany. Which countries did the governments fund science generously? France and Germany. Which countries were laissez-faire in science and the governments didn't fund science? Britain and America. So you only have to look at the last 200 years of industrialization to see that it was the 2 countries whose governments didn't fund science that were the leaders. Now, I'm going to tell you one story about what happened in America, and then I'm going to explain to you why it's a complete myth that governments should fund science, and indeed why it's even worse than that, why the government funding of science actually damages economic growth. So the story of America is very interesting. America was completely and utterly laissez-faire in science. It had absolutely taken the lessons of Adam Smith, the great free market economist, who dedicated a great deal of his book to showing that governments should not fund science. And the Americans took this to heart and didn't fund science. And the only time the federal government funded science in America was during wartime. So the National Academy of Sciences was created in the middle of the Civil War to create ironclads to beat the South. But apart from that, the American government didn't fund science. And then a terrible thing happened to America. So even after the Second World War, during the Second World War, the American government funded science unbelievably generously. You know, you've all seen the film about blowing up that bomb and stuff, Manhattan Project. But after the war, the Organization of Scientific Research and Development, the OSRD, which had funded the Manhattan and all the other projects, in 1947, it was shuttered. It was closed. Everyone was sacked. That's how much the American government did not fund science. It only funded science temporarily during wartime. But then the Cold War broke out, so the American government thought, well, does that count? Is that a real war? Do we have to fund science? Probably not. And then in 1957, Sputnik flew, and the Russians had beaten the Americans into space. Moreover, the Russians being a nuclear power, obviously they were going to nuke America from space. And America had what can only really be described as a collective nervous breakdown. They had lost to another country. And their amour propre was offended, and actually they were genuinely frightened. They knew how horrible they'd been to other people, so they assumed that people would be equally horrible to them. So the American government poured money into science. And within a 20-year period after the end of the Second World War, the American government was funding, well, in 1964, the American government was funding 3/4 of all pure science in America and 2/3 of all research and development being the wider thing. So you were a machine tool company in Minnesota, and you wanted to do some research because you had a competitor down the road. You wrote a grant to the Commerce Department as if you were a university. That's how much the American government funded science. And then after that, it dawned on the American government, but it's never talked about in public, that none of this was a good investment. And so now in America, it's amazing how little the American government funds. It only funds 20% of research and development, 10 of which is for defense. So the American government's only funding 10% of American R&D, the wider thing, and that's for things like the environment, health, energy. It's just the things that has a political purpose rather than an economic purpose. So here we have the United States of America from 1776 to the present day. No government funding of science until 1957, really, and then an explosion. And then a complete contraction. No one ever talks about the contraction because there are no votes in it. Complete contraction. What happens to long-term rates of American economic growth? Absolutely nothing. America's been growing at 2.5% a year since 1830, and it continues growing at 2.5% a year today. Obviously, in any individual year, you get a fluctuation, but if you look at long-term rates of economic growth, they are completely unaffected by the American government funding science. There's just no blips. And yet, we are told on all sides that governments have to fund science because markets fail. Markets don't fund science. Markets are bad. They're naughty. They should be spanked. Why aren't they funding science like good markets should do? And the story, it's a very clever story. This is the story. And by the way, when I say very clever, people like Ken Arrow and Paul Romer, you probably haven't heard of these terrible people because they're economists, but they win Nobel Prizes for saying this stuff. Nobel Prizes. What they say is this: no one will fund pure science or indeed R&D in the market because other people can copy their work for free. And then this is written absolutely. Anybody can copy anybody else's work. Now, as it happens, I know how to clone a gene. How many people who are not cell biologists do you suppose could clone a gene? If I went out there and picked up someone from a cell phone company and said, look, here's the protocol, go and clone a gene, he or she probably wouldn't be able to do it for about 5 years. And vice versa. If someone came up to me with a blueprint for a cell phone and said, Paul Romer says that anybody can copy science for free, here's the protocol, please make me a new cell phone, I think it would take me more than 24 hours. It is a complete and utter myth that other people's science is available for free. The reality is that the only people who can copy other people's science are those who have dedicated literally years of their lives to that specific area of science. And in so doing, they have produced their own science. You only know that you actually know a field of science when you've actually produced your own science. Either you publish your papers or you publish your patents or produced a product, whatever it is. But you only know when you've produced. Moreover, and it's not often talked about, but even in industry, scientists cooperate and collaborate. Even competitive companies collaborate, because if you can imagine you have 10 firms and 9 collaborate and 1 doesn't, who's going to make the next advance? It'll be one of the 9. It won't be the one, because they have access to 9 times more material than the other one. And so companies trade information, but only with fellow experts. No one's going to give away stuff to someone who hasn't got something to give back in return. That's the nature of industry, because it's in everyone's interest to do it. That's why, by the way, scientists publish papers. Why do we publish papers? Is it because we're such good people that we just want to share our knowledge out of a good heart? Well, you only have to meet the odd scientist to realize that good heart is not really a feature of that individual. People publish papers because in return they get recognition, and so people share knowledge with them. And so science, from the days of the Royal Society onwards, has always been about collaboration, because you get more out of collaboration than if you do it as a lone individual. So, and I'm going to stop to give time for lots of audience questions. What happened after 1945 in America, the head of the Office of Scientific Research and Development, Manhattan Project and all that, a man called Vannevar Bush, suddenly realized that Roosevelt and Truman were planning to close his huge enterprise. It was the biggest science enterprise in the history of the world. And he wrote this book, Science, the Endless Frontier, in which he explained, look, you've got to carry on funding science into peacetime because, as I said earlier, markets are naughty and they should be spanked because they don't fund enough science. And he lost the argument. But in 1957, the American government poured money into science, not because they suddenly thought science was a good thing. The American government is actually quite a hard-nosed thing. It just thought the Russians had beaten us into space, and God knows what else they'd beaten us into. And of course, it was all government funding. Now, I don't know how good your geopolitics is as individuals, but when in 1957, people like Eisenhower and others said, the Russians are going to overtake us economically. That is what people believed. It was genuinely believed that the Russian model of funding of science had shown that governments had to fund science because science is a public good. So Ken Arrow, the Nobel laureate, his papers received tens of thousands of citations in which he says, look, Russia, government funding of science, beating us into space, they're going to be the next global superpower. Well, I don't know if you've noticed, but Russia is not a global superpower because it wasted all this money because it was completely unrelated to the market. And you can put as many Sputniks as you like in space. It literally doesn't put butter on the table. So the American scientific community, however, was thrilled by the Russian advance because they went to the government and literally said, look, pure science has to be funded by the state. If you don't, you get left behind by the Russians. And so a myth, which is a polite word of saying lie, but I'm going to be polite today because I was well brought up. The myth was propagated by the American scientific community, led by the economists, but fed by the scientists. The governments had to fund science because otherwise you would fail economically. And anyone who said, well, how come since 1830 America's been growing at a steady rate and it's never changed? And now I will tell you why the government funding of science is a bad thing. There's only a limited number of good scientists. There aren't that many of us. I'm sorry, there aren't that many. And if, that was a joke. I won't make any more, I promise. And what happens is if the American government, or indeed any government, takes the best scientists and put them in the ivory towers and gives them wonderful labs and freedom to do what they want, which is great, of course, all the best scientists will go to the government labs. Of course they would. They're rational people. It'd be the same with the great artists or the great musicians or whatever. And so industry is only left with the less good scientists because the less good scientists can't get the top jobs at Harvard. They actually have to earn their living. But because they're not so good, and because it's difficult, copying other people's science is difficult. Only top scientists can copy other top scientists, and only top scientists can remain in front. Industry is left with the second division scientists. It gets less investment for its money, and so actually reduces its investment because it's not getting a return and does marketing or something. And so the government funding of science takes the best scientists out of the market, puts them in ivory towers where they do beautiful things, the equivalent of Sputnik in space. I mean, wonderful science. No one's saying that these universities don't do great science. But industry has been left behind. And that's why the government funding of science is called crowding out. People assume that if the government puts in $1 or £1 or €1, that's in addition to what the private sector is doing. Oh, no, it's not. And it's been shown, by the way, empirically, you can see it. As the government funding in America has gone up and down like this, the private sector has been the mirror image. The more the government funding science, the less private sector, because you're not getting the scientists to employ, the less the government funds science. The more the private sector does, because now finally it's got good scientists to employ. So the government funding of science actually harms economic growth. Thank you very much. I don't have a chairman. Do I have to identify people myself? You be the chairman.
I need a mic, though.
All right.
I mean, I have questions of myself.
Oh, well, you can't.
There
You can't.
have it. Well, ooh, can I use it? Lovely. I'm just going to work my way through here, and I'll save mine for the end.
Thank you. Is this working? Yes. Thank you for your talk. What about the, I guess, classic argument you would oppose to your argument, which is that not all good science is science that has the most economic value? So you could think of many examples where, you could, like, if economic value is the only thing driving science, you would potentially end up in worse equilibriums of places.
Yeah. Did you all hear that? What about non-economically valuable science? Look, of course, if a democratic legislature says, we want science because we're worried about global warming or whatever, of course that's legitimate. Of course it is. Just don't pretend it's going to stimulate economic growth, because it will not stimulate economic growth, and it never has, and it never can. So yes, government's funding science for non-economic purposes, CERN or whatever. You could give the money to the Opera House, or you could give the money to CERN. It's the same uselessness in terms of economics, but of course it adds greatly to the human condition, just like the Egyptians building their pyramids or the French building their Gothic cathedrals. These are cultural expressions. So yes, non-economic science, fine, as long as it's democratic government. Just don't think it's going to stimulate economic growth, that's all.
Actually, I want to disagree with you, if you don't mind, and then I'll pass the mic. I mean, the classic example that I always think of is CRISPR. That's funded from government. I mean, that's from Berkeley. That's public money.
CRISPR first came out of a group of, I'm not going to be, a very humble Spanish university. And it was a group of second-year undergraduates, and they were going out into the water, and they were picking up all these bacteria, and the supervisor back home thought, that's odd, because he saw, and it was a he, I'm not being sexist, he saw what was going on at the level of DNA, and it didn't make sense. It was then picked up by a yogurt company, Danone. It was then picked up by the French military, and it was then picked up by another non-government funding, I can't remember what the third entity was. And only after the full realization of CRISPR had come out, then did the state-funded people move in, and in a big way. But it wasn't discovered because of MRC grants. It was discovered the way so much great science is discovered, as an accidental byproduct of something else. And the byproduct was initially a teaching expedition of a humble university to second-year students looking at the bacteria.
That university is, the university is still publicly funded. And also, just to say here, CRISPR now has massive economic growth, so it doesn't quite exactly matter where the funding came from, whether it was Berkeley or it was a humble Spanish university. It's public money.
Look, universities absolutely don't need government money. The whole story of European universities is of them being nationalized. So the world's first university, as you all know, was Bologna, created in 1088, private initiative of the students. Padua, Montpellier, a whole series of Mediterranean universities, all private initiatives. Why? Well, why do people in America go to medical school and get MD after their name? If you go to university and get a qualification, you now have a qualification. You can earn more money subsequently. And that's exactly how the universities grew. At some point, popes and emperors suddenly realized that these independent institutions were centers of free thought, threatening the hegemony of the pope and the emperor. And so they said, we can't have that. We're going to nationalize these bastards to make sure they only do and say what we told them to do. The only exception to that, for historical reasons, the channel really, is Oxford and Cambridge. And so Oxford and Cambridge in England have remained independent universities, and of course Harvard, Yale, Princeton, all independent universities. It's the Anglo-Saxon tradition, not because Anglo-Saxons are better people, but because the English channel protected us from those popes and those emperors. If there wasn't a single penny going to universities in the world today, they would all be modeled on American medical schools. People would go to university to get the qualifications for the better life ahead. The nationalization was not because we need government money for universities, it was to crush them as centers of original thought.
My last point, and then, yeah. It's just,
Sorry? What did you say? The National Health Service. Let me tell...
there is no National Health Service in America, that's why I left, just so you know.
The worst health services in the world are in Britain and America. So we have the best universities and the worst health services. And the reason for that is ours is a completely nationalized industry, and it's crap. And the Americans, it's too far the other way. If you want a really good healthcare system, you go to the continent of Europe, where the state underpins a series of charities, and it's that mixture that really works in Europe. We've got it wrong. The worst health service for 1,000 miles around here is the British health service. If any of you fall ill and you have access to a motor car, for heaven's sake, drive over to France and get treated there.
I mean, in defense of the NHS, it's kept me alive, and I'm really pleased about that. So anyway, I'm going to pass this off before I get too grouchy.
So I congratulate you on a very good, set of provocations at the end of the day. You certainly entertained us and woken us up. But do you accept that markets fail sometimes? You said, oh, markets are naughty, they should be spanked. But it's in the nature of markets not to pay attention to externalities unless they are given attention to public goods and so on. So 3 counterexamples to what you're talking about. There's neglected diseases. A big pharma does not invest money in producing solutions to diseases that are not economically significant. Therefore, governments around the world, thankfully, have invested in this Drugs for Neglected Diseases initiative. And it may not be economically sparkling, but it's saved hundreds of millions of people's lives as a result. So that was governments getting behind the funding of science. Then the smartphones. You must know Mariana Mazzucato's argument that smartphones were not created by Steve Jobs, but they were created by research that the American government funded, such as GPS, such as touchscreens, such as many of the wireless protocols. They would not have happened without that public funding. And of course, Steve Jobs and many others made the smartphones wonderful afterwards, but it's only on the basis of public funding getting the system up to a sufficient stage. And finally, my final example is I am in the longevity business. I see lots of good ideas for solutions which aren't getting funded by VCs because they're too early stage and there's too much work to be done. That is where universities are more prepared to fund the basic science. And once the basic science is established, which ideas work and which don't work, then private funding can come along and be hugely humanitarianly important and hugely economically important as well. So my question again, do you agree that markets fail sometimes?
Of course markets fail. And there are 2 definitions of market failure. There's what we all understand as non-economists, markets failing, like 2008, for example. And then there's the neoclassical economic definition, but you're not referring to that, so we needn't talk about that. But let me just go through your points. Mariana Mazzucato is completely and utterly wrong. And what is interesting about Mariana Mazzucato is it's just a series of anecdotes. If serious economists produce a mass of data out of which you can then produce an econometric model that has substance. So those of us like Martin Ricketts and I who've shown that governments need and fund science, we produce our own models and got them published in good journals and all the rest of it. That is proper economics. She is about anecdote. And I mean, the anecdote that I think most interests me, and I'm going to throw this back at you, is what happened when ARPA. So ARPA, you all know what ARPA is, or DARPA. There was an individual called Senator Mansfield, and there was an audit in America in 1966, I'm just trying to remember the exact date, in which it was called Project Hindsight. And Project Hindsight was the first audit, this story is really important, by the way, the first audit anyone ever did about the government funding of science. And what Project Hindsight did is they went to all the research that had been poured into the Defense Department in America on the pure science element to see how much had come out that was valuable and important. And the reason there was this rare moment of insight, the Americans had just lost the Vietnam War, so this must have been around 1970, and they were in a bruised state. And what Project Hindsight said, and you're nodding so you know what I'm about to say, Project Hindsight discovered there were 700 advances in military hardware that had come out of the world up to that point that the American military had employed. And out of those 700, 2 came out of government-funded pure science, i.e. a complete waste of money. So after Hindsight came out, Senator Mansfield, who was the leader of the Senate in America, I don't know what the term is, he said, there's this terrible organization called ARPA that has all this money, and all they do is pure science. And we know it's completely irrelevant and it's unfair on the taxpayer. And he stopped ARPA from doing any more pure science. A very important episode in American history. Did he make himself popular? No. Senator Mansfield became one of the least popular men in American history. What happened, and I'm going to throw this open to all of you, what happened to all the scientists that Senator Mansfield sacked? Anybody? I'm sorry? Very good guess. Would you like to know? Very good guess. We'd like to know where they went.
Palo Alto?
I'm sorry?
Palo Alto.
Yes. And they worked for an organization you've all heard of. My brain is not functioning today. You know, thank you, Xerox PARC, thank you. They went to Xerox PARC. So Xerox PARC was headed by someone who'd been sacked from ARPA and was now running Xerox PARC. And when ARPA lost all these people, he said, come and work for us. And it's Xerox PARC that produced the technology that Steve Jobs and the others then copied at some later point. You all know that story. It came about because these government scientists in their ivory tower had been chucked out of their ivory tower, forced to earn their keep in the market, and finally did something useful. It's the exact opposite from your story. And the reason we know it's the exact opposite of your story is the only thing that matters in terms of economics is aggregate GDP. Aggregate GDP. So it's very easy to say, the reason I use the word aggregate, I've been talking about crowding in and crowding out. If you go to an individual company, and the government says, I'll give you $10 million if you put up a couple of $100 million of your own, then every rational company will say, oh, yes, please, that's a good bargain, because for the cost of $2 million, you now have $12 million. That's called crowding in. And there are lots and lots of papers showing how wonderful crowding in is. What people forget, in the aggregate, it's a disaster for the American economy, because all these good scientists go to this company because they now have $12 million to spend doing research they otherwise would not have done. They're only doing it because of the free money, taking the best scientists out of the rest of the market, which actually might have done something useful. So that sort of money damages the economy. So to come back to your point, if you look at aggregate GDP per capita in America, there's not a wobble. From 1830 to the present day, nearly 200 years. It's the most extraordinary story. And these huge fluctuations of government funding have achieved nothing. Now, go to Mariana Mazzucato's work. You won't even find crowding out in the index of her books, which I have read, except in the sense that it's not actually crowding out. She uses crowding out in a very strange way. It's very odd. She addresses none of these systematic points. All she says, I tell you what she says about the Xerox PARC story. What she says is, look, ARPA produced all these great science and all these great scientists, and then magically, she doesn't explain how, Xerox PARC appears, and there's Steve Jobs. What she doesn't do is explain it was because they were all sacked from the government ivory tower that they actually moved into industry. Your other points, by the way, are quite correct. If you want to do non-economic science because you want to look at a rare disease for a few 100,000 people in the middle of Africa, fine. Of course, markets are going to produce that. But it's not going to be a good investment for the American taxpayer. And by the way, there's crowding out in philanthropic money as well. People like Gates have moved hugely into these areas because they felt they were neglected. Burroughs Wellcome, more than once, their charity, have said, we have moved out of the philanthropic sector of medical research because the government's been moving in. That's my long answer to you. And I like very much your jumper. Nice colour.
We've got...
In the beginning of your talk, you mentioned that Germany and France did not catch up with the US and Britain, but Germany industrialized rapidly in about 70 years, kind of quite a bit faster than the US and Britain. Now, granted, it was able to learn from those two countries, but it industrialized rapidly to the extent that it was able to compete quite substantially in World War I by that point. On top of that, Britain and the US had geographic advantages, right? The US has the Pacific and Atlantic Oceans, and then Britain had the Channel, and so they had geographic isolation, which helped them immensely. On top of that, the other two countries that industrialized most rapidly in the 20th century were the Soviet Union and China, both of which, of course, had enormous government funding. On top of that, those are kind of just minor points. I think the major point is that I'm not sure that your talk proved that the government shouldn't fund science, only that the current scientific system is broken, right? So correlation does not equal causation. So we could just as easily say that, okay, maybe it was the introduction of peer review in the 1970s that actually has caused a stagnation in scientific development, right? Which is the same time we started seeing, for example, a degradation in advances in theoretical physics and so on. What do you actually, can you prove that that the government funding of science created this problem? Because we could just as easily say, look at the tokamak reactors in the Soviet Union, look at Sputnik, look at all of these other
Well, first of all, thank you very much for picking the examples of Germany, Russia, and China, because these are the examples I love to dwell on. So Germany had only something like 70% of the GDP of Britain in 1830. What is often forgotten, yeah, they industrialized, yeah, of course they did, but they only had 70% of the GDP per capita of Britain in 1914, which is why we beat the bastards. And in 1939, they only had 70% of the GDP per capita of Britain, which is why we beat them again. It's a... Yeah, we had an empire as well, and they'd overlooked that. But the point is... No. It's a complete myth that Germany industrialized faster than we were industrialization. It's just one of those myths. So it's very easy to find this data. I mean, you could do it in 5 minutes on your computer. There's a program, there's a thing called Our World in Data. Just go to Our World in Data and just ask for British, German, French, Russian GDP per capita from 1800 to the present day, and you'll see the lines, and you'll see that America converges on Britain about 1890 and actually takes over. But France and Germany only start to do that well into the 1960s and 70s, when they're dealing with a completely different world. But in all the 19th century of so-called rapid industrialization, they were not industrializing at any faster rate than we were, and they should have, because they were starting from a lower base. They actually should have been converging. Germany didn't converge. It's one of the great industrial and economic failures of the 20th century. Germany didn't converge. As for Russia and China, if you think so wonderful, why don't you go and live in Russia and China and see how much government funding of science would make your life palatable?
Those are really different. Okay, that's... Sorry, because there's so many...
Yeah, thanks for the interesting talk. I'm not in the field itself, but what about physics? I think if you look at physics.
Oh, physics.
Yeah, so looking at technology sort of since the 50s, it kind of seems like, we've had planes, we're getting better at making planes, we have cars, we're getting better at making cars, but how do then, in the sort of your scenario, do we incentivize sort of real fundamental step changes? For example, in physics, what if we can look deeper into the universe to unlock new technological possibilities? How do you unlock that in the private sector without first sort of challenging the fundamental aspects of the entire field?
Right. Well, one thing to remember is that the private sector, contrary to myth, funds an enormous amount of pure science. On average, 7% of industrial R&D is for pure science. And the reason for that is that pure science is a very profitable investment for industry, because you're employing pure scientists, and they absolutely pull in all the stuff from the outside world, and so you'd actually end up with better products. The price you pay for funding employing these pure scientists is they have to do pure science, otherwise they lose their tacit knowledge. And so industry funds pure science because it's profitable. And a series of studies have shown that the more these companies invest in pure science, the faster their rates of growth and the greater profitability to their shareholders. So you don't have to say, you don't have to argue, why should the government do this? The industry is doing it anyway, which is, of course, why Bell Labs, I mean, everyone in this room knows about the Nobel Prizes won by Bell Labs. I mean, all these... Well, we could argue about the precise nature and status of Bell Labs, but it wasn't a government-funded lab. It was a private enterprise, and yes, it got regulated towards the end, and in the end it got broken up. But it funded a fantastic amount of pure science, not because it was So, for example, take radio astronomy. Radio astronomy is about the purest science you could imagine. What could be, seriously, what could be purer than radio astronomy? It is purely a pure science. Where did it come from? Who was the first radio astronomer? What was he, I'm not being sexist, he just was a man, what was he doing when he invented the science of radio astronomy? He was working for Bell Labs, that you're so rude about. He was working for Bell Labs, laying...
I'm not going to take this accusation, it's great, but it was a state-regulated monopoly.
Well, I actually do differ with that. I mean, it had a fantastic monopolistic power, and the state protected it, but Bell Labs was absolutely in the market. And what this individual was doing when he won his Nobel Prize, he was laying these intercontinental telephone wires, and what he discovered is the longer the wire, the greater the noise. And he couldn't understand where this noise was coming from. It was a complete nightmare. Until it dawned on him one day, the noise was coming from the sky. And he discovered the science of radio astronomy. Background radiation, Big Bang. Who discovered the background radiation of the Big Bang? Bell Labs, about which you're so rude. And Bell Labs has, I think, won 7 Nobel Prizes, and I can't remember how many other people have been associated.
Universities won the rest.
No. You don't. Look, you talk about universities. Let's talk about the Cavendish Lab, the most successful research lab in Britain. Why is it called the Cavendish Lab? I'll tell you, because you probably don't know the story, but I'll tell you. Because there was a duke called Cavendish, and he went to Gladstone, who was then the Prime Minister, and said, Britain should be investing in pure science. The Germans are, the French are, we better catch up with them. And Gladstone said, this is true, by the way, this is not rhetorical, I'm just telling you. He said, you're a duke, you pay for it. And Cavendish said, oh, I didn't think of that. But he was a duke, and he paid for it. And the private funding of these laboratories, such as Cavendish and Cambridge, or the Royal Institution. The Royal Institution, the Braggs, the whole business of electromagnetic induction, all that, Royal Institution, one of the greatest physics labs in the history of the world, totally privately funded. Totally privately funded.
The success of private funding does not imply that government should not fund science.
No, but I'll tell you why it does. Because the government funding of science is theft. It's going to people, innocent people like me, and the taxpayer putting his money in my pocket and stealing my money without my say-so.
That's all tax. Okay, fine.
Taxation is theft.
Okay.
So you have to justify it. And therefore, you can't just say, oh, why shouldn't the government fund science, as if the money comes magically from heaven. It's taking money out of poor people. There are poor people.
This is tax reform now. I mean, I do want to get to this gentleman who has been waiting quite some time.
You have to justify taxes, and no one has justified it because no one has ever established that governments have to fund science, ever. So only Mazzucato's anecdotes.
I will start by trying to be on your side, I think, against everyone before me. So I've been in industry my whole life, like 10 years, and I recently started to work at Wellcome Genome Campus, and there's plenty of institutions that are founded by the government. And I think it's very hard to grasp your point if you're pro-science generally, because it's very hard. It's almost what all the DeSci is about. It's very hard to imagine the alternative, because I'm basically seeing brilliant people who are working on something that I find totally worthless as a person from industry daily. And I cannot even tell them that in a nice way without pointing that you're spending your years of your PhD, postdoc, or whatever. That's pretty pointless because you're creating a paper no one will ever read and will not be applicable for next 20 years. But the thing is, they don't even see alternative. And the moment they are some startups, movements in Cambridge to bring those people out of the campus to the private sector. And the moment those people realize they could actually apply their science or the thinking or the knowledge is pretty revelational for them, because it was just, the alternative is so unimaginable, because everything, all the science is funded by the government, that it's almost eye-opening for some of them. So that's kind of my first part, that I'm kind of agreeing with you, which I think I'm the first one. The second one is that maybe kind of is a compromise between, because I've heard a proposition that in a history of American science, when Americans moved to the New World and they had no nobility of British, they had no one to be a policymaker, because they didn't have like aristocratic elite that was raised to be policymakers. So they decided, okay, let's take all the smart people at universities and give them policymaking powers, which worked brilliantly in the beginnings, and I think most of us can agree that Enlightenment virtues of truth-seeking worked out pretty well to make decisions for society. But the argument goes that at some point, once you give more and more policy-making powers to the scientists, you basically create incentive structures that are becoming more and more corrupt and are basically making scientists not follow the truth, original, basic science truth-seeking mission, and it's basically making them almost semi-politician, driven by grants and whatever leads to a PhD career, rather than actually seeking science. Because at some point when you have, so that's the controversial part, but when you have a climate change science, when it dictates 2% of GDP of the world, it's really hard to pursue science when everyone is dependent and everyone's careers depend on it. So there's more and more incentives to just produce more papers, and harder to actually distinguish science.
Your history of American colonial history under the British and after the Revolution, with respect, it's just wrong. What's extraordinary about the colonies is how democratic they are from day one. There was the Atlantic Charter, even before the Mayflower had arrived, the Mayflower Charter, sorry, even before the Mayflower had arrived in America in 1620, they'd already drawn up their little constitution of democracy. So what the Americans took with them to America from Britain and from the Dutch, by the way, the Dutch very similar, this tremendous tradition of democracy. Yes, there were very early universities, Harvard 1639 or something, but Harvard was only a religious training college in Massachusetts. It had no great power. No, it's democracy that made America work on the Dutch or British model. Everything else you said we can talk about, but there's no need. You haven't said anything I particularly want to disagree with, except you're absolutely right. On the subject of the corruption of science, there's a great man called Daniel Sarowitz, and he wrote a book called, he wrote an article called Saving Science about 10 years ago. And he believes in the government funding of science, so you all love him. He believes in the government funding of science, but what he said was the linear model doesn't work. The model of peer review, chums giving money to chums, making sure they all say the right things, doesn't work. It should be what's called mission research. And an example of that is Manhattan Project. Manhattan Project, huge piece of science, but there was a very clear mission to kill lots of people in Japan. And when governments fund mission research, there's a fantastic track record. It often works very, very well. What fails and causes the corruption of the reproducibility crisis that you've talked about is this whole business of peer review, by which a group of peers capture these funding bodies, they capture the editorial boards of the journals, and they capture the university promotions committees, and they make damn sure that only people who say the right thing get promoted. I wrote a book called Breakfast is a Dangerous Meal, and the reason I wrote that book was I was looking for the world's oldest scientific myth, which was the scientific myth that professional scientists bought into that was transparently nonsense. And it was clearly breakfast is the most important meal of the day, which we should eat like kings. I looked, and this was just not a random selection, I just looked at the 200 most cited papers in breakfast in the year I was reading and doing this book. Of the 200 papers, one, written interestingly by a philosopher, God knows what he was doing, one said, it's obviously nonsense. Of the other 199, only one was actually fraudulent. I could see where they'd cheated. The other 198, the scientists had fooled themselves. They wanted to believe that breakfast were, because that's where the money was, that's where the grants were, and that's where the publications were. And I can tell you, breakfast is a neo-fascist tyranny. If you try to publish a paper saying that breakfast is not the most important meal of the day, you will wish it was Putin knocking on your door and not the Regis Professor of Nutrition at Harvard. And that's why Max Planck said that science advances funeral by funeral. Why did he say that science advances funeral by funeral? Because these bodies get captured, and you have to wait for the buggers to die before you can start to let new ideas in. And peer review from the government makes it so much worse.
Just to quickly point out before I pass over to this gentleman, but you just said that the Manhattan Project, which was government funded, produced fantastic science.
Fantastic.
And now, right, so what's wrong with that? Because what's wrong with having mission-driven science? No one disagrees with that, and I think that's how you get science out into the world, no?
Mission science is great, but that's not what people believe in. When they say government should fund science, they're talking like that gentleman over there about universities, about the NSF, about the NIH. People, when they talk about the government funding of science, are not thinking about blowing people up in the Arizona desert. They're thinking about all the science labs in the universities. That's what they mean by the government funding of science, and that simply doesn't work economically. It just takes the best scientists out of industry. Mission research, of course. But mission research has been funded by the American government from before 1800. You know, you had Marines and you had lighthouses and things, and those people needed research, and that was absolutely fine. Mission research is fine. But no one pretends that's about economic growth. No one thought the Manhattan Project was going to make America richer. It was a mission. Mission research is not about making money. The whole point of the linear model, pure science, this is a myth, pure science leads to applied science, which leads to economic growth. That's what people mean by the government funding of science, because and that simply doesn't work. It may make all your lives richer because you personally do very well by it. And there was a man who said, it was that American writer to come back to me, nothing is harder than to drum into the head of a man an idea that is not his in economic interest or something. You will probably as a literary person here. Thank you, it was Upton Sinclair. You're absolutely right. You're right. I'm sorry?
I agree with you about breakfast.
So it's very hard if you do well out of the government funding of science to realize that you are in fact an evil leech, but that's the reality.
Sir, are you not employed by a university?
What did she say?
Are you not employed by a university?
I'm retired. But if you'd heard your own introduction, which university did I move to? Buckingham, which is the only university in Britain not funded by the state. Oh, Buckingham, funny that. I have lived my beliefs by working in the one university in Britain that doesn't leech off the taxpayer. Thank you.
I just want to get your view very, very quick.
Okay.
Outside the room, because we've got to lock up the room within 10 minutes. So you can continue the debate.
Guys, go to bar
That's
190.
all right.
Bar 190, there's alcohol.
I'll take the receiver as well.
Thank you very much.
Sorry, I got all ratchet.